course by Intellipaat. Today in this video, we will learn end-to-end on how you can become a DevOps engineer. Well, the first question that you should have in your mind is, why should you learn DevOps? Well, according to Forbes, DevOps and cloud are the top 5 most in-demand skills in the IT industry for the year 2024. If you look at LinkedIn, there are 28,000 plus jobs available for DevOps profile in India, while in US the number is 51,000 plus. Watch this DevOps full course till the end because we have also covered the most asked interview questions of DevOps in 2024. Now before we move ahead, be sure to subscribe to the Intellipaat YouTube channel and click on the bell icon to never miss out on any updates from us. Now let's go through the topics we will be covering in this video. First, we will start with what is software development and then move on to discuss what is DevOps. After that, you'll get introduced to what is Git and then move on to discuss how you can do build management using Maven. After that, we will be covering how you can do containerization using Docker, followed by how you can deploy microservices in Kubernetes. After that, we will be covering Jenkins to deploy a CI/CD pipeline and then see how the same microservices architecture that you deployed before can also be deployed using Jenkins and Kubernetes. After that, we will be learning infrastructure as a code using Terraform. And finally, we will be covering the most asked DevOps interview questions in 2024, which can be asked to you in your next job interview. Alright guys, so with this, we are done with the agenda. I hope the video is clear to you. Now let's go ahead and start off with the first topic, which is what is software development.
Hello everyone, welcome back to this session on DevOps certification training. So our topic for today is what is software development. So let's start with this topic now. So what is software development exactly? Now, software development is the process of transforming customer requirements into a complete software product, right? So basically, a customer would come into your company, he would lay down the requirements, and the process of converting those requirements into a complete software product is what is known as software development. Now, obviously, there's a process which is followed for the software development. And so let's see what that process is exactly. All right. So the whole process of the software development is basically divided among these 5 stages. Now, what are these 5 stages? The first stage is about the requirements gathering. The second stage is about designing. Designing basically deals with converting the requirements into specifications. Then we have implementation, wherein we basically implement the specifications that we draw out from the requirements. Then we have verification to basically understand what we have developed in the product or what we have developed in the software. Is it matching with the requirements of what the customers said initially? And towards the end, we then do maintenance. That is, any version patches, any bugs that were there in the earlier release. If we have to fix that, we do that in the maintenance phase. Now, let us look at all these phases particularly, or let us look at all these phases one by one. Right. So the first stage, like I said, is the requirements phase. Now, what happens in the requirements phases? Say a customer comes into your company and he meets the architect of the company and he says that, I want these and these features in my software. For example, say he's from the HR background and he basically wants an HR software up and running. So he would specify the requirements. He would say he wants an attendance page. He wants to create a page for leaves. He wants to monitor the clock in and clock out time, etc. and etc. Right? So these are all the requirements which he gives to the architect. Now, the architect would be a person who basically can bridge the gap between the customer and the developers in the company. Right? So this was the requirements phase. The architect would basically take the requirements from the customer. The next phase is the design phase. Now, this design phase is also implemented by the architect of the company. So what he does is he basically either with the help of his subordinates that is basically some other architects in a company or by himself, he would basically design the specification for the software, technical specification of the software based on the requirements given by the customer. Right? And these specifications would be basically like and like what all parameters should be there in the software, how many functions do we need in the software, how many classes do we need in the software, etc., right? And this all is written down in a documentation, and then it's made available to the developers, right? Now the developers are the people who would be implementing this particular specifications which are given by the architect, right? So developers, they get a straightforward job, they know exactly what has to be done, and the architect makes sure that the work is divided among people, the people who specialize in their own territory, right? And though that particular work from that specification is given to that particular developer or a group of developers, right? So this is implementation phase. Now the developers would see the specifications, they would create the software product, right? And then the software product would be joined together or would be clubbed together and will come up to be one particular suite, right? Once the software has been developed and before sending it to the customer, now the next phase is testing or verification. Now we check, now the architect checks what all requirements were specified by the customer, are they being fulfilled by the software, right? Now obviously the functional checking is done by the testers. They check all the functions, are the functions working properly according to the specifications which were given by the architect, and towards the end the architect checks whether the requirements specified by the customer are being fulfilled by the software that we have developed, right? So this is the verification phase, and then we have the maintenance phase. So once the software goes out to the customer and then he's using it, obviously there could be some additional features that the customer might require or might come up in the future, right? So all that comes in the maintenance phase, as well as any bug fixes. Now see, no software is perfect in this world, right? There are bound to be bugs. Even the OS, the Mac OS or the Windows that we use, they all have bugs, right? And they are fixed incrementally. You might have seen that you get Windows updates frequently, you get your phone updates frequently, and if you read the specification of those updates, it specifies as fixed major bugs or fixed minor bugs or updated the security patch. Similarly, for every software, this kind of a life cycle is followed. And this life cycle is followed in the maintenance phase, wherein you regularly roll out any security patches, any bug fixes, etc. Right? So this was the life cycle of software development, guys. Now there are a lot of models which are implemented for basically the software development. Now we discussed the process of software development lifecycle, right? Now this process can be implemented in a number of ways, and we have three models particularly which were followed back, I guess, 5 or 6 years or 10 years, right? And the first model which came up was the waterfall model, right? Then we had the agile model, which basically solved some problems of the waterfall model, and then we had the lean model, which again solved some problem of the agile and waterfall model. All right, so traditionally, like the slide says, there were three models which were followed in the industry. There were actually more models as well, but these three models were the most prevalent in the industry while software was developed back in the days of 1980s and 1990s, right? So in our further sessions, we'll be talking about waterfall, agile, and lean, and our next session is going to talk about waterfall model particularly. Hello everyone, welcome back to this course. So today in this session, we are going to discuss why did we exactly need DevOps, right? So in our earlier sessions, we saw that the problem was almost solved. The problem was solved between the customers and the companies with the help of agile and lean methodologies. So why did we need to come up with DevOps? So let us go ahead and see what problems DevOps is actually solving. So guys, we did solve the problem between customers and the software company, but there were still some problems inside the software companies as well, right? And what was that problem? So in any tech company, in any tech team, you have two teams which basically contribute to a release of a software. The first team is called the development team, and the second team is called the operations team. Right? Now, what is development team and what is the operations team? A developer is basically a person who develops the code, right? He would develop the code, and the code would then be forwarded to the operations guy, whose job is to basically test the code and put it on the testing server or the production server based on the requirement, right? Now, what was the problem here? The problem was when the developer developed the code and he forwarded it to the operations guy, the operations guy's system could not run the code which the developer has forwarded, right? So obviously the developer would have tested the code that he is sending on his system first, and only then he's sending, right? On successful operation on his system, he will only forward the code to somebody else who wants to test it, right? But it did not run on the operation system guy. It could be the problem of environment, it could be the problem that he has not installed everything which is required by the software. So he used to push it back to the developer saying, your code is not running on my system, please check your code, it is faulty, right? But now the developer was furious, it ran fine on his system. And if that operations guy is not installing something properly, it's not his problem, right? It's not his job to go ahead and fix his system and then run the code, because his job is to run or develop the code which he is doing, and the code is running fine on his system, right? So it's the operations guy problem that he's not able to run it on his system, right? So these were some of the problems that were between the developers and the operations guy, and this was solved later. But before that, there was a lot of problem in team communication, and it solved and it caused a lot of inefficiency in the team, right? When we talk about lean methodology, we were talking about faster release cycles, eliminating waste, but this was a waste that we were not able to eliminate using lean methodology, right? And this was solved using DevOps, right? Now the DevOps is what is DevOps exactly? It is not a tool, it is not a software suite. It's basically an idea, it's basically a thinking, and this thinking is obviously implemented using some tools. But right now, if you were to talk about DevOps, like I said, it's just an idea of of working in a certain way that could solve the problem that we were facing between the development and the operations team. So if you were to draw some differences between what we were doing earlier when we were working without DevOps and what happens when we use DevOps, is that the traditional IT system was less productive, although it was very productive, as we saw in lean methodology, where we have eliminated everything, we have tried everything in our hands to solve it using the planning part. But there was still some room of inefficiency that we could not solve using planning, and that was solved using DevOps. So DevOps was more productive than traditional IT, right? Then in traditional IT, we had a skill-centric team, right? Each team was skilled in a particular territory, and we had a lot of teams in our organization which used to work on different things. Now in DevOps, what we do is the smaller teams are also specialized in different domains based on the silos, right? Based on the technology. So rather than having 4 people who are equipped or who are skill centric in one particular technology, in DevOps, we had each person who was skill centric in a technology, right? So probably one person would know Kubernetes, the other person would know DevOps better, the other person would know Git better, the other person could know some other technology better. So we had silos like this, right? In traditional IT, we used to invest more time in planning. So when I talk about traditional IT, I'm talking about Waterfall, Agile, Lean, both collectively, right? So there was still some planning involved when we talk about traditional IT. In DevOps, we are basically saying we do smaller and frequent release cycles, right? So we do smaller and frequent release cycles, as we saw by the end of lean and agile methodology, that we are doing smaller release cycles. DevOps take the advantage of those methodologies and implements it in its own model as well, that we have smaller and frequent releases, but they're still smaller than what we were seeing in lean and agile methodologies. How is it? We are going to discuss it in the future. So DevOps still shortens the release cycle by the help of automation. It's a release cycles, and hence releases software in even lesser days than, or lesser weeks than we had in traditional IT. If we talk about DevOps, guys, I would like to give you a fact that using DevOps methodology, you can have release cycles in a day rather than weeks or months. So every day there could be a release if you're using DevOps methodology to the fullest. Okay, so this was again a good thing. In traditional IT, when we were using waterfall model, for example, it was difficult to achieve a target or goal because the goal was set 1 year later, right? So there was a difficulty in doing that. Reason being, we could not foresee future, right? There could be some more problems that could be there while we are working on a project, but everything cannot be planned in advance. But in DevOps, because we are doing shorter release cycles, it is not that difficult to achieve a target or goal. It is easier to set objectives for a day than to set objectives for an year what you're going to do, right? And that is why DevOps makes it easy for us or for your employees to achieve their goals or their targets. Okay, so this was basically the difference between what we had in the past, probably when we were using waterfall methodologies in the past, and what is the present, what we are able to currently achieve using the DevOps methodology. All right. So, guys, these are the differences. Now, our next topic is what is DevOps, and that is what we are going to cover in our next session. All right. So, guys, see you in the next session. Good. Have a good day. Goodbye. Hello, everyone. Welcome back to this session and DevOps training. Today, in this session, we are going to discuss what is DevOps. All right. So, without wasting any time, let's go ahead and start with this session. So, guys, like I told you guys earlier, DevOps is nothing but a methodology. It is an idea, right? It is not a tool, it is not a software, it's an idea or methodology of solving the problems between developer and operations guys, right? Now, this methodology involves a life cycle, which, as you can see in the diagram, that the first thing that you do is you plan what you have to do, right? Then you code your way in, then you build the code. Building the code means if you have a Java file, for example, you'll have to create a jar file or an executable file out of that. So that is called building, right? So building your code, and then you will be testing your code. So what executable you have built, you'll basically test that code for any faults in the functionalities. And if there are no faults, you'll basically release the code to the ops team. Now there are two kinds of release, guys. There's an internal release and there's an external release, right? The internal release talks about releasing the software to a different team of the company, and this is what exactly is happening. Then comes the release phase where the developer guys release the software to the operation guys for their work, right? The operations guy will in turn deploy the software onto the target system. It could be a testing server which basically will test or do automated test on it, or it could be the production server where everything has happened, the testing has happened, and you're deploying it on the production server, right? So once you have deployed it, of course, now becomes the operation phase. The operation phase can be done internally, or it could be done by your customers, wherein you're operating the software, or you release the software for internal employees to see whether the traffic, when is it doing good when it holds, when it's getting traffic onto it, is it doing good when normal people are doing arbitrary tasks on your software. And then you are also continuously monitoring it to see if your task is or your application is functioning properly, and if it is not functioning properly, you're basically creating a log of events which are happening, right? Which this is called monitoring. And after monitoring again comes the planning phase, which means if you get any kind of feedback from the monitoring part, you again start planning it, how to do it, how to solve this kind of a problem that you're getting in the monitoring phase, and then code your way in, build the code, again test it, again release it to the ops guy, and this goes on and on until you get the perfect application. And there is no perfect application, guys, right? Always there will be new requirements coming in, always there will be some bugs, always there will be some security patches, and therefore this life cycle goes on and on. So this is what DevOps is, guys, right? And if you were to think about it, how is it solving the problem between the dev and the ops guys is by automating this life cycle. Basically, that means that now the developer does not have to give the code to the ops guy. It will basically be given through a tool which we have, so there is a tool called Docker, right? So basically the dev guy will enclose his code inside Docker and will push it to the ops team, and the ops team just have to run Docker and this code will run fine, right? There is no problem for dependency, there is no problem for configuration management. Everything happens automatically in this life cycle. So don't worry if you don't understand exactly what DevOps is, because in our next slides we are going to discuss how it actually works, right? So going forward, now let's discuss how the DevOps life cycle actually works, right? So if you were to that infinity sign that we had, it if you were to condense it, or if you want to expand it, so that DevOps lifecycle diagram that we had, the infinity diagram that we had, if you were to expand it, it would look something like this, right? So you have something called as planning, you have something called as coding, building, and testing. Now this used to happen on the developers side, right? And then we go on to the ops side, where we have release, we have deploy, you have operate, and then you have monitor, right? So in between this, we have to integrate this part of the developers side to this side of the operator side, and this is done using continuous integration. Now what is continuous integration, we'll discuss in a while, but for integrating the developer and the operations guys, we use continuous integration, right? Now before moving on to what is continuous integration, let's pay attention to what we have over here as well, right? So the planning and coding phase, we contribute, or we collectively call it as continuous development. What is continuous development? I'll explain you in a little while. Building and testing, we call it continuous testing, okay? Releasing and deploying, we call it continuous deployment. Operation and monitoring, we call it continuous monitoring, okay? So you start with planning, you do coding, you build it, you test it, you then release it to the ops team, then you deploy it, then you operate it, and then you monitor it. And this gives rise to 5 stages, that is continuous development, continuous testing, continuous integration, continuous deployment, continuous monitoring, which again goes back to continuous development. Now let's understand these terms. Let's understand what is continuous development, testing, deployment, monitoring, and integration. Okay, so this is the life cycle, guys. Now, why are we calling it continuous? Continuous basically means it goes on and on, right? It never stops. So like I told you in the diagram for DevOps, that the cycle goes on and on. It never stops. The product is always being developed, right? It is always in some part of the life cycle. So if you were to explain continuous development and continuous integration, continuous testing, this is the best way to learn it. Okay, so we have a developer who basically will be pushing his code to a version control system. Okay, and this version control system will basically, any changes in this version control system will be taken up by a continuous integration tool. Okay, so what is a continuous integration tool? A continuous integration tool does nothing but it joins each of these stages to each other. For example, if I have to go from continuous development to continuous testing, and if this happens in separate softwares, continuous integration will join these and this, right? Continuous integration will join testing and then deployment. Continuous integration will join monitoring and then again coming back to development. And how does this happen? It happens like this. So there is a software which basically does continuous integration. Okay, let's understand just this as a black box. This is a software which does continuous integration, and the function for this particular software is the moment you push your code to a version control system. This version control system is nothing but a software which takes care of storing your code. Okay, so the moment you push your code to a version control system, or you change your code in the version control system, the continuous integration tool automatically identifies, okay, so there's a change in the version control system. So what it does is it takes this code and it builds it on the testing server. It first builds it and tests it on the on the testing server, and this is called continuous testing. Reason being, every developer who does this, continuous integration does the job similarly, right? So if there are 100 developers in the team, so for every developer, if we configure a version control system, that for every developer it has to test the code, it will always do that. Okay, so every developer who's doing a version control, who's pushing his code to version control system, continuous integration software is going to test their code on the testing server, right? And this is the reason it's called continuous, right? Because it happens continuously. Okay, so continuous development, we push our code to version control system. It is identified by the continuous integration tool. So the first job that continuous integration tool does is it pushes onto the testing server the code where it is built and tested, and if the test succeeds, continuous integration tool pushes it on the production server. Okay, Now, either if it's on the production server or if it's on the testing server. Now, if on the testing server there are some bugs which are identified, the feedback is given through continuous monitoring to the developer. Or if the production server, if there are some problems on the production server, or like I said, when you deploy your code on the production server, it basically gets available to the world and it gets continuously monitored, right? For any kind of problems which are occurring, it gets continuously monitored and the logs are generated, and these logs are being stored somewhere using continuous monitoring. So your production server is continuously monitored for any kind of activity which is happening on it, and the logs are being generated. Now, the developers, the team. Now, when I go back to the developer, why am I coming back over here? Because this identifies, or this tells us basically now that now when the development team is done with the release and now they have to see what other work I have to do, all they have to do is check the logs from the continuous monitoring tool, right? And they'll be able to identify, so okay, so this and this is causing a problem, this and this is causing a problem. And also the users are saying that, we should have this feature. The client also came in, he also wants some features, so they plan a release, right? And once they plan a release, they again start coding, and again once they're done with the code, they'll push the code to version control system, which will be identified by the continuous integration tool, which will then automatically test it. Once it's been tested, if it's successful, it will push to the production server. Again, the logs will be identified by the continuous monitoring stage. Again, it will go to the developer after planning, and then he'll code his way into version control system, and the life cycle goes on and on, right? So this is exactly how DevOps work, right? Now let's look at each of these stages independently to understand what exactly happens in continuous development, what exactly happens in continuous integration. Okay, so in continuous development, you basically push your code to a version control system. The version control system could be a software like Git or a software like SVN. Right now, when the moment you push your code to the version control system, it basically creates a new version of your code. For example, if you wrote ABC on a text file, right? Now that ABC you wrote and you upload it on the version control system. So this was the first version. The version control system automatically makes it version 1. The moment you make some changes and again push it to the version control system, what happens is it creates the version 1 was the text file having ABC. Now the new version that you have pushed, it becomes version 2 and the file would be ABC and probably whatever changes you have made to the file. Okay, so it creates a new version, and at the same time it also holds on to the previous version, so that in any case, in any problems that you might have in the future, if you want to revert back to the previous version, you can easily do that, right? And that is why we have version control systems like Git and SVN, and continuous development is an integral part of pushing code to your version control system. Okay, now this was continuous development. Then you have continuous integration. Now what is continuous integration? This is nothing but integrating your life cycles with each other, right? For example, once you push the code to your version control system, it obviously has to be picked up and pushed onto the testing server for testing, where it could be built and tested, right? So all these life cycles are integrated, or there is someone who is doing the manual job of a person of taking code from one stage and pushing it onto another, then taking the results from there, pushing it onto another, then taking the results from there, pushing onto another. And that manual effort is being done by a tool which is called the continuous integration tool. Okay, then you have continuous deployment. Continuous deployment basically means you will deploy your code onto a particular server. It could be a testing server, it could be a production server, and deployment basically involves putting the right kind of software on it and then pushing the build onto your server so that it has the right software environment where it will function, right? And again, installing softwares and system and everything is also automated using a tool which is used in continuous development lifecycle. Okay, then we move to continuous testing. Now continuous testing is again a life cycle stage wherein you continuously test your software. So like I told you guys, in this what happens is you continuously build and then test your code. So your code is pulled from the version control system. It is built. So when I say built, it basically is converted to an executable file, and this executable file is then run, right? Now the continuous testing, how it happens is you create testing suites which are basically pre-installed in the testing server, and the moment it gets a new executable, all those test suites are executed on this particular executable file to check if all the tests are passed or not, right? And if all the tests are passed, it is then again picked up by the continuous integration tool and then pushed onto the production server. Once it reaches the production server, again it gets monitored, right? It gets monitored for user activity, it gets monitored for any errors, it gets monitored for any user comments on version upgrades, right? On version upgrades, or you can say any feature requests. So all those feature requests, all those errors, all those logs are then visualized or then are then stored inside a monitoring tool, right? And this monitoring tool helps us in sorting these logs based on what we wanted. It'll basically sort it on the basis of general logs, it'll sort it on the basis of error logs, it'll sort it on the basis of feature requests, right? So it becomes a one destination stop for you where you can check and plan your day ahead or plan your team's work for the near future. Okay, so this is continuous monitoring. So these were all the life cycle stages of DevOps, guys, and this life cycle stages basically make it possible for us to have shorter release cycles because all these stages are automated, right? And these are automated using tools, and these tools we'll be discussing in our next session, where we will get an introduction to all the tools which basically come together to create a DevOps. So in our next session, we are going to talk about DevOps tools, guys. So this brings us to the end of this session. So have a great day ahead and goodbye. Hello everyone, welcome back to this session on DevOps training. Today in this session, we are going to discuss the DevOps tools that will help us implement the DevOps lifecycle. Right? So far we have discussed the DevOps methodology, how the DevOps lifecycle work, but they are incomplete without their respective tools, which will map to each of the lifecycle stage in the DevOps lifecycle. Okay, so let's go ahead and start discussing these tools with their respective stages. So the first stage that we saw was continuous development. Now, continuous development is implemented using version control systems, like I told you guys. And in most of the companies, the most used version control tool is Git. All right. So Git is a version control system which we'll be also using in this course, right? And it is basically used when multiple people are working on one particular project. Right, so it is great for team collaboration. It is great for tracking changes, and is absolutely awesome on command line. All right, so this is what we are going to learn in this course. So for Git maps to the continuous development lifecycle stage, then we have continuous integration. Now, you heard a lot about this continuous integration tool when we were discussing in the DevOps lifecycle, and the tool is called Jenkins, right? So Jenkins is basically an open source tool, right, which is used to implement the continuous integration features that we saw in the DevOps lifecycle. So in this course, we'll be learning Jenkins, and there is a separate module on Jenkins that we'll totally devote to explain different features that you can explore in Jenkins, right? The next stage is continuous deployment. And continuous deployment basically means two things. It means configuration management, and it means virtualization and containerization. So we use Docker for virtualization and containerization. And what exactly Docker does is, so the problem of running your code on one system and not being able to run on another system is what is solved using containerization. So what containerization basically does is, it wraps your code along with the software dependencies, and all these software dependencies and code is wrapped around by a container, right? So a container is a physical entity which will basically wrap your software dependencies and your software, and it will, if you run that container on any other system, it will run as if it is running on the same system that is on the developer's computer. So a container is an executable form of an operating system which can be run on any system. The only pre-requirement is that you should have Docker installed on it, right? Similarly, you have configuration management. Now, configuration management, what is configuration management exactly? So say you have a computer, you have a freshly set up computer on which you have some operating system installed. Now, if you want to test your application on that system, what you have to do is you first have to install all the softwares on it. Right. For example, like I said, you would need Docker for your container to run. You probably would need an Apache server. You would need Python. All these softwares which have to be installed can be installed using configuration management without even touching that remote computer or that freshly set up computer. And that is possible using tools like Puppet and Ansible, more of which we will be seeing in our course as we progress in our number of modules. All right. Our next stage is continuous testing. Now, continuous testing, as we learned, was all about creating testing suites which would automatically test your code once it gets built on your system, right? So all these automation testing suites can be created using the Selenium software, right? So we will be learning the Selenium WebDriver in this course as we move along, and we will see how we can create our automation suites in Selenium for testing our applications. Okay, so this was about continuous testing, and then next we have continuous monitoring, wherein your application is continuously monitored and the logs are created. Any errors are also monitored, right? So all of that is done using Nagios. So Nagios basically gives you a dashboard with all your services listed on it, and those services can exist on any system outside the network or inside the network, and all these services running on it can be seen on the Nagios dashboard. Okay, so it's a great tool for monitoring your application. It's a great tool for gathering user data or user activity data at a one-stop destination. Okay, so that is what Nagios is all about. And this brings us to all the tools. So these were all the tools that we will be discussing throughout the course, right? And this brings us to the DevOps tools lifecycle. So you saw the DevOps lifecycle earlier, wherein you had a developer and the developer was basically pushing code onto a version control system. This is a replica of that figure. And in this figure, we have just replaced the tools with the life cycles. All right. So now what the developer does is he pushes his code to GitHub. From GitHub, Jenkins automatically detects that, on GitHub, your code has been changed. It pulls the code and pushes it onto the testing server, and it installs all the softwares required on the testing server, and the testing suite that has been built on the Selenium is already present on that testing server, right? So Jenkins pushes the code here, the code is built and tested over here. If it goes successful, Jenkins again pushes the code to production, right? And on the production server, Nagios continuously monitors it for user activity, how many users are logged on, what the users are saying about it. All of that information is saved inside Nagios, and that information can actually be seen on the Nagios dashboard by the development team, and they can make a plan for the next release, what all features they have to include, what all fixes they have to do, right? And once you do that, you again start on with your next release. So this is what you do when you are working with the DevOps tools, and this portrays the whole DevOps lifecycle that we have in a company, in any arbitrary company which is using DevOps. All right. So guys, this brings us to the end of our module 1. So I hope you guys learned something out of this module. So it was a theoretical session for us, this whole module. It was a theoretical journey, but I'm sure you must have gotten an actual idea about how DevOps actually works, right? More of DevOps you will be learning when you will be actually practicing it, and that will be pertaining to all the hands-on sessions that we'll be doing in our further modules. All right. So I hope you guys have learned something about DevOps from this module. So there is a quiz section after in this module section. I would request you guys to just go through that quiz and see if you can answer that. And if you can, then I guess you are good to go to module 2. All right. So thank you guys for attending today's session. Have a great day ahead and goodbye.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
So let's get started. So I think we have enough people to get started with. So first of all, version is what? First of all, version are like you must in your laptop. Sometimes what you do, you create a file, you write some content in the file, okay, and later on you go and edit it. So sometimes you edit in the same file, and editing in the same file replaces the file, right? But many times what you do, you create a new file out of it. You can save as some other file. Okay, new folder 1.pl, new file 1.txt, something like that. You save it as a different name. So what is that? That means you are not deleting the existing file. Your original file is there, but you are creating a new file with a different name. That means you want to keep the old version also. And why do we need old version? In the future you might need it. You think that instead of deleting the original file, what I'll do, I'll create a backup of this old file and I'll create a new file with some additional content. So exactly that is what versioning. Version means having multiple versions or multiple copies of your file so that you can see what were the changes you did in the new file, or in the later stages if you want to bring it back, you can always switch back to the old version. If you want to see what was in the previous file, what content was in the old file, so you can bring it back. So versioning is, that's what version is. Now we have seen that in a project there is only not a single person. There are many people working in the project, right? There are many people working in the project. There are many developers. Now, if there are many developers, everyone is writing a code. The work that is coming is equally distributed among people. Some, let's say it's a e-commerce. Let's say it's an e-commerce website. Okay, some developers will be working on login page. Some developers will be working on items page. Some developers will be working on customers page. Some developers will be working on payments page. Some developers will be working on different functionality. Now, since everyone is working, they're writing their code, so there should be a place to manage. There should be something to manage their code and to maintain the versions of the code. Okay, for example, let's talk about if there is no version control happening. If there is no tool, if we are not using any tool for version control. So what would happen in that case? What would happen in that case? Let me draw something. Okay, see, now let's say I'm the person, I wrote the code. Okay, this is me. Okay, I'm the person who wrote the code. I started writing the code. Okay, I wrote some content in my file. Okay, it can be anything, and I read the code, and this code is in version 1. Let's say this code is in version 1. I call it V1. Okay, I got it V1 of the code, version 1 of the code, and I deployed this code in some environment on production server. I deployed this code. Okay, this is V1 of the code I deployed here. Now imagine 3 new people came to work with me in my company. Okay, 3 new people came in to work with me in my company. Okay, person 1, person 2, person 3. Or imagine give them some name. Okay, let's give them name. So let's say this is Anmol, this is Vani. Okay, and this is, let's take some more name, Praveen. Okay, this is Praveen. Okay, these are three people who started work, who joined my company. Now I want them to work on this code as well. Okay, I want these people to work on this code as well. So what I'll do, I'll give this code to everyone. Okay, I'll give this code to everyone to work. So now I gave this code to them. So this was E1. Okay, now right now my code is in version 1. This is the first copy of the code, first version of the code that I've written, and I gave them to work. Okay, now what will they do? They will start working on the code. Okay, let's say first Anmol started working on the code. Okay, he added few lines here, he added some extra lines here, and the code became V2. Okay, he created a version 2 of the code. Then what he would do, he would give that code to me. Now what I'll do, I have V1, I have deployed V1 on this production environment. Okay, so there were some additional lines in his code. So what I did, I took some extra lines from his code, and I merged it in this code. Okay, the extra lines which Anmol had written. So I had the V1. So I merged his code in my code, and this was finally became V3. Imagine this became version 3 because this was new code, right? On my code V1, I have merged the changes from, or you can say I can take the same file, okay? Because there are no changes. So I'll replace my file, maybe. I might replace my file with what Anmol has given me. Okay. Now imagine. Now what I'll do, I'll deploy version 2 in production. Okay, so production is having version 2 now. Now next day, Vani came to me, and Vani wrote some of her own code. Okay, Vani wrote some of her own code. She added some extra lines to version 1. She was having V1. Now she added some extra lines to V1 and became, let's call it version 3. Okay, let's call it version 3. Now she gave this code to me. Now the code which I am having is the code coming from Anmol. Okay, Anmol gave me V2. So right now I have V2. Now Vani has worked on version 1, and she has added some extra lines in version 1 and became version 3. Now how will I merge her code to my code? I will do it manually, right? I will see that what extra lines Vani had added in version 1. I'll compare it with what I have in version 2. Then I will add those extra lines, and then I'll deploy to V3. Then I'll deploy to production become V3. Then Praveen is also writing a code. He is also working on V1. Okay, he will also create version 4. Let's say so here read version 3. Okay, it will version 4 now. Okay, here the version become version 4. I hope you understand, because right earlier the version that was with me was version 3. So I added some lines from Vani, and it became version 4, and I deployed version 4 here. I deployed version 4 here. So right now production has version 4. Then on the third day, Praveen came in. He was working on version 1, and he had also done some changes to version 1. Okay, now I have to bring, and he created version 5, let's say. Now Praveen gives this code to me. So I again had to take some additional things that Praveen has done on top of version 1, and that changes I have to bring it to the version 4 file which I'm having. Okay, Then this becomes version 6, and I'll deploy this version 6 to go to production. So this is a lot of manual process, right? This is not a manual process. Imagine, eh, here I have given an example of just 3 developers. Imagine there are 20, 30 developers in the team. This process is going to be very complex. Yes or no? This process will become very complex, right? Right now, I'm not using any code. I'm not using any tool. Okay, right now I'm not using versioning. I'm not using tool. This is without versioning because I want to tell you the importance of versioning. This process is going to be very complex for me. For me, I'm going to have a nightmare. How to do this? If 20 developers are there, I'll keep on finding the differences between them. You know, this will involve a lot of complexity. So to avoid this process, to improve this process, a lot of tools came in the market. Those tools are called source code management or version control systems. SCM tools or version control systems, whatever you call. These two words are used interchangeably. So basically, there are two types of tools. There are two types of source code management and version control systems available in the market. So one is centralized and other is distributed. Centralized and distributed. Now, what is the difference between centralized and distributed? Now we have understood what is the need for a source code management. Need for source code management is to ease out this process, ease out the process of versioning. Because versioning anyways we need. Versioning anyways we need because there are many people working on same set of files, and tomorrow if they make a change, I should be in a position to track who has done what change, when did he do this change. I should be able to in a position to track. Let's say now, right now in production, version 6 is deployed. Let's say anytime I want to go back to version 2, I see that version 6 is not running fine. So I might need to roll it back to version 5. I might need to roll it back to previous version or some older versions. So I should have those in my. I should have those versions, right? Only then I'll be. What if I keep on replacing? What if I keep on replacing all the content in my file? That means I'm not having the version. So different versions have to be created for this purpose. Can all merges happen in the same time? How do we know if there are any changes in the code? Yeah, so that's where your source code management and version control is going. Okay, here it was everything manual. So that's why a lot of source code management and version control tools were created. I'm more saying how is it different from bucket versioning in AWS? There also versioning is happening. There also versioning is following the same principle. There are also multiple copies of objects are getting stored in S3. Okay. Again, Anmol, that is more on AWS. So you'll get to know more if you are learning AWS there. Okay. Now we saw that there are two types of version control systems. One is centralized and one is distributed. Now, what is the difference between centralized and distributed? Okay, to learn what is difference between centralized and distributed, what we have. Yeah. So what was the problem between us in this approach? What we saw? So it was manual. Okay, and there was no collaboration. It was very time consuming. Team collaboration, that is the important part. Collaboration was very time consuming and hectic. Okay, and it was very difficult to access the previous version. Okay, these were the disadvantages. Now, if you have version control system, some version control tools that came in, they are giving you a lot of features. They are giving you automatic versioning. Versioning is automatic there. You can track each and you can access even the older versions, and you can see who has changed what at what time and what changes he did. Why did he change it? You can keep on track everything. Then this helps you in team collaboration. And collaboration, the word collaboration is very important because all the DevOps tools we'll be using, ultimately, they are for having collaboration within the team. That is the ultimate aim of DevOps. Okay, then only the modified code is stored across different versions, hence it saves storage. Okay, so here multiple copies of the code are not created. Okay, it's like only the modified code is getting created. Only the modified code is getting. If you know, if you have worked on AWS, there is a concept called snapshot. Snapshots are incremental. So instead of creating a different copy of the code, what you do, you store only the modifications, only the things that have been changed. Okay, so this saves some space. The delta, correct? The delta. So this saves the space. Okay, now, yeah, we were seeing this, right? Types of version control. So there were two types of version control systems: central version control system and distributed version control system. Let's talk about central version control system. Let's talk about central version. So this is how the central version control system looks. This is a depiction of that central version control system. So in central version control system, what you have a remote repository. What is a repo? Repository or repo is something where you store your code. Okay, it's at a remote location. It's at a remote location. So now this is the case. I have three developers. Okay, I have some questions. There is some question from. Okay, so in this is centralized version control. What do you have in centralized version control? So you have a remote repo. Remote repo is your at your remote location. Remote location means not on a laptop. If everything is happening on a laptop, what if your laptop crashes? Now there are multiple developers. Let's say there are three developers: developer one, developer two, and developer three. What they do? The code is getting stored in the remote repo. Okay, the code is stored in the remote repo. Now let's say in the remote repo, I have this code. Okay, let's say this is a file. This is a file. In this file, there is some text. Let's say A. Let's say in the file, A is written. Now, when this developer has to work, this developer will download the code from the remote repo. Okay, he download the code. He will make his changes. Let's say he wrote B. And after making his changes, he will commit the code or push the code to the remote repo. Commit means to push the code. Whatever the changes he had done, so he will do it and he will commit the code or push the code in the remote repo. So in the remote repo now, situation is the file is having this. Okay, next day, person 2 comes in. What person 2 will come? Person 2 will download the code now. Now the code that he is downloading is having A and B. He will make his own changes. Let's say he made written C. He wrote C. After making his changes, he will commit it back to the remote repo. Now remote repo is having C. Okay, now next day, or let's say 3. So this person also what will do? He will download this code now. Whatever the latest he is there in the remote repo. Okay, same way he will also make a change and he'll also commit the change. So here what the thing is, do you see collaboration happening? Do you see collaboration happening here? So there are multiple people in the team. They are able to work this way, and on the remote repo, version control is happening. So if you go to the remote repo, you can check what version of this file is anytime. You can check what changes A did, what changes this person developer 2 did, what changes developer 3 did, when did they do this change, why did they do this change, which line did they change. You can track each and everything, but where? You can track each and everything only at the remote repo level. Inside the remote repository, you can track all the versions. All the versions are there in your remote repo. Okay, so I can say that versioning is happening on the remote repo. Now the thing with this approach is these developers need an internet connection, because this remote repo is where? This remote repo is on some remote location, maybe some server on the cloud, maybe somewhere else. So these developers are sitting anywhere in the world and they will need internet connection to connect to the remote repo, to download the code, to upload the code. Okay. You can assume, like, you can think about right now as Google Drive. Okay. You can think about like Google Drive. So in Google Drive, what happens? You upload a file, a TXT file, imagine. And you share that Google Drive link with many of your friends. What they will do? Your friends might upload, means they will download the file, and they might make changes to the file and they will upload it back. Okay, and another of a friend will download the same file. He will make change and upload it back. So you can assume, you can think about it like that. So there is collaboration happening, but there are two disadvantages. First is one that we saw, that versioning is happening only on the remote location. Versioning is happening only on the remote location. Now, if the versioning is happening on remote location, so if you want to see which version of the file is there, who did that change, who did that commit, why did he commit it, at what time did he commit it. So those things you can only check on the remote repo. For that, you need internet connection to commit the code, to get the code, everything for interacting. You need to have internet connection. So this was one disadvantage. Second disadvantage, and very important disadvantage, is that what if this remote repo crashes? What if this remote repo crashes? Now this remote repo is like everything to you. It is having all the versions. It is here, you can do here you are able to see the versioning, how is happening, who did the commits and everything. But now if this crashes, you are gone. It's like whole code is gone. That is an issue. So this was the issue with centralized version control system. Okay, now there are some tools which are available for this. For example, SVN. There is something called SVN, is a tool we use for centralized version control. And there are some more tools also. Okay, SVN. And now most of the time we don't usually use centralized version control system. Okay, centralized version control system is not used a lot. Okay, coming to your questions. We'll start with practical, don't worry. Today we'll do some demos also, don't worry. Just to give you an intro of these things. These things are, can you close? Okay. Question, anyone? Okay. Oh, Meher is saying, how many versions are stored? I mean, how many versions are stored? I mean, if the code has been committed 100 times, then it's going to store all 100 versions, or only last 10 as such. So here also what happens in these version control systems. Okay, here also your delta is getting stored. It's not storing the complete version. Here also modifications, only the modifications are getting stored. And you can see the whole history of that file. You can see the complete history that on this day, developer 1 did this commit. He wrote A. On second day, developer 2 did B. On third day, developer 3 did C. Or maybe developer 1 did some other thing. So you can track each and everything. Okay, there is no such limit here that you can see only last 10 or last 100. You can see the complete history. So here, yeah, the thing is that you need an internet connection. You need an internet connection here. Okay, if you want to see the versions, if you want to download the code, so the same example can you take, right? Google Drive. Can you download any file from Google Drive without an internet connection? No, right? You cannot. Can you upload the file to Google Drive without an internet connection? You cannot. Okay, so you need an internet connection. Now this was having a single point of failure. Now if remote repo crashes or if it is down, your users are impacted. Okay, they cannot do anything. They might be writing the code, whatever the copy of the file they have created, they can write the code there, but they don't have any mechanism to track the versions. Okay, they cannot upload the code, they cannot download the code, everything is stuck. Okay, Meher is saying if someone wants to go to the previous version, is it possible? Yes, it is possible. If someone wants to go to the previous version, he can download that version. He can download that because versions are there. If someone wants some older versions, he can download that version. Okay, and he can work on the old version. Okay, and obviously there'll be some conflicts and those things happening. Okay, maybe few lines are written here, you edit those lines, and this developer also edited the same lines. Okay, now both are trying to commit, so there'll be some conflicts. You have to resolve the conflicts. Okay, and then proceed accordingly. There'll be some conflicts, obviously. About conflicts, we'll be talking about data. Pradeep is saying, is there any mechanism to lock the editing of the file by multiple developers simultaneously? Because developers might write duplicate. Yeah, exactly. That's what I'm talking. That's what I was talking about, Pradeep. They might be possible that the developer might write duplicate code or they might write conflicting codes. Okay. For example, on this line number 1, earlier A was written. So maybe developer B, this particular developer is changing it to B. This developer is changing it to C. It is possible. So there'll be some conflicts happening. What they have to do in that case? They have to get the latest from the remote. Whatever is the latest thing in the remote, they have to get it. They have to change the code accordingly at their place. Then they have to commit that code into the remote. Okay. So conflicts have to be resolved here. Simple. Okay. Got it, Pradeep? And there are ways of logging. Okay. You can log the files and those things are there. So this was centralized version control system. We will not waste a lot of time here because these are not usually used. Okay, these days people are not using it. Okay, some examples of centralized version control system are sub SVN. Okay, SVN is very popular. There is Helix Core and there are some other tools also. Now coming to what is distributed version control system. Git is not centralized. Git is not centralized. Git is distributed version control system. And Git is one of the most popular distributed version control system. Almost every organization is using Git. Almost every organization is using Git. So now, what happens in Git? So what happens in usually distributed version control system? Here you see, in distributed version control system, you have a remote repo. You have a remote repo. But along with the remote repo, you have a local repo as well. Along with the remote repo, you have some local repo as well. So here, remote repo concept is same. Okay, all the versioning happen on the remote repo. Remote repo is located at the remote location where your file is stored, where your code is stored. Okay, let's say here we have a file. Here we have a A written to it. Okay, there's some code written. A is just a line here in the file. But here you have something called local repo also. Now versioning is happening at 2 levels. At the remote repo level and at the local repo level. Local repo is inside your laptop. Now there are 3 developers, developer 1, developer 2, developer 3. So what they will do on their local machines, on their local laptops, they will install a Git client. Git is what? Git is an application. Git is a application. It's a software on your laptop or your machine. You will install Git. Okay, and there will be a local repo on your laptop. Now this local repo is inside the laptop of developer one. This local repo is inside the local repo. They have their own local repos. These developers are having their own local repos. And now what they do? Whenever they have to make some changes, so what they do? They take the code into the local repo. Local repo is also repository. Repo means repository. Repository is a place where you can store your files. You can assume like a database. It's a kind of a database or a place where you store a lot of files. Okay, so right now the file on my remote is A. It's written A here. Okay, now this file is brought to the local repo. Let's say developer one is working on it. Let's say developer one is working. He will bring this file A at his side in the local repo. Now he can make a lot of changes to it. Now what he do? He'll make, okay, he brought it to the local repo. Imagine he brought to the local repo. Now he will start making change to it. Okay, he'll start making change to it. So he wrote A, okay, he wrote B. Now after making some change, he does not have to commit it into the remote repo. He can commit it into the local repo. So he can do a commit. This person, after making some changes, he will commit the code to the local repo. Okay. Now this code is there in this local repo. The code is not yet there in the remote repo. He will make some more changes and commit it in the local repo. Now local repo also, on local repo also you can track all the versioning. So versioning is happening here also and here also. Now right now we are talking about local repo. On his laptop, he can see what are the versions. He can do all the versioning here. He can see all the log history, he can see all the logs, he can see what changes he did, what changes other did. All the changes he can see in the local repo. What he does, whenever he wants, he makes some changes. Whenever he wants, he makes some changes and he does a commit in the local repo. And once he is done with his task, he will push the code. He will push the code to the remote repo. Because remote repo has to be updated. Remote repo has to be updated. Why? Because tomorrow developer 2 might come in. Developer 2 is also working. Now developer 2 will work on his own local repo. So developer 2 needs to know what changes one has done so that he can add something on top of it. Okay, so remote repo is there for collaboration because local repo is lying on their personal laptop. Developer 2 does not know what developer 1 is having on their local repo. Developer 3 does not know what developer 1 and 2 are having in their local repo because local repo are there in their local laptop. So what they do, they are working individually on their local repos, and whenever they are done, they push the code to the remote repo. And this remote repo is accessible to everyone. Everyone can see what's in there in the remote repo. Okay, so imagine in our case, developer 1 got the code from the remote repo. He made some changes, he made some commits on the local repo, then he pushed the code to the remote repo. Now the remote repo is having A, B, C, D. Okay. Now tomorrow, developer 2 came in. He will pull the code. From the remote repo to his local repo. Now to his local repo, the file that has been pulled is having A, B, C, D. He will make some more of his changes to it. Okay, he might write he might make some changes. He might edit the file. He might whatever. He might do some changes. So let's say he added EF. He added 2 lines EF. After making changes, he will commit in his local repo. He will commit the changes to his local repo. Okay, after doing some changes, so after his task is done, he will push the code again back to the remote repo. Now the remote repo is having EF and whatever. Now since the changes have come to the remote repo, now everyone can see it. Everyone can see it anytime. But who did the change? How did he make? What are the files he changed? At what time did he make this change? Okay, so what are the advantages in this approach? So advantages in distributed version control system are here you have two places, two repos. You have a remote repo, you have a local repo. So here, even if your internet connection is not there, now internet connection is needed if you want to sync your local repo with the remote repo. Maybe if you want to download the changes from the remote, if you want to download the code from the remote repo, or if you want to upload the code to the remote repo, or if you want to see versions on the remote repo, then you need to have internet connection. But if you don't have internet connection, you can still work on a local repo. You can still work on a local repo because versioning is happening on a local repo also. You can always go and check in the local repo who did that commit, when did you do the commit, what are the changes, how many means all the versioning stuff you can check on the local repo also. So you don't need internet connection. Internet connection you will only need if you want to download the code from the remote repo or you want to push the code to the remote repo. Okay, and this was one of the improvement. This was one of the improvement over distributed version control system. Another improvement is that here you have two repos. Now you have 2 points of failures. Means in case your remote is down, your remote is crashed, remote's repo is not available or anything, you still have your code in your local repo. You still have the code in your local repo. So at any point of time you are safe. Okay, there might be cases that so local repo is most of the time updated. You have to keep on updating. So local repo has to be in sync with the remote repo. Or maybe if remote repo crashes, you might lose everything in the remote repo, but still you have all the versions and everything in the local repo. Okay, in the local repo you still have the version, so you can always restore it and you can do different things. Okay, so distributed version control system was an improvement over centralized version control system. So every developer has their own local repo. Local repo is there on their laptop only. Developer 2 and developer 3 cannot see what's in the laptop of local repo of developer 1. Okay, so local repo is in their personal machine. That is saying, but this type of versioning consumes huge volume of local. But this is providing a safety also. This is providing a safety also and a lot of benefits that you're having. You don't need internet connection to work. You can always commit the changes. You can always look at the previous versions. You can look at differences and everything in your local repo only. Okay. One thing, can the developer to request developer 1 version of the code on his local machine? Can developer 2 request developer 1 version of say? So here developer 1 does not know what developer 2 has done in the local repo. Developer 1 does not know what developer 3 is doing on the local repo unless they have committed their code to the remote repo. That's what I said. Once they do the changes, now if they want that other people should have a look at their changes or other people can see their changes, but they have to commit the changes, they have to push the changes to the remote repo, because remote repo here is doing all the collaboration. The collaboration is being done by remote repo. Here also and here also. You see, in centralized version on control also, remote repo was the thing that was helping in collaboration. Because ultimately this is a version control system. This is a type of version control system. It's a DevOps. It's a DevOps tool. Okay, so collaboration is happening here also. But there were some two disadvantages, and those two disadvantages are overcome by distributed version control system. So your remote repo for collaboration. If developer 2 wants to see what developer 1 has done, so developer 1 needs to push his code to remote repo so that other people can access it. Other people can go to the remote repo and check what developer 1 has done. Okay, Vani, I hope I answered your question. Manjeet is saying simultaneously push from developer 1 and developer 2. How is that getting handled? So again, there are chances of conflicts here also. There are chances of conflicts here also that developer 1 and developer 2 modified the same line of the code and they are pushing that code to remote repo. So there will be conflicts. So conflicts have to be resolved. Okay, conflicts have to be resolved. You can resolve conflicts manually. Okay, conflicts we'll talk about, don't worry. Conflicts we'll talk about. Naveen is saying, what is the use of local repo in deployment? So local repo, there is no use of local repo in deployment. Okay, local repo. So deployment we're not talking here right now. We are not talking about deployment right now here. Deployment is like same. Deployment again you can deployment will come later. Means this is a source code management version control base. Victim is saying okay, break. Okay. Now these are differences. You can read those differences. So I'll not go a lot into theory now. We have done enough of theory. Okay. Just very quickly. So we saw SVN. SVN is example of centralized version control system. Okay. Again, we will not be doing SVN. We will not be learning SVN because we'll be learning Git. Git is what? It is an example of distributed version control system. Okay. Let's come back on the question. So these are saying question. Where's the question here? It will also require rollback. Yeah, rollback everything. Rollback also you can do. Okay. Now we'll be doing some demos. Before that, I'll tell you how to create a server. Okay. Let's quickly see how to create a server on cloud. Okay. Now we'll be using AWS cloud, and I hope you guys are having your AWS account. Okay, your AWS account are already there. You might have already created it. So I did not ask you to create a DB. So you have created a AWS account, right? You guys all have your AWS account. Okay, you can log in as a root user or whatever user. Whenever you log in, you see this screen. Okay, whenever you log into your account, you see this screen. Now on AWS, I'm not talking about details. I'll not go into details about AWS because you might have a separate course on AWS if you have taken. Because this is not a cloud course. Here, what we are interested in, we are interested in creating a server. That's it. Our main aim is to developer to get a server. That's it. Okay. Now, let's here on the left, on the right side at the top, you see there are some regions. The name of the cities you are seeing: North Virginia, Ohio, California, Oregon, Seoul, Singapore, Sydney, Tokyo. Okay, now you can choose any. It doesn't matter. It doesn't really matter what you are choosing. Okay, so let's go with any region. Let's go to Paris. Okay, I can go to Paris. Okay, any region you want, you can create your service. Now, again, what is the region? What is availability zone and all those things? Those things I'm not covering right now. Okay, not needed for us because our aim is what? Our aim is to get a server. That's it. Okay. So in AWS, you have lots of services. You can create a database. You can create a server, you can create some file systems, you can create a network, you can create a lot of the queues, you can create some permissions, you can create file, you can create a lot of things. For us, we are interested in creating a server. In AWS, these virtual servers are called EC2 instances. EC2. EC2 is Elastic Compute Cloud. Okay, now how we look at a server? On the search bar, just search for EC2. EC2. It says virtual servers in the cloud. Just click open it. Just click open it. And here you'll be seeing a console. You're seeing a dashboard. You're seeing a dashboard where what you can do? Here you can click on launch instance. Click on launch instance. Now there will be some configurations that you have to provide. There are some configurations you have to provide. So give it a name. So I call it John server. I'll call it John's laptop. I'm mimicking two users. Let's say I'm mimicking just creating a situation where two users are working. Okay, let's create it without a name. Let's create it without a name. This is optional. If you don't put a name, it will not take a name. So I'm not creating a name here. Okay, leave it blank for now. If you want to give your server a name, you can give it here. Then comes application and OS images, AMI. Now, what is an AMI? You can read it, it's a template and everything. Now, in details, I'll not go. But for our understanding, you have to assume AMI contains operating system. AMI contains operating system. Now, which server you want to create? Whether you want to create a Windows server, whether you want to create a Linux server, whether you want to create a Mac OS, whether you want to create a SUSE Linux, whether you want to create a Red Hat. So you can choose which operating system you want. Okay. So let us go for Ubuntu. I'm going for Ubuntu. Pick on Ubuntu. Now in the drop down, you'll be seeing different flavors that are offered to you. No need to go into that. Just select the first one. You can check the versions. Okay, we are going with Ubuntu Server 22.04. This is the latest one. Just open it. Okay. Scroll down. Now here, you see there is something called instance type. Instance type refers to the size of your instances. Now servers are having some capacity. Like a laptop has some specifications, right? How much GB of RAM, how much virtual CPUs. Okay. So similarly, servers that you're creating, servers are ultimately a laptop only, right? Kind of it has a compute capacity. So these servers had different capacity. You see, here there are different instance types you are getting. Okay, some are small. Let's say it's having 0.5 GB of RAM and one virtual CPU. This having 1 GB of RAM, one virtual CPU, and you have even the bigger ones. You see, T2 large. T2 large is having 8 GB of RAM and two virtual CPUs, and you have even bigger ones. T3 T3.x large. T3.x large is having 16 GB of RAM and 4 virtual CPUs. You can choose whatever, but there are few instance types only that are available in the free tier. We have to do things in our free tier. Okay, because when you create a AWS account, you get 1 year of free tier. Okay, you are in free tier quota for 1 year. Okay, T2 Micro is available in the free tier. Okay, so let's go for it. Let's go for it. It's already selected. Then comes KeyPair. KeyPair is nothing but some, you say, like a login and password. Okay, like when you open a laptop, you have to provide your username and password, right? You have to provide the username and password of a laptop. Then only you'll be able to log in, right? So that's why we have a KeyPair. Using a KeyPair, you can log into your server. Okay, here if I call it server or if I call it EC2 instance, if I call it virtual machine, everything means the same. Everything means ultimately that is a server, that is a virtual server. And this server is located somewhere in the cloud. It's not physical. I'm not able to touch it. I'll not be able to touch that. So this server I'm getting somewhere in the cloud. Okay. So here I have to put a key pair. Okay. Here click on create a new key pair. If you already have a key pair, you can use it. But see, I don't have it. So create a new key pair. Here, give it a name. Okay, I call it Paris key pair. It's in Paris. So I'll call it Paris key pair. And you can put it any name. Paris key. I'll call it Paris key. I'll call it Paris key. Use RSA. Use PEM. Okay. And say create key pair. Select RSA. By default, this is only selected. RSA, PEM, and say create key pair. Now, what about details of that and all those things? We'll see that no need, you will understand when you're studying AWS. But here we are just creating a server. Okay. So this will, if you say create key, so you'll be getting to save that key in your local laptop. So the key that you're creating, you need to save it in your laptop. Save. It got downloaded. You see, that is key.pem got downloaded. And I can see it in my downloads folder. If I go downloads folder, you see, I can see Paris key.pem. I can see Paris key.pem. Now, I'll use this Paris key.pem when I later want to connect to my server. Okay, so leave it as it is. Scroll down. There are some network settings. Here, we will be leaving them as default. We will be not changing it. Now, what is a VPC? What is subnet? These things, these are very AWS specific. Okay, now we will not be touching it. You learn more when if you're taking AWS course, or if you know cloud, you already know this. Then here, you see, we have something called firewall. Here they call it security group. In AWS, they are called security groups. What is a firewall? Firewall is like a guard. Okay, you can assume that your server as your house, and security groups like a guard. Okay, now guard is what? Guard, whenever someone comes to your house, there is a guard sitting. The security guard checks whether that person is allowed to enter the house or not. If that person is allowed to enter, then the security guard allows him. If that person is not allowed, the security guard stops him. So that's what the firewall is. That is what the firewall is. So here we are going to select it, create a security group. So let it be. And here what to do? Here just select these also. So let's just select these also. Not really important, but let's select these also. So I'm allowing SSH traffic. I'm going to allow, HTTPS traffic. I'm going to allow HTTP traffic. So these three type of traffics I'm going to allow on my instances, on my server. Now, what are these? What are these traffics? See, whenever you want to connect to your Linux servers, okay, Ubuntu, Amazon Linux, or different servers, you are getting option, right? Different operating systems you are getting option. Amazon Linux, Ubuntu, Red Hat, SUSE Linux, Debian. So these are Linux servers. Okay, these are Linux servers. Now these, if you want to connect to your Linux servers, so you have to use the protocol that is being used is SSH. The protocol that is being used is SSH. Okay, so here if you select allow SSH traffic coming from anywhere means from internet. The thing is that your server that you are creating, is getting created in some AWS network. The server that you are creating is getting created in some AWS network. Now you are going to access that server sitting at your home, right? You are going to access that server from your laptop sitting at your home. So that server should allow your connection, right? Server should allow you to connect. So that is why we are creating security group. Okay, we are telling the guard of the house to allow this person, and this person. Okay, now SSH traffic SSH protocol is used when you want to connect to your Linux instances. Okay, for us, it's our Linux instance only, so we need SSH traffic on. HTTP and HTTPS are used for web traffic. If I want to open something in the browser, we write HTTP, right? We write HTTP, HTTPS. Okay, so HTTP and HTTPS are used for sending request from the browser. Okay, so HTTP protocol and HTTP, so we are allowing all the things. Okay, and just scroll down. Okay, and nothing, no need to change anything else. Here you have something called configure storage. Now, how much size of the volume you want? How much you can say, you can assume like a hard disk. How much hard disk you want in your server? So I'll say 8 GB of hard disk. Okay, and that's it. Nothing else. So what we did, we are creating a server. Okay, we chose Ubuntu. We chose the first option. We chose T2 Micro. This is in free tier. We created a key pair, and the key pair got downloaded on laptop. Then we went to create security loop, and we selected all three options, and that is it. And you can say how many such number of instances that you want to create. How many such instances you want to create? I'll say only one. I'll say I want to create only one such instance and say launch instance. And say launch instance. Now it says launching instance. It says success. Successfully launched instance. Okay, instance got launched. And if you go down and you can say click on view all instances. And here you see your server is in pending state. It's in pending state. Okay, so it will take few minutes, few seconds to get created. Till then, let's take your questions. Okay, I explained very quickly. I explained very quickly on the topics. Means how to create an instance. I'm going to say North Virginia highly available. Everything is highly available. Okay, in AWS everything is highly available. Deepti is saying authentication is to connect. Yeah, correct. Deepti. Key pair is used for authentication. Become the saying, sir, please launch an instance. So don't go. Okay. I did not go into very detail. I just used minimal explanation. Okay. So we have our server ready. Now we want to connect to our server. Okay. Now we want to connect to our server. So how to connect to our server? So you have two options. One is select it and say connect. Let's give it a name. You can give it a name here also. Click on it and you can give it name here. Okay. Let's call it anything. Okay, let's call it my server. Okay, my server 1. Okay, now how to connect to it? Select it and say click on connect. Okay, and by default the EC2 instance connect is selected, and if in the below you see there is something to connect, click on connect, and in the new tab connection will happen. So we are connecting to our machine. So see, I got connected to my server. So this is a very small way, easy way to connect to our servers. Okay, just click on connect and in the browser it will open it. You can also connect to your servers from your laptop also. Okay, if in your Windows laptop you have PowerShell, in your Windows laptop you have something called PowerShell, right? Windows PowerShell. So let's connect using PowerShell. Click on open Windows PowerShell. Okay, now go to the location where you downloaded your keys. Okay, go to the location where you downloaded. So I downloaded my keys in download folder. In my downloads folder, my pariskey.pem is there. Okay, so what I'll do, I'll go to downloads, CD, downloads. Okay, if you're on Mac also, you are the same process. In Mac also, you are the same process. You don't have PowerShell there, but you have terminal. In Mac, if someone is using Mac, you have terminal there. So go to the folder in which you have keys. So I'm into downloads folder where I have the key. Okay, now go back to the instance. Okay, click on connect again. Select your instance, click on connect again. And here you see there is a tab for SSH client. Click on the tab click on the tab, and if you see below, you see there is an example how to connect. You will be getting a command. Just copy this command. Just copy this command and paste it here. And paste it here. Enter. Say, are you sure you want to continue connecting? I'll say yes. Done. You see, from here also, on my laptop also, I got connected to my instance. Okay, so there were two ways of connecting. You can follow either of the ways. Okay, I hope it is clear. Till here, fine. Till here, fine. Creating an instance. I showed you quickly because most of the steps are not relevant to DevOps. Okay, means they will be mostly covered in AWS. Means how to create an instance. And all. So for us, important was to getting an instance. Okay, I did not explain you every configuration in detail. That what is a VPC, what is the AMI, and all those things. But I showed you with some defaults how to quickly create a server. Okay, then you're saying why use AWS instance? So we need a server, right? We need a server. That's why you can do it on a local also. Okay, but no, some people might be working on uh, Windows machine. Someone might be using on Mac OS. Someone might be using on some other machine. So what I did, I created a Ubuntu server. Ubuntu is an operating system. Okay, Ubuntu is an OS. So I created a Ubuntu operating system server on AWS, and I just connected to it. One is saying once the instance is created, I am unable to follow steps. You access download keep here. Okay, so again, I'm maybe repeating it. So once your instance gets created, you just need to access it. You just need to connect to it. So there are two ways of connecting. I told you. I told you two ways of connecting. One was very simple. Select it, select your server, and go to connect. Okay, and you have easy to instance connect. Then just click on connect below, and below you see connect option. Just click connect, and it will open this in the new tab. Okay, this will open this window in the new tab, and you are in the instance. Nothing need to do. Nothing need to do here. You are already connected to the instance, and you can start running your commands here. Okay, this was very step. Other procedure I told you. Other procedure was if you want to connect to your instance from your laptop or PowerShell. So on Windows we have a PowerShell, right? Windows PowerShell. If you want to connect from here, open the PowerShell. Go to the folder where your keys got copied. Remember when I did create keys got downloaded. So I download the keys in which folder? Download folder. Okay, and here I want to run a command. Connect to my server. So what I do? Here you see there is a SSH connect option also. And here just copy this example, this particular command. You already have this command SSH-I, name of the key, and the details where you want to connect, and just paste it here. Simple. Just paste it here and say enter. Okay, and it will take you inside it. You see, you are connected to your server. Got it, Vani? Now, once you are connected to your instance, okay, now here, what you can do? Now here, first thing you have to do is check whether Git is installed or not. So Ubuntu will come with Git pre-installed because most of the operating system are coming with Git pre-installed. So just do git hyphen version. Okay, git hyphen version, and then you get the version. Git version 2.34.1. So Git is already installed. If you do not have Git installed, so if you use Git, this will be already installed. But if you do not have Git installed, you can follow the steps which are mentioned in this. You must be having a this document. Okay, sorry. In your LMS, you will be having a document here, DevOps all tool installation. So in this, okay, in this you don't have Git installation, but Git is by default installed. That's why they don't have it here. So see, you can in case Git is not installed. In case Git is not installed, you can follow the installation process here. Okay, just type git install. Okay, and you will get download. You see, just open the first link and you can see where you want to download. Depends on where. If you want to download Mac OS, you can download it. You can download the Windows. You can download the Linux. R is Ubuntu, right? Ubuntu is a Linux instance. So click on Linux, and here you will get all the commands. Here you can get all the commands to download it. So for us, it's Ubuntu, right? For us, it's Ubuntu. So we have to run this command first, okay, and this command, then these two commands, and your Git will be installed. Okay, but right now for us, Git is already installed. If you follow the steps, what I did, you will see Git is already installed. Priyanka saying, can I get this instance creation videos? So all the things will be in LMS. Okay, all the thing will be in there in the LMS. So no worries on that. You can always check the recording. Dear saying, can you share these files? These files are already there in LMS. Okay, all the files will be there in LMS. Now Git is already installed. Now coming to our Git commands. Now I have connected to my EC2 instance. So I am on the server. Now what I'll do, I will create a folder here. I'll do mkdir. So you know mkdir command. Mkdir, I'll call it my Git demo. Okay, call it anything. Just a name of folder. I'll say mkdir my Git demo. Okay, so this folder got created. Now if I want to go in this folder, I'll do cd my Git demo. Enter. So I am in this folder now. Now in this folder I don't have anything right now. Now I want that Git should track this folder. Okay, come into questions. Some questions. Okay, now here what we want? Here we want that Git should track our folder. Now Git will not track your folder by default. We are right now talking about local repository. We are not talking about remote repository now. Now what we have done, Git client, we call it Git client. Git client is already installed on our server. And now we want Git to track our files. Okay, so how would you do that? So by default, Git will not tag anything. So in your laptop, means in your server, you might have a lot of folders. Here we have created one folder called my Git demo, but in your server, you might have many folders, many files. So by default, Git will not track anyone. If you want that Git should track any of your folder, what you need to do? You need to run a command git init. You have to run a command git init. So say enter. Done. So now your this folder, my Git demo, this folder has become a repository. You see, it says initialized empty Git repository in this folder. So this particular folder has become a repository now. It's acting like a local repository. Now here I can run some git commands. So as soon as I run git init command, there is a hidden directory got created. Automatically a hidden directory got created, which you can see ls-altr. So if you use the option altr, so this will give you some hidden directories also. ls-lstr is just giving you how many files are there. So there's nothing. But if you want to see the hidden files, so you can run this command ls-altr, and this will give you some hidden files also. Look at it. There's some hidden files also, and .git file got created. .git directory got created. How did it get created? As you did git init. You did git init, and a .git directory got created. Okay. Now let me create some files inside this folder. Now this is as soon as I did git init. So this folder that you created, means this directory or folder that you created, my Git demo, this mygit demo folder has become what? It has become your local repository. And now you can run git commands there. Now you can start running some git commands there. Okay. So what I'll do? One command I'll tell you, git status. Git status is what? Git status checks the status of your repository. Git status checks the status of a repository. Write git status and press enter. Okay. So what does it say? Git status says no on branch master. What is a branch and those things? What is master? I'll tell you later. It says no commits yet. Right now, there's nothing. There is nothing in the repo. And say connecting nothing to commit. There is nothing to commit. Okay. Okay. You guys, can you please change the color of the background so that we can see? Okay. So I'll change the color. Let me change the color. Yeah. Green background. Let's make it gray and text. Screen text. Let's make them black. Okay. Maybe I'll change some size also. Okay, I'll make it bold also. Okay, I think it's fine. Is it fine? Is it better now? Okay. So first command is git init. I'll give you the command, don't worry. The first command that I ran is, first I did git ---- version. Just to see what is the version of my git installed. What is the version of my git client. Next command I did git init. Git init I did to initialize my git repository. I created a folder. I ran a git init command inside the folder, and my folder or my directory became a git repository. Okay, guys, these commands are there in your LMS again. These commands, every command is there in LMS. Don't worry. No need to take means if you want to take the notes, you can take the notes. But you see, there is in the hands-on, you'll be seeing common git commands. Okay, in this you will be seeing all the commands. Okay, I'm using this only. Nothing. See git init. You can see the description also properly. We run git init command. Okay. Now we run another command git status. Git status. Git status. What does it do? Git status shows you the status of your repository. So right now we don't have anything in the repository. Okay, I'm using a clear command again and again just to clear all the content. So right now there is nothing. So now what I am going to do? I am going to create two files here. Let's create two files. How to create a file? So you know Linux, right? So the command to create a file is touch. I'll do touch file 1.txt and file 2.txt. Okay, these two files I'm creating and say enter. Now do ls-lstr and you see these files are there. File 1.txt and file 2 files got created in this directory. Now these files are you have just created, and these files are not being tracked by Git right now. So now if you do git status, look at it. Now if I do git status, now these commands will come in the flow. Don't worry. If I do git status now, it'll give you this. It says that okay, you are on branch master. So what is a master? So what is a branch? So by default, we are working on master branch. Okay, whenever you initialize a repository, the first branch gets created as master. We'll come in detail about the branch. Don't worry, what is the branch and those things I'll tell you. But you have to assume that branch is you can say, just assume branch right now. It's a master branch. We are working on the master branch. We'll cover branches tomorrow. There are no commits, and there are two untracked files. You see, it says untracked files. Which files are untracked? The two files say created, file 1.txt and file 2.txt. These are untracked files right now. Why are they untracked? Because I'm going to tell you a very important thing now. See, what we have done, let me cover the concepts, okay? Okay, let's see. Whatever we are able to cover, we'll cover. So, see, I'm recreating. This is my instance which I created. Okay, this is my EC2 instance or my server. I call it my server 1. This is my EC2 instance which I created. Inside my EC2 instance, what I did? I created a directory. Okay. I name this directory as, you can name bottom. So I'll name it. I named it my git demo. Okay, I named it my git demo. Okay. Now inside this directory, what I'm doing? Now inside this directory, what I did? First I did git init. First command I did git init. And this git init command converted my this directory into a repository, into a git repository. Now you know what happened? Automatically. Now see what all things you want to do, what all things you can do in your any what can I do with the file? You will either create a file, right? Either you will delete a file, either you will update a file. Can you do any other thing? Can you do any other thing apart from create, delete, and update? Cannot, right? These are only the three operations that are possible. Either you create a file, either you made some changes to the file, or you delete a file. So whatever these operations you do is called a change. So these are the three types of changes that you can do on a file. Okay. Now, as soon as you did a git init, your folder, your directory transformed into a git repository. Okay. Now it automatically got divided into three logical partitions. You can say it got divided into three logical partitions. These are not, you cannot see those partitions. So this partition is called working area. This is called working area. Working area. So means if you are creating a file, you are modifying a file, you are deleting a file, or you are making any change, you are working on that file. That means the file is there in your working area. So let's say I created two files here right now. So I'm making just one. This is the file I created. And while the file is there, this particular file you are working on right now, this means that this particular file is in working area or working directory, whatever you call it. Now I want to save this file. I want to save this file in my repository. I want to commit this file to my local repository. So what I'll do, I'll not directly do a commit. What I need to do, I made a change. Let's say I made a change. I wrote ABC. In this file, I wrote ABC. Now this file first have to be moved to staging area. This is very important, guys. This file, guys, let's see. This is very important. This is very important, guys. This is very important. This is very important. This is very wait, guys. Let's look at it. So I did a working area. So whenever you make a change, whenever you are editing, whenever you are creating, deleting, updating, or modifying anything, you are doing where? You are actually working in your working area, in your working directory. Now, what you will do? You will have to bring your changes to staging area. So how do you move changes to staging area? You will run a command to add. You will add an add command. You run an add command. So add command will bring your changes to the staging area. So sorry. Okay, we'll see that command. Don't worry, we'll see it in practice. Okay, it's not coming properly, but so I made a change and I moved my file to my staging area. Okay. Now, once this is in the staging area, Sumi is saying I'm lost. Okay. So what I did, whenever I make a change, again repeating. See, whenever I am making a change, I am working on my working area. Okay, I'm working on my working area. So I run a git add command. So git add command will bring my changes from the working area to my staging area. Okay, to my staging area. Now what is the staging area? Now these areas you cannot see. You cannot see these areas in your folder, but these are logical partitions. These are some logical partitions. You'll understand more when we are doing the demo. I'm just telling you some part of theory because today we don't have time to see the demos. Okay. So now, once it is in staging area, I can see what are the changes I did. Okay. Then what I can do after it is in staging area, I can commit it. I will run a commit command, and commit command will move it to my local repository. Okay. So always, whenever you make a change, it has to be two-step process. First is you make a file, you create a file, you edit a file, or you are working on the file. You have to add that file to staging area. Then after you do a commit. Okay. These two steps you always need to do. We'll do that tomorrow, don't worry. We'll do that tomorrow. But before that, one very small thing. See, here we have created two files. Now we'll be doing git add, git commit later on. But I will tell you one command, one extra command I'm giving you, so that okay. Please mute all at them time versions. Okay. Okay. So maybe it's time already over. Let's connect tomorrow and let's do some more demos. Okay, let's continue our demo tomorrow. I think there are some people who have already left. Let's connect tomorrow. Tomorrow we are going to do. I'll tell you this thing again. I'll repeat it. So I hope it is getting clear. Things are getting clear because in DevOps there are a lot of things. So I'm trying to because we are going slow. I know we are going a bit slow, and let's see. Sai is saying, sir, we can use Git in our local, right? Then why use Git in instance? So you can use it on local also. It's fine. You can use it wherever you want. Git is a client. Okay, Git is just a client. You can install it on your local machine, on your laptop. You can also install it on your any remote server, or it means any EC2 instance or any virtual machine. You can install it wherever you want. Yeah. Okay, just a minute. I'll stop your instance after doing the demos. That is important because anyways we have created a instance in the free tier. It's for free, but still there are some hourly limit, monthly. So we are saying unable to connect with PowerShell. Okay. Thank you everyone.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
Okay, so this is the directory we created, and as soon as we did git init in it, so this directory, 3 partitions got created for this directory. Just take an example, 3 partitions got created, and now I told you 3 operations that you can do on any file in your. Then there are only 3 options that you can do. Either you can do a create, okay, either you will do a delete, either you will do update, right? So these are the change operations that you can do on any file. Either you'll create a file, either you delete a file, or you will add or remove something in that file. Okay, so basically these are 3 operations. These are change operations. Anything changes. Okay, now these change operations will happen in the working directory, in the working area. Okay, so the first partition that we are talking about is working directory. Okay, or working area, because you're working on it, you are changing the file. So if I create a file, or if I modify a file, or if I delete a file, or if I do anything operation on the file, that means I am working in my working area. Okay, so let's say there is a file created, and I wrote something in it. I wrote something, a red line. I wrote something, a red line here. Okay, now what happens? Ultimate aim is what? Your ultimate aim is to edit something in the file and commit it to the repository. Okay, edit something and commit it to the repository. So committing, you cannot commit directly. So what do you want to do? You have to move that file. After making some change to the file, you have to move that file to a staging area. You have to move the file to a staging area. So to move the file to a staging area, what you do? You run add command. Okay? File moves to the staging area. And to move the file, you have to run which command? Add command. The command is add. You have to do git add and the file will move from the working area to staging area. Okay, this area is staging area. Once it is moved to staging area, now you can be working on a lot of files. Let's say you have changed 10 files. You have created some files and you have some modified some files. In total, you have worked on 10 files. Now you can add all those 10 files to your staging area. You can add all those 10 files to a staging area. Now you have an option to choose out of 10 files which you want to commit and which you don't want to commit. Okay, now to commit, you have to run commit command. So as soon as you commit, your file moves from the staging area and gets committed to the local repository. Okay, so your file will move from here to here like this. And which command are you using? You're using a commit command. Commit command. Okay, so let's try this. Okay, let's try this. And all these operations you are doing on a local laptop. So right now we are not talking about remote repository. We are only talking about local repository. So what I did just now, I created a folder. I just created a folder called my project. Inside this, I did git init, and my project and my folder has been converted to a git repository. Now let me create some files here. The command to create a file is touch. Let's create a file called file1.txt and file2.txt. I'm getting these two files. Okay, so let me clear my screen. I'll keep on clearing my screen so that visibility is a bit better. If I do, so another git command, what I told you, git status. Git status is a command you have to use. Git status is a command you have to use if you want to see the status of a repository. Like how many files are in working directory, how many files are in staging area, how many files are committed. How many files are committed will not show, but git status will tell you the status of a repository. So right now it says that I have two files, file1.txt and file2.txt, which git is not tracking right now because I have created these files as new files. These are new files. I have not done any modification right now. I have created these new files. So these files are not tracked by git right now. Even if I create a folder inside this folder, if I create one more folder, let's say folder 1, folder 2, inside this folder, so even those folders will be untracked. So I have to get it tracked. So to get it tracked, I have to move it to staging area. Okay, to staging area. So it shows you everything. Okay, all the commands are being shown by git. Use git add to track. Simple. I'll use git add and say dot. Simple. You remember that. Git add dot. This will move your files from your working area to staging area. And say add dot means it will move all the files that are in untracked location, means in which are untracked right now, in the current folder. Okay, so dot means all the files which are in this folder. So in this folder, my project, I have two files, file1.txt and file2.txt, which are being shown up here. Remove all the files from your local, from your working area to staging area and say enter. After running this command, do a git status again to check whether it actually worked or not. Git status, status status. Done. Okay, so now your git is tracking these files. See, now it is not giving. Now, first of all, the color has changed. Look at it. Notice the color has changed. Earlier it was red. Okay, now it has green. It says new file. Now it says new file. Means your git is now tracking these. And now as we did git add operations, so now our two files are in the staging area. Now these two files are in the staging area. My files are right now in my staging area. Now I can commit it. Now they're in staging area. Now I will commit it. So to commit, I have to use a command called git commit. Command is git commit. Okay, then -m. Okay, so you can commit these files. But before that, see, I am committing these files. So what I want to do, I want to set up my username and email. Okay, this is some additional thing I'm telling you. I have to set up my username and email because see, in a project, many people are working. So right now you are working on a code. Imagine you are working on a code, and ultimately we will be pushing our code to our remote repository. Okay, for collaboration purpose that we have already seen yesterday. Okay, that we already seen yesterday that in Git you have local repository and a remote repository. Right? Yeah, in Git you have what? You have a local repo and you have a remote repo. So right now where we are working? We are working on the local repo side. So here we have installed our Git client, and right now we are working here only. But tomorrow, later on, you might have to push that code to remote repo so that other people can also see, right? So that other developers can also see the code. So it should show, right, who has done this change, who has done this commit. So we usually set a username and email in our environment. Okay, so the command is before doing a commit. So you have to use git config hyphen global global user dot name. Okay, and give your username. Give a username. For me, let's say username is user1. Okay, let's say username is user1. It can be any name. Let's say the username is user1. Okay, and I'll say give it a name. Let's say give it a name. Let's give it Sam. Okay, username is Sam. Okay, git config hyphen global user dot name is Sam and press enter. Now you can set up email also. Same command, git config hyphen global user dot email. Okay, and I'll put the email of Sam at the rate gmail.com. It can be an email, gmail.com. Basically, what you want to do, you have to put your name and your normal email ID. No one is checking whether your email ID is good or not, but you have to put your email ID and press enter. Okay, done. So what you have done with these commands? With this git config commands, I have set up my username and email. Now, whatever commits I'm doing, whatever the files will be committing, they will be reflecting my name and email ID along with it. So that someone should know, right, who has done this commit. They should see my email ID as well. What if they want to contact me to check why did I do this commit or if there are issues. So I set up these global variables. Okay, now you don't have to do this every time. This is only one-time stuff. You can do it earlier also. Before, just after get in it, you can run these two commands. Okay. So these commands, where these credentials are stored, these will be stored in your .git folder only. Remember, our directory, our folder has been converted into a Git local repository now. Git repository now. So as we did git init, a .git folder got created. Okay, altr. Again, I'm showing you. This I've showed you already. So if you do ls -altr, you'd be seeing what? You'd be seeing .git folder, and all the information, all your versions and all these global variables, all are stored in this .git variable only. .git directory only. This is a hidden directory. Okay, so do not delete it. This is a this is the file. This is the directory which gets created when you do git init. So everything stays here. Okay. Now what I did? Srinivasan saying, what is the use of global variables? I told you, right? Just to track who has done the comments. Okay. You'll be seeing. Don't worry. You'll be seeing. Okay. So now my files are in my staging area right now. So again, do git status. Git status. So this shows you that the files are in the staging area right now. So it's green. It's green, and it says changes to be committed. Changes to be committed. Now these files are in the staging area right now. Now I have two options. One is I can straight away commit these two files to my local repo. This is option one. But if I want that I have to edit these files again, or I want to send these files back to working directory, so I can unstage these files. Okay, the way we have brought these files from our working area to our staging area, now we have all the files here in my staging area. Now I can either commit these files. Once I commit, these files will be saved in my local repo. These files will be committed to my local repo. Or I also have option to send them back. I can send them back to the working area also. But let's commit them. Sending them back and unstaging, I'll tell you later. But I'm going to commit these files. So the command to commit is git commit. Okay, and -m. -m means message. Message you have to put in double quotes. You put double quotes and say why you are committing it. So I'll say commit one. Let's call it commit one. It can be any message. You can write any logical, any valid statement here. Modifying this parameter in this file, changing some just write anything, whatever. Why you are committing means it tells you why you're committing. And say enter. And this gives you this thing. This gives you that you have performed one commit. And what are the two files we changed? Two files changed, 0 insertions and 0 deletions. Means you just created these two files. File1.txt, file2.txt. These files are now sent from your staging area to your local repository. You have done a commit. Now if I do git status again, you would see that nothing to commit because you have already committed your files. Wait, you see, file 1 and file 2 are there, but right now my file 1 and file 2 are not in the staging area. They are not in the working area. They are committed. I have committed these files. How did I commit it? I did with this command git commit -m, and I put a message in front of it. Here. Now, so what are the commands we saw? What are the commands we have seen? We have seen git -version. We have seen git init. Then we saw git config -- global user dot name, the name of a user. Then we saw git config --- global user dot email, name ID of a user, email ID of a user. Okay. Then we did a command called git status. Then we saw a command git add dot. Or then we saw a command git commit -m and the message. Okay, these commands we have seen till now. Now I want to see the logs. I want to see all the logs of my repository. Okay, so what is the command? I'll use git log, simple. And this git log command, look at it. I did git log and it is showing me all the commits. It says that commit one, this is a message. This is a message that you have put. One commit happened on Friday, December 22 on 0 to 14. Now, don't match the time. This is UTC time. Okay, and you can see who committed it. Look at it. It's showing you author. So that is the use of the config command that we did. Because it shows that okay, in the log history, I see that a commit has been made by this person, and every commit gets a commit ID. So there is a commit ID. This is a commit ID. Okay, this is a commit ID. This is a commit ID that happened, that got created when I did a commit. Clear? Till here fine? Till here fine? Create mode 10064 is, don't worry about that. Okay, we'll talk about that later. Don't worry about that. So what I'm telling you, understand that. Okay, we'll go slow. Let's go slow and steady. Okay. Whatever I told you is clear or not. Now you can see other things, all the branches, masters, and those things. I'll talk about that. Don't worry. But till here fine or not? Yes. Okay. Now, one thing I want to tell you, that when you create any, so by default you are always working on the master branch. Now in Git we have the concept of branches. Okay, we'll talk about that. Don't worry. We'll talk about branch concept. But right now, by default, you are always working on the master branch. Okay, so that's what it says. That's why if you do git status, it says on branch master, because I am working on my main branch. Master branch is a main branch which gets by default created when you initialize your repo. Okay, so you're in the master branch. You can create your own branches also. I'll tell you that branches later on. But we have done a commit. And our files are in the local, are committed to our local repository. Now what I'll do, if I want to change these files, if I want to edit these files, now remember what operations I can do on these files. I can modify these files. I can add a new file. I can delete a file. Let's edit this file. Let's edit. I'm going to edit. VI editor, I think you already know. VI editor or nano editor, whichever you are comfortable with. So I'm opening the file, vi file1.txt, and open this, and I'm going to edit it. I'm going to write hello inside it. Okay, I'm going to write hello. Hello, I'm going to write it. And I'll save it. Now see, I have started working on my file. I have changed something in my file. I have modified something in the file. That means the file has come to where? It has come to my working area. So working area is a place where I can work on my files. So my file, I have done some changes. I have saved those changes on the file. Now this version of the file is in my working area. And if I do git status, it will show you, look, yes, it will show you. It will show you that you are on the branch master, but the changes not staged or commit. Means your file has been modified. It's telling you that your file has been modified, but right now it's in red. Look at it. It's in red. Red means it's in working area. So what I need to do? I need to commit my changes. And we know that I cannot commit my changes directly. So there are steps involved. Step is that I have to move my file to the staging area first, and then I have to do a commit. Now what is the command to move the file to staging area? Git add. Okay, git add. So let me clear it here. Clear the screen. So if I do git status, again I'm doing git status. So I can see the file is in local and working area. Now if I do git add dot, okay, now if I do git status again, now you see it's green. It says modified, and my file is now in the staging area. Now I can run commit command again. Now I can commit. I'll do git commit -m and any message. I'll say commit to. Let's say commit to. Done. Okay, done. So I have committed my file. I have committed the changes which I have made. It says one file changed and one insertion. So I inserted one line in my file. Now again, if I do git log, so now it shows me two logs. One is what I did previously, that is commit one message. Okay, and now it is showing me one more commit which I did just now. It's telling me one more commit that I did. Now this commit also has a unique ID. So every commit will get a unique ID. Okay, and it also shows who did it. So this is what versioning is. This is what versioning is. So I can see at what time I did what commit, and I can track my commits. See, VI editor, I think you might have, you have your Linux sessions, right? Linux sessions you might have already been working on. See, Linux I'm not covering. See, don't do it right now. Okay, first of all, Vijay and whoever are doing along with me, don't do along with me. You'll miss a lot of things. You'll miss the concepts because I'll be covering a lot of things. So if you do stuck in, it'll take a lot of time. So you have weekday, right? You have the weekend. So try it at your side. Look, you will get the recordings. Do it along with them. Okay, at that time. So how to use a VI editor? How to use a nano editor? You can learn. Okay, it's very easy. It's very easy. These are Linux. These are some Linux commands. Okay. So as I told you, Linux is the only prerequisite we are having. Linux is the only prerequisite you have. So learn some basic Linux commands. You should know how to edit a file, create a file, and all those things. These are very basic. Okay, got it, guys? Will you follow this? Will you follow this, guys? Don't go along with me right now. So just look at what you are doing right now. Okay, just practice after the class. You will get the recordings. So now I have done two commits. It shows that okay, one commit I did on 2/14/23, and this commit I did 2/22/54. Okay. Now it says now where I'm doing all these commits. I am doing the commits in my local repository. I'm doing these commits in my local repository in the branch. In which branch? In the master branch. In the master branch. Master branch is the default branch that you work on when you create a repository. So right now we are working on the master branch, and it shows that head. What is head? Head always points to the latest commit. Head always points to the latest commit. So if I show you, like, I'll denote it like this, okay? With this line, I'm noting it. So this is a master branch. Okay, I'll call it master. This is a master branch, and we are working on it right now. And we have done one commit. I'm denoting commit like this, and I have done one more commit. Okay, two commits I have done till now. Okay, but now I can. Okay, some questions. Okay, now if I want to see what are the changes I did in this commit, if I want to see what are the changes I did in commits, so the command is git show. Simple. The command is git show. Let me clear it. Command is, if I do git log, this would give me, no, git log gives you a lot of things, right? Git log gives you things in detail, that what is a commit, it gives you. But if you want to see things in short, if you're not interested in seeing lot of details, so just do git log hyphen one line, hyphen one line. So it will show your commits in a single line, in logs in a single line. Look at it. See, in a single line, it's showing both the commits. So again, these are handy features. If I want to see what are the commits I did, what are the changes I did in this commit, so the command is git show, and just copy the commit ID, either the short one which you see here, or either the long one you see here. It doesn't matter. Okay, so copy this commit ID and paste it here, and say enter, and it gives you all the details about this commit. So it says this is the commit ID, author is Sam, date is this, the commit which was the message that was added along with the commit is commit to, and it is showing you that okay, there were some differences. So in file1.txt, earlier there was nothing, but we added lines. You see, plus 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 means some lines were added. Which lines were added? Hello. You see, this was the change I did. So git show command tells you what are the changes that happen in this commit. Okay. So I hope till here everyone is following. Everyone is with me. Mara is saying when we do not provide config details, it will pick previous config details. Is it right? So if you do not provide config details, means your username and email ID. So it would not be anything. It will say blank. It will not give anything. It will author will be blank. So you have to give something. Okay, it's a good practice to give something. So now the changes right now, important thing is that the changes right now are where? The changes right now are in my local repository only. Right? But now we are talking about collaboration. Okay, we are talking about collaboration. That means I need to put this code where I need to send these files to my remote repo, to my remote repository. Right? So my file is here, got committed in my local repo. So I need to send this code. I want to push this code to a remote repo. Now, we are studying about Git, about distributed version control system. And here we have a concept of local repo. And we are doing everything in a local repo right now. What is that remote repo? Remote repo is a remote file, is a location. Remote repo is a remote location which helps in collaboration. Okay. Now there are many services which are available you can use for your remote repo. You must have heard about GitHub, GitLab, Bitbucket. Okay, these are different services. These are different web services. These are different web applications or web services which you can which you can use as a remote repository. Now I have done all my coding and I want to push this code to the remote repo. So you can use any remote repo. For us, we'll be using GitHub. For us, we'll be using GitHub. So what you do, you have to create a GitHub account. You have to create a GitHub account. So so just type on GitHub account. Okay, GitHub. Just type GitHub. Just type GitHub in Google, and it will take you to this page. Okay. So you have to create your user here. You have to create a GitHub account. It's free of cost. Okay. You have to create a GitHub account. So you have to do a sign up and all those things. Okay. You have to. It will be free, child. It will be free. Don't worry. No money needed. Now I will do a sign in. Okay, I already have an account, so I'll do a sign in. So, okay, sorry, I have logged into my Git repository. So you have to create one. Go home and create this Git repository. Get sign up to GitHub. Okay, you have to create a GitHub account. This is a must-have. Okay, so instead of GitHub, you can use GitLab also. But I'll be showing you things on GitHub. So here we can have our local repository. Srinivasan saying please cover commands like git reverse. So don't worry guys, I'll tell you. So let's go with the flow. Let's go one by one. Okay. So now here, what I need to do? I need to create a remote repository. I have to create a remote repository. So click on new. Click on new. And here you have to give the name of a repository. Okay. Give it any name. So I'll call it demo project. I'll call it demo project. Okay. This is the name of a repository I'm creating. You can give it any name. It will just show you whether that name is available or not. So, and give a description. Description can be anything. Okay. I'll just give it a demo project. It can be anything. So your repository can be either public or either private. So I'll keep my repository public. Okay. So because I want all of you to access my repository. If I want internet people can access my repository, I'll keep it public. but I can also call it private also. I can make it private also so that no one will be able to access my repository apart from me. So I'll make it public. Then don't select anything. Do not select anything and say create repository. Okay, so your repository has been created. Your repository called demo project has been created and it's a public repository. Okay, now this repository is your remote repository. This repository is your remote repository. Now, what is your aim? What do you want? You want that whatever code you have written, whatever code you have committed in your local repository, because on the local repository you have already done some commits. You have done 2 commits and you have file 1 and file 2 here. What do you want? You want to push the code to the remote repository. You want to push the code to the remote repository so that other users can also see that code. User 2, user 3, user 4, or your different developers, they can also see the code because they also want to work, right? Right now, remote repository is empty. Right now, we have just created a remote repository. So what I need to do? I need to point my local repository to my remote repository. I want to tell my local repository that you have this as your remote repository. Right now, my local repository does not know. My local repository does not know that what is my remote repository. So I have to tell my local repository that this is your remote repository. So for that, we will use this command. So all the commands are here, don't worry. All the commands are here in your uh, uh, um, document. Okay, so the command is git remote add origin and the URL. Okay, so just copy this command git remote. Okay, let me type it only. So here on the local repository, you have to type this command git remote add origin. Whenever you see the term called origin means your remote repo. So I'm adding my origin here. Git remote add origin and the URL of your repository. The URL of your repository. So what is the URL? I'll get it here. You see, when I create my repository, it gives me URL. Look at it. This URL will copy. I'll copy this URL. I'll copy this URL. And what I'll do? I will paste it here. I'll paste it here and say enter. Done. Done. So it says now what I've done, I have told my local repository that there is a remote repository for you. You can, if you push the changes, all the changes will be pushed to remote repository. And this is a push operation. This is a push operations. Okay. Now, anyone knows command to paste, and you can just select it and just right click, it will get pasted. Okay. Now, I have told my local repository that okay, that this is a remote repository. Now I can do push. Now I can do push. So next command is to push the changes to your origin. Origin means remote repository. So I'll do git push origin and the name of the branch where you want to push. So branch is master. Right now the branch is master. So git push origin master. This command will push the code that you have in your local repository to your remote repository and say enter. It will ask you the username for a GitHub, and this username you have already used when you have created a GitHub account. Okay, when you create a GitHub account, the username which you have created, you have to put in here. So my username is this. I'm using this. Okay, and say enter. Then it asks you the password. Now the password, you don't have to put the same password that you had. Okay, if I put the same password, look at it. If I'm putting the same password, it gives an error. Okay, it gives an error. So the here username has to be the same, whatever you have used to create your account, GitHub account, but the password is not the same. For password, you have to use a personal access token. You have to use a personal access token. So how to create a personal access token? Look at it very carefully, guys. Look at it very carefully. How to create a personal access token. Okay, guys, don't worry. Just don't do it right now. Okay, please don't do along with me. I think please some of you are trying to do along with me. Don't do along with me. You will miss the concepts. Srinivasan is saying, what is the use of git remote add origin? So I told you right just now. I told you git remote add origin is I'm just telling my local repository that there is a remote repository. This is a remote repository. You have to point to. I'm doing a connection. I'm just doing a connection between my local repository and the remote repository. I'm doing git remote add origin. I'm just adding a origin. Okay. So when you think this means easy to instance, need internet access. Yes, correct. Correct. So just follow the steps what I'm doing. Okay. Now I did a git push origin master to send my code from my local repository to remote repository, and it asked me my username and the password. Username I put it, but the password it is not working. So I need to generate a personal access token. So the question is how to generate a personal access token. So watch it very carefully. I'm telling you how to generate a personal access token. So just duplicate this. Let me duplicate this tab. Let me duplicate this tab. And here you see in the right side where your icon is there, where your icon is there, just select it. And here scroll down and you can go to settings. You can go to settings. In settings, you see, if you scroll down, if you scroll down, scroll down, scroll down, scroll down, in the end, you see something called a developer setting. Enter. Now, here you see something called a personal access token. You see, you have to create a personal access token for yourself. So select it and say tokens classic. Okay, and here you can see you can create a token. So click on generate a new token and say generate a new token classic. Okay, generate a new token classic. And here you have to give it a name. Okay, what this token is for? I'm saying this token is for DevOps demo. I'll call it DevOps demo. Anything you can put it. Anything you can put it. Any name you can put it. This token will expire for how many days? You can choose whatever dates. I'll put, let's say I'll put 90 days. So this token will expire after 90 days. Okay. Now select scope. What are the scopes? What can you do with the token? You can say. What are the permissions you want to give on the token? So I'll say all. We'll say people can work on my, access all my commit status. They can check all the public repositories. They can check the GitHub actions. Now these are GitHub actions and those things are different things. But I'll select all these things. But I'm giving all the permissions to my token. I'm just giving all the permissions to my token. Many permissions you will not even use it. But I'm giving all the permissions, I'm adding everything to the scope. Just select everything. Just select everything. Okay, do this in the demo. Okay, in your weekend, try to do this. And click on generate token. Okay, and my token got generated. Look at it. This is the token got generated. And what you need to do, you need to just copy this token and save it to somewhere. Save this token somewhere. Okay, at some place. Okay, because you will not see that token again. Okay, once you remove the screen, okay, once you close this window, you will not be able to see that token again. Okay, so since I have already noted down my token, I can close this. So now this is the password. This token is the password actually, which I can use. I'll copy this token and I'll go back to my PowerShell. Now I'll try to run this command again. Git push origin master. So using this command, I'm pushing all my changes from my local repo to my remote repo, which I have pointed out earlier. And say enter. And it now says username. I'll put my username. Thought and password. I have already copied the token. Paste it and say enter. See, now it worked. Now it worked. Now it says writing objects 100%. You can see the logs, and ultimately what it has done. It has pushed the code that I had in my local repository to my remote repository, and I can go back to my remote repository and actually see that. I can actually see that. Click on the code and look at it. Look at it. These files are here. These files I can see here. File1.txt and file2.txt. Okay, and I can check the commit history also. Look at it. Here is the master branch. By default, it's a master branch. So that's what my log says. It says that master towards master. Master arrow master means the master of your local repository, means the code that was there in the master of a local repository has been pushed to the master branch of your remote repository. And that is what it's done. So all the code which I had in my local, I can see it in my remote repository. Till here, is it fine or not? Till here, does it make sense or not? I'll use it. Don't worry, guys. Just go with the flow. Okay, just go with the flow. Till here is fine or not? Till here is fine or not? Now, since my code has been pushed from my local repo to my remote repo, now everyone in my team, everyone in the world can access this code. Since it's a public repository, I could make it private also. But now people can, now it's open for collaboration. It's open for collaboration. But too many things to remember. I agree. Manjeet, I agree. These will come in the flow. These will come in the practice. Okay. But try to understand. Today, your main aim should be understanding what I'm doing. Okay. Go home. Look at the demo again. It will be very clear. And whatever things I'm doing, it will be like you'll be doing it quickly. Why is saying once the files are pushed from the local repo to remote repo, does it mean that the file are not in the local machine? No, that does not mean Vani. That means the file are there in your local repo as well. You see, if I check my files, ls-lstr, okay, the files are there in my local repo also. But I have copied the files to my remote repo also. It's like uploading files to the Google Drive. Like if you upload a file to the Google Drive, the files are still in your laptop, right? You're not doing a cut and paste. So you're using copy. Right, Vani? That's means you need to hands dirty. Yeah, exactly. You need to have a dirty hands. You need to have your hands dirty, get your hands dirty. Mel is saying, where can we get config details in remote repo? Like who created it? In the remote repo also you can see. Look at it. If I go to the remote repo, it's not great. Why I don't know why it is putting Sam Kumar. I did not put Sam Kumar, but it says easy. Sam had done 2 commits. Commit number 2. And I can check the commits. Look at it. Click on this. And it actually says that Sam did a commit 1. Then Sam did commit 2. And I can actually, this is a very graphical way. Look at it. I can see what changes that did in commit 2. If I open commit 2, you can see hello got earlier. On the left side, it says this was the state of the file earlier. In the right side in green, you see this is the state of the file right now. So the change that was made in this commit number 2 is hello. Plus hello means hello was added. Got it? I went to GitHub account, I created my GitHub account and I went to settings. Remember, I went to settings. So these settings are for your whole GitHub account. Now in a GitHub account, you can have multiple repos. You can create multiple repository. So right now, the repository that we have created is demo project. So you can have 100 different repositories. So this person access token will be valid for all. Got it? Sandeep? Okay. So now what we have done? We have committed our changes to our remote repo. Okay. Now like this, if I want to draw like this, I can draw it like this. So I have, let's say, this is my remote repo. So what I've done, I did a git push. I used a push command and I pushed my changes to here. So the file came in here. Now this file is in the remote location now. It's in the remote repository. Now people from my team can see this. What are the changes? So people can go to my repository and can see. And now if someone else wants to work, okay, someone else wants to work. Let's say there is another user here. There is another user who wants to work. This is another user's laptop. Okay, just see that. Just imagine that this is another user's laptop. Now he wants to work. What he will do? He will be working on his own laptop. Okay, let's call it server 2. Okay, let's call it server 2. Server 2. In a server 2 also, he will do the same. He will create a folder. In that folder, there will be a working area, there will be a staging area, there will be a local repository. Okay. Now what he will do? He will, if this user wants to work on these project, so what he would do? He would bring these files to his side. So what he would do? He would clone this repo. He has to clone this repo to his local repo. Now this is user 1 and this is user 2. This is the local repository for user 1. This is the local repository for user 2. So user 2 has to work. He has to clone these changes. Means he has to bring this code, download this code to his local repo. Then he can start working on it. So let's recreate this scenario. Okay. So what I'm going to do, just to simulate two users. So I'm going to create one more instance. Okay, I'm going to create one more issue instance. I'll go to instances again. So I'll not follow the whole step. I'll not follow the whole procedure. Look at what I'm doing. I am selecting my instance. Okay, let's name it user 1 first. Okay, let's call it server 1. Server 1, not user 1. Whatever you call it, just name it. Okay, I am selecting this instance. And let's name it differently. Okay, I'll name it later on. So this is my user 1. So I'll select my instance. I go to actions. Okay, and there is something called image and templates. Again repeating, select your instance, go to actions, there is something called image and templates, and here you see launch more like this. So if you click on launch more like this, so a new instance will be created. Okay, you can give it a name, call it server 2. I'll call it server 2. Okay, and say, and other settings you don't have to do. It has taken the settings from the previous thing. You just need to put the key pair, that's it. Just use the same key pair. You can create a new key pair, you can use the same key pair, and other things you don't have to change. And say launch instance. So I just cloned my instance, you can say. I just created one more instance. Simple. So now I have two instances running. One is server 2, and we should have renamed it there only. Server 1. Okay. Now I am just mimicking two users. Okay. Let's say user 1 is working on server 1. User 2 is working on server 2. And we have already done the stuff on server 1. Whatever till now we were doing on server 1. So user 1 who is working on server 1, he has created files in his local repo, and he has pushed the file to the remote repo, and we can see the files here. Now let's talk about server 2. Means user 2 this is user's 2 laptop. Imagine this is user's 2 laptop. Let me connect to it. Let me connect to this user laptop. Okay, so I'll be saying that okay, this is my user. I'm using user2 from my browser. Okay, I'm not connecting with PowerShell. You already know how to connect with PowerShell. So this is my user. So as this user also, what I'll do, I'll create a directory. I'll do one thing. I'll not do anything. So this user has to bring the code in his laptop. Okay, this is my server 2. Look at it. This is my server 2. Now this user who is working on server 2 will have to set up his own local repository. Right? So what he need to do? He just needs to do a git clone. Okay. First of all, here also you need to check whether git is installed or not. So git will be installed because we have used the same version. So git hyphen version if you do. So you would see that. Okay, sorry. Git hyphen version if you do. You can see that git is installed. Okay, you can see git is installed. Now let me increase the font size. Okay. Now here this person has to do git clone. He wants to bring the code from his laptop from the remote repo to his local repo. So he'll do git clone and copy the URL of the repository. So where he will get the repository URL? So he'll go to code and this is the URL. Now this remote repo is accessible to all the users. Okay, this is my remote repo. Demo project is a remote repo and this remote repo is accessible to all the users. Like the concept of distributed version control system, right? We have again showing you one thing. Yeah, so local repo we have done. Now remote repo, all the users can access it. It's a remote location, so everyone can access it. So this user2 gets this URL, repo URL from here, and he simply does a git clone and get this command, git clone and the URL of the repo, and say enter. And you see, it is cloning into demo project, and a repo has been created at his site. He has cloned the complete repository. So if I do ls-lstr, you see the repository has been downloaded at his site. The repository has been downloaded at his site. Okay, so now if I go into this repository, now he does not have to do git init. He does not have to do git init. So he has downloaded his own repository at his site. He has cloned it. He has cloned the complete repository. And if I go inside this repository and if we do ls-lstr, so you will see file 1 and file 2. That means this user has downloaded the code of the remote repository. Now he can also let me set up the username and password for this user also. Okay, our command git config hyphen username and all those things that you have to do here also, because this is another user, right? For this user also I have to set up. This user will also set up. So let's call this user as Sam. I'll call this user as Tom. Okay, call it Tom. Okay, so I'll set the email also, user.email tom@gmail.com. Okay, now in this, now I have set up username and email ID for this user also. Now this user can also do git commands. We are right now in this user. Like now I'm a Tom user. Okay, now I'm working as a Tom user. Now this Tom user has this project downloaded and he can do git commands, right? He can run git commands. He can do git status. So basically there is nothing right now. Okay, nothing to commit. He can do git log just to check logs. You see, he can see that. So logs are also coming with it. So this person downloaded this whole project, this whole repository, and obviously logs will come with it. He can see that okay, on this repo there are 2 commits already done. There are 2 commits which are already done, and you can see these 2 commits were done by Sam, and you can see all the details. So that's what the benefit of Git is. Remember yesterday I told you in Git versioning is happening on local repo also, on remote repo also. So people can track the changes in their local repo also, and they can check the changes in the remote repo also. So in the right now we are in the local repo of Tom user. You are saying how many instances you can make? You can make any number of instances. That is not an issue. Now I'm saying so only when we commit in the remote repo, we need user permissions for cloning. So only when we commit in the remote repo, we need user permissions for cloning or copying. Okay, for cloning, you don't need permissions. So yeah, that is correct. That is correct. So that is saying that I did a git clone and it did not ask me any username password. Why? Because it's my public repo. Because the repository is a public. So that's why even you guys can download it. Even you can go to my, you can copy this URL. You can copy this URL and do a git clone, and you can download the code, download this code in your local repo. Okay. So what I did now, let's say this Tom user also wants to make a change. Let's say this Tom user also wants to make a change. So let's say he edits some file. He edits, he can see the file. Okay, if he sees the file, he can see ls-lstr, and I see file one and file 2. Let's say this Tom user makes a change. Okay, I'll do vi, he makes a change in file2.txt. Okay, inside file2.txt, I'll say my, okay, it's not saying anything. So just write anything. Okay, just write anything. Oh, it's not. Sometimes it will happen, guys. You will not be able to. So that's the issue with the opening of the browser. Sometimes VA editor will not work properly here. So I just use a cat command. Okay, I'll just use a cat command. Or let's say this user is creating a new file. This user can create a new file also, right? So the Sam is doing what? Sorry, Tom user is doing what? He's doing a touch. He's creating a new file, file3.txt. File3.txt. He's adding one more file. Okay. Now the concept stays same here also. So if I do git status, again the same story. Where the file has been created? The file has been created in the working area. The file has been created in the working area, and that's why you see it in red. It's undragged. This is a new file. So what you need to do? You need to do a git add. Simple. Okay. Now it has been moved to staging area. You can check git status, and it says it's in green. This means the file has been moved to staging area. Now you can do git commit -m and the message, commit message. So let's say commit 3. Okay, commit 3 and say enter. Done. Commit done. Okay. Now if I do git log, look at it. If I do git log, what do I see? I see 3 commits. I see 3 commits. One is done by Sam. Commit 2 is done by Sam. Now commit number 3 is done by Tom. So here I did a mistake, I think. Here email ID should be written. So I should be writing an email because I think I made a spelling mistake, you see. I did a spelling mistake. I should have put email. So that's why it has not taken my email. But ignore. You can see that just to make you feel that okay, the 3 commits happened on my no, see, first 2 commits were done by Sam. Okay, and this commit has been done by Tom. Okay, now what do you see here? Now this commit has been done by Tom, but has he, no, Sam does not know what Tom has submitted, right? So if Sam checks in his local repo, okay, imagine if Sam checks in his local repo, if he checks git log, will he be able to see? Okay, it got timed out, I think. Okay, this got timed out. So I need to, okay, this session got timed out, I think. So yeah, it got timed out. Okay, so now if Sam on his machine, if he checks git log, he only sees commit 1 and commit 2. But Tom on his machine, if he checks git log, he sees commit 1, commit 2, commit 3 because the third commit Sam has done on his local repo. This commit Tom has done on his local repo. But now, what Tom will do? Tom will push the code to the remote repo. Okay, Now Tom would push the code to the remote repo. Now you know how to push the code, right? You know how to push the, its command is git push origin master and say enter. Again I ask username password. No, username is same. Okay, username is the username of my repository. So username is puneet dot gmail.com. These are the credentials for my GitHub account. Okay, and password you guys already know. Okay, Pat, the person access token that we have created. So I'll use this. Paste it here. Enter. Done. You see, now Sam has created a file3.txt. He has done a commit, and now he has pushed the commit to the remote repo. Now, if I go to the remote repo, if I refresh it, look at it, it's showing, right? Tom. You see, Tom has done commit number 3, and file 3 has come up here. And you can see, if I check the commit history, you can see, first two commit 1, commit 2 were done by Sam, and commit 3 has been done by Tom. Okay, no, clear, fine. Okay, they are saying, what does this look like when there are hundreds or even thousands of commits? Will it look, no, it will not be a mess. It will not be a mess. Everything is managed. We'll be seeing it. Okay, till here I think is fine. Now Sam user, the user Sam, who right now does not know what is happening in the remote repo. He needs to update his repo. He needs to sync his local repository with the remote repository. Right? Because in his laptop, in Sam's laptop, it's not. Sam's laptop is not updated. Sam's local repository is not updated with the remote repository, because you see, if he's doing git log, he is seeing only commit 1 and commit 2, which he has done. He does not see, he is right now not aware of the changes that Tom has pushed to the remote repo. Okay, so what he would do? He would use pull command. He will use git pull origin which branch master. So you are pulling, this means that pull the origin. Origin means wherever you see the origin or wherever you see the remote, that means it is pointing to your remote repository. Origin, remote, everything means remote repository. And master is a default branch. So with this command what I'm doing, I'm pulling this SAM user is pulling the changes from the master branch, from the remote, in the remote repo, which branch? Master branch, and say enter. And look at it. It's saying file 3 came in. Look at it. Now if it checks, if I do ls-lstr, you will see file 3 got downloaded this time. Means now the local repository of SAM has been synced with the remote repository. Okay, now if we see git log, if he sees, you see, he sees everything. He sees that, okay, commit 1, commit 2, as well as commit 3, and you can see he can see who has done which change. He sees this first 2 commits are done by Sam, and third commit is done by Tom. So this is what collaboration is happening. You can see collaboration happening. Do you see collaboration happening now? You are able to track versions on your local repository. Sam has its own local repository. Tom has its own local repository. I can track, so everyone in the team can track versions on the remote repository, and everyone has access to this remote repository. Okay, everyone in the team will have access to this remote repository. They can track changes there also. And whenever they want to work on it, they will bring the changes to their, they will do a git pull that will download the changes from their local repo. And when they make a change, they will create a file, they will edit the file, they will make a change, and after doing the change, they will push the file, push the changes to the remote repo. Okay, clear? Does it make sense? Okay, now there can be a situation. So let's say again, so this is a SAM user. And from the SAM user account, I'm editing some file. Okay, I'm editing file 3. I have to go vi file 3.txt. I'll make a change here. I'll say I'll write something here. I'll say good morning. Okay, I wrote good morning 2 times or whatever. So again the same story. I'll do git status. This would show that the file is in working area. So I'll do a git add. The file will move to staging area. Then I'll do git commit -m. I'll give a commit message. Call it commit 4. Commit 4 and say enter. Okay, and you can see now the file is no longer in the staging area. The file has been committed, but the commit is there in my local repository only. Okay, so the SAM user has to push this. So you will do git push origin master. Okay, he's pushing the changes to the remote repo of which branch? Of master branch. Okay, username, password. Okay, password is the same. Done. Yes, pushed. Now if I go to my remote repo, if I refresh it, see I can see commit happened. Now I can see 4 commits here. See, I can see 4 commits here. But now Tom user does not know the changes. So still, if Tom user checks git log, so he'll be able to see only 3 commits. So that means he need to do a git pull. So he would do git pull origin master. So means he's pulling the changes from the remote. He's pulling the latest changes from the remote. Okay, done. File series engine came here. Okay, and he can check now git log. You see, now he can see 4th commit also. Okay, again, this was a kind of a repetition at it. Okay, I hope this is clear. I hope this is clear. Now, coming to the concept of, okay, see, branching concept I'll tell you tomorrow. Branching concept I'll tell you in the next session, but some other concepts. Let's talk about some other concepts. So there is a command if I want to revert a commit. Let's say I did a commit and then suddenly I realized, oh, I should not have done that. I should not have done that commit. So for that, you have a command to revert. So imagine SAM user has just now did a commit, right? SAM user has just now did a commit. So if I do git log, you can see that last commit was in by SAM user. Let's say this commit was not good. After doing the commit, SAM realized that this commit was a bad commit. So what he can do? He can do a revert. He can do a revert. So the command is git revert. Okay, these are commands are very self-explanatory. He'll do git revert. After that, he has to give the commit ID, which commit he wants to revert. So he can just copy this commit ID and paste it here. So Sam is trying to revert the commit number 4. So press enter. And this will open up a editor. This will open up a editor. Here you can put your comments. Okay, this is just to put the comments. So here the commit message. Okay. So what revert command will do? Revert command will create a new commit which says that, which is just roll backing the previous commit. So in the previous commit, if I did A, just to show you what is, say, imagine there are 3 commits happened. Okay, one extra commit did happen, and this commit I figured out that this commit is a wrong commit. So if I do git revert, if I made some, I wrote some in this file. If I wrote A, in this file, if I wrote A. Now if I revert this, if I have to revert this commit, what will do? Revert will create a new commit. Revert will just create a new commit, and it will roll back the changes that were done in the previous commit. In the previous commit, if in the file I wrote A, now this file, the A will be deleted from this file. Simple. Okay, let us see. Let's see it happening. So this has opened my editor, okay, where I can change the commit message. So I leave it as it is. Commit message is fine. It says revert commit number 4. And if you want to give any other thing, okay, you can give other things also. Okay, you can do other things also. So what I'll do, I'll just save it. So this has opened a nano editor for me. Okay, now you can do it in any editor. Okay, you can do it in any editor and just save it. Okay, I think it's not work or what. Okay, it got saved. Look at it. It says I did a git revert of this commit, and it says 1 file change and 1 deletion. That means in this commit, what I did, I added good morning. Right, in this particular commit number 4, I added good morning. And if I go to git log, now you see a new commit has happened. After commit number 4, a new commit has happened, which is just reverting my commit number 4. And that means if I go to my file which I changed file 3, right? Remember, I changed file 3. Now you see good morning has been deleted. So git revert is for that. Got it? Git revert is clear. How to save if it's a nano? So it depends on editor. Okay, Venkatesh, this depends on editor. So in a V editor, it's like you put semicolon and all those things. So do practice. Okay, practice it, you will get to know. So for me, by default, open in the nano editor. So on a nano editor, Control X works. Revert is nothing. Revert is just a new commit. Revert is nothing, but revert is just a new commit that is reverting the changes that you have done in the previous commit. If you want to revert it, so I did a git revert and the commit ID, and you can see the changes have been reverted. And these changes have been reverted only in my local repo. Okay, it's not like these changes have been reverted in the remote repo. These commit, revert is nothing. Revert is just a commit. Okay, nothing else. So see, I see a new commit, revert commit 4. This commit, I can see it here. But does my origin is updated with this commit? Does my remote repo knows about the revert I did? No. My remote repo does not know about the revert I did, because this is a revert that I have done, and this commit is lying on my local repository only. Now to push this thing, I have to just git push. Simple. You have to do git push so that you can send the changes that you have done in local repo to your remote repo. So thank you for attending today's session. Let's drop the session now. Thank you. Bye.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world, and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
Okay, so guys, today we'll be talking about things in more detail. What continuous integration, we'll be seeing demos, how to install Maven, how to run Maven commands. Then we'll see Jenkins, things about Jenkins, how to install Jenkins. Okay, these things we'll see today. Okay, now one thing I want to show you, I want to tell you, see, every code, if irrespective of whichever language you write the code, even if you write a code in Java, if you write a code in Python, if you write a code in C#, if you write a code in Node.js, if you write a code in PHP, if you write a code in Go language, any language. So the code will go through a process. Okay, code will go through a process. So the first thing that happens when you write the code, what you have to do, you have to compile it first. Okay, you have to compile it first. Okay, code need to be compiled. After compilation, after the code gets compiled, you have to do something called static code analysis. Static code analysis. Now, what does static code analysis do? See, you write a code in any programming language, let's say Java. Java will have its own set of standards, some good practices, which it asks people to follow. Now, if I say good practices, so that is relative. Good, the word good is relative, right? Some project, good practices will be something else. For some projects, good practices will be something else. So there are set of good practices that are for Java. Similarly, there are set of some good practices for Python. There are set of good practices for C Sharp. Any programming language will have a set of good practices. Those are rules. Okay, those are rules which are standard, which are created. And in static code analysis, you are just checking that your code is following those set of good practices or not. Now, if your code is following those good practices, you would want that, okay, it's good. Okay, then you're satisfied. But in case your code is not following set of good practices, so you might want your developers to improve the code. Okay, so that is the need of static code analysis. Static code analysis will analyze the code, okay, using some tools. There are many such tools. We'll talk about them, don't worry. Then after static code analysis, what we do? After static code analysis, we'll be doing some unit tests. Unit tests. In unit tests, what we do? In unit tests, you test your code, that whether your code is satisfying the business use cases that you implemented or not. Okay, so every code, we saw the code structure, right? We saw the coding structure that in Maven, what you have a SRC folder, right? You have a SRC folder. In SRC folder, you have main and you have test. In main, what do you write? In main, you write your actual code. For example, in this project, let's say we have this Java, com, DevOps demo. Okay, this is it. So there are a lot of files. In helper, we have some files. Okay, generic resource bundle. In this, we have some files. Backend, we have different files. Now, what are these files? What is the code in it? You don't care. You don't care as a DevOps engineer. What is these? So there are different files. It is just a code. It can be any code. Now, for every file, for every business use case, what you will write? You will write some tests. Where do you write the test? You write the tests under test folder. So in the test folder, you write all the unit tests. Okay, you write all the unit tests. So exception thrower, this, test generic comparator, test this, test this, test this. So unit tests are written here. Who will write unit test? That to your unit testing team, that your developers will write. Because this is a code only. You are writing a code here just to test your other part of the code. Simple. Okay, so here you write the unit tests. The test folder, you write the unit tests. Okay, now that these tests are run in the unit test phase. In this phase. So after static code analysis is completed, you want to run unit tests. Now, if your unit tests are done fine, then you want that, okay, it's good. Then if unit tests are passing, then only you will feel that your code is in a good position. Right? After running unit test, what do you want to do? You might want to verify that your unit tests are covering the part of code or not. So usually what happens? Usually we are saying, what is static code analysis? Static code analysis is just to check whether your code is following some good practices of the language or not. Okay, you are writing a code in Java, so it is checked whether your code is following good practices in Java or not. Okay, if you're writing a code in Python, it will check whether the code is following some good practices, some standards, what Python projects have or not. Okay, so then we do then you have unit test. After unit test, what we do? We can check our code coverage. Code coverage. No, these steps, what I'm telling you, some projects might have it, some might not have it. Okay, so I'm just telling you some standard code coverage. What is done in the code coverage part? In the code coverage part, we check the unit test that your developers have written. What part of the code, what is the percentage of code they are covering? It is advisable. It is advisable that your unit tests should cover each and everything that your code is doing. If I'm writing an application for login, if my code says if I write a code for login page, payments page, items page, card page, so my code coverage should cover each and every case. Each and every case my unit test should cover. So I should write unit test to test my login functionality. In login functionality also in detail everything. That I'll attempt to do some logins with some correct login credentials. I will attempt doing some logins with incorrect login credentials. Okay, I'll try to make a payment. I'll try to cancel my payment. Means unit test in detail. It will check everything. And it is advisable that the unit test should cover a good percentage of the code. So that's what is analyzed in the code coverage part. Okay, we keep a standard here, or again, it depends on project to project. So your project might want that your unit test should cover at least 80 to 90% of the code. Whatever code you have written here, whatever code you have written in main, so the unit test which you are writing in test folder, they should cover at least 80 to 90% of all the functionalities that you have written in this. Okay, so we check in the code coverage. What is it? How much percentage it is covering? Then after everything is done, we are satisfied. Like we have done a quality assurance. You mean we have done here? We have checked the quality of the code. It's okay. Static code. It's following good practices. Also, all the unit tests that I'm writing, they are also being tested successfully. Okay, and the unit tests that I've written, they are covering good percentage of my code also. So it's my software is good. Then I'm happy that I'm developing a good software. Right? After I'm happy, what I'll do? I will just package my code. Simple. I would just package my code into a executable. Means maybe it's a jar file, maybe it's a EAR file, maybe it's a WAR file, or different languages might have different executables. Different languages might have different types of executables. We can create a zip file, you can create a tar file, you can create different types of files you can create. Now, all these steps would come under CI only. All these steps would come under CI only. We'll talk about CI in detail, means I'll show you that also. But basically, these are the 4-5 steps which we usually do in the build process. Is it clear? One thing to perform unit tests, sometimes we might have dependencies as well. How do you handle that? So Maven handles that. Okay, these all things. You see, these 1, 2, all these steps can be handled by Maven. All these steps can be handled by Maven. Become saying what is the difference between unit test code and main code? See, unit test, for example, I'm giving an example. Let's say I'm writing a code. In main code, I'm creating an application for voting. Okay, let's say I'm creating an application for voting. My application registers the people who are voting. Okay, so in the main code, I'll write my code to voting. That age of the people have to be above 18. Let's say I wrote this, that the age of the person has to be above 18. Then I would write a test for it. In the test, I would write a test for this logic. I will test it using maybe 2 cases. I will test it using a case that, okay, I'll input the age of the person is 20. Okay, so this will give me output that voting allowed. The person is above 18, he can vote. Then as a second test, I'll pass the age of the person as 16. Okay, so this should give me false output. The person is not allowed to vote. Okay, so this is just an example. For every logic that you're writing in a code, there should be some test cases written for it. Because you write a code to implement some business logic that the client is saying. Okay, and in unit test, you write some tests to test the logic that you're writing. Does it make sense? Vikramjit, is it clear? Is it clear? Okay. So these were the phases. Okay, these are the phases. Now, if you talk about Maven and these, you see these five things. 1, 2, 3, 4. These will be done by different build tools. Build tools actually do these things only. And after that, later on, there's some other phases also. We'll talk about it. But if we talk about Maven, now we are studying Maven as a build tool, right? We are studying Maven as a build tool. Now, Maven has some steps. Okay, what Maven does. So that is called Maven build lifecycle. That is called Maven build lifecycle. So what does Maven do? So there are 7 stages in the build cycle. Okay, there are 7 phases in the Maven build lifecycle: validate, compile, test, package, verify, install, deploy. Okay, these are the 5 steps. These are 7 steps that happen in Maven build lifecycle. Okay, now what happens in validate? In validate, it checks whether the project is correct and necessary information is available or not. It is just validating your project. It is just validating your project. In compile, we already know what is compile, right? We already know what is compile. In compile, what happens? Maven will compile your code. Why does compilation is necessary? Compilation is necessary because the code you are writing, is in which language? Is in Java, right? The code is written in Java. For example, this is a Java code. You see, this is a complex Java code. Now this is in English, correct? This is in English. This is in English. Now tell me whether a machine will understand English or not. Your machine does not understand English. It understands binary 0, 1 byte codes or some machine language, right? Now this language needs to be converted into some machine language. So that is done as a part of compilation. So in case of Java, what happens? All the code is written in .java files. Okay, all the code that is written in .java files. You see the file names. Look at the file names. All the files are having .java, ending in .java. See, .java. Even in a test folder. Test is also code, right? I told you, right? Even in test folder, you see, we have .java. So all these are code. Now, all these files have to be compiled. So when you compile a Java file, .java file, the file that gets generated is .class file. Okay, so when .java file goes through a compilation process, a .class file gets created. Oh, that is in Java. Again, this process will be similar in other programming languages also. Python will do something else, C# will do something else, PHP will do something else, Node.js will do something else. Okay, so this is compile phase. But then what we have? After compile, Maven does test. So in test, what happens? Some unit tests are executed. Okay, unit tests are getting executed. So you write your test cases, like in the test folder. Then Maven picks up them and does some testing. And it'll give you results. That how many, if you write 20 test cases, then out of 20, 10 test cases might pass and 10 are not passing, let's say. Okay, so this is a test phase where your unit tests are run. Okay, compile phase, then test phase, then comes package phase. In package, a package is created. Okay, means package is what? Now all the class files have been created. Okay, class files have been created. Imagine I have 40 Java files. Imagine I have 40 Java files. Like some Java files are in test folder, some Java files might be in your main folder. Okay, 40 Java files are here, and let's say 30 Java files are here. So how many total Java files are there? 40 plus 30, 70 Java files are there. If you see main and test, imagine there are 70 .java files. So if we compile them, it will create 70 .class files, right? It creates 70 .class files. Now these all 70 .class files will be bundled into a zip, into a archive, into a package. It may be a jar, it may be a var, it may be a EAR. Okay, it is packaged or bundled into archive. Okay, so this happens in package. Then we have verify phase. In verify phase, okay, it runs any checks on result of integration test. So there is some. This is a verify phase. Okay, in this also there is some verification is happening just to ensure that quality criteria are met. So here you specify all those things just to check whether all the code is of a good quality. Okay, and then install phase. Now in install, sixth phase is install. In install, what happens? In install, your package is installed in the local repository. It's getting stored in the install is nothing but it's storing your package to the local repository. Remember, yesterday I told you this diagram. You see here, what I told you. Imagine this is a weather application. This user is working on weather application. So after this user compiles his code, builds it, package it, a artifact gets created. Remember, let's say artifact gets created is weather 2.0.jar. Okay, weather 2.0.jar. This is something called a package. Artifact is what? Artifact is just a package that gets created after your package step. After the package step. So we did a compile, we did a unit test, we did a code cover, means all the things we did. After that, we are satisfied. A package will get created. That package is nothing but artifact. An artifact will have a version. Let's say this artifact got created here, weather 2.0. So in the install phase, what is happening? In the install phase, what is happening? Your artifact that has been created is getting stored in local repo. Artifact gets created, that gets stored in the local repo. Local repo is a Maven repo. Okay, it's a local repo that we have discussed. That lies in your laptop. That lies in your laptop. So here your artifact is getting stored. Okay, so this happens in install phase. Okay, sorry. After install phase, there is a deploy phase. In deploy phase, what happens? Your artifact gets copied to remote repo. Okay, so artifact gets copied to remote repo. You see, now weather 2.0 that had been stored in the local repo by the install phase. Now this weather 2.0.jar file gets copied to remote repo. And once it gets copied to remote repo, it is visible to everyone in your team. Hence, if your another friend is working on some other application, he is writing a code for something else, and maybe he has mentioned that his code is dependent on your artifact. It's your package which you have created. You have created weather 2.0, and this person is writing a code for traveling website, and this traveling website code has a dependency on weather 2.0.jar file. Okay, so he will mention that it is format XML, and he will compile his code. While his code is getting compiled, Maven will download the weather 2.0 from the remote repo to his local repo. Then only this code will be able to compile. Okay, so install and deploy. What is the difference between install and deploy? What is the difference between install and deploy? Install is just installing your artifact or your package into your local repo. But deploying is copying your artifact to the remote repo. And once it is going to the remote repo, then the actual collaboration happens. See, all the DevOps tools that we are studying, all the DevOps tools that we are seeing, you will see a main principle behind them. A hidden thing behind it. A hidden motivation behind it. What is that motivation? Motivation is collaboration. So in GitHub also, we saw collaboration was happening, right? Everything gets stored. Everyone, when they are done on their local, they will push their code to GitHub so that everyone in the team can see that code. And whenever they want, they will download the code. They will start working on it. And after that, they will push their other code. So it keeps happening. So that is the proper collaboration. Collaboration is what? Collaboration means that many people in the team are able to work together, and that improves the speed of working and leads to better application. Is that clear, guys? Till here, fine. Everyone understands all these phases, all these 7 phases that we discussed about Maven. Does everyone understand? Validate, compile, test, package, verify, install, deploy. Now, in Maven, these are sequential. These phases are sequential. That means if I run test, so automatically phase 1 and phase 2 are run automatically. If I run install, that means the phases which are on top of install means validate, compile, test, package, and verify. These will automatically be run. If I run this deploy, all the steps which are above it, they will automatically run. Okay, we'll see that. It's just a hint that I'm giving you. We'll see that in action in a few minutes. Okay, about Maven repositories, we have already seen. Okay, what is the local repo? What is the remote repo? We have already seen that. Okay, now let's proceed on creating an issue instance and installing Maven there. Let's install Maven there. Okay, I see some people have raised hand. Just a second, I'll unmute you guys. Don't worry, I'll unmute you. Till then, let me start an issue instance. Okay, till then, I'll run my issue instance so that we can while the instance is running, you can ask me questions. Okay, I'm just launching an instance the same way we are doing till now. I'll go to launch instance. Okay, now this time what I'm doing, I launch a slightly bigger instance. Again, instance, this AMI, I'm going to use Ubuntu only. Okay, Ubuntu only. See, when you do the same we were using in every project, in every demo. Now, here, instance type we were choosing was T2 micro. T2 micro was a small instance. It was a small instance, but I want a bigger instance this time. Okay, because I'll do a lot of installations. Yeah? I will install Java also, I will install Maven also, I will install Jenkins also. So I'll do a lot of things. So I will play in a slightly bigger instance. So I'll go for T2 medium. Okay, let's go with T2 medium. Okay, this is having 4 GB of memory. It's having 4 GB of RAM and 2 CPUs. So I'll go with it. And beware, guys, this is important. It is not in the free tier. So this will charge you something. The price is very less. Don't worry. The price is very less. If you look at the price, it's charging you 0.1096 USD per hour. Okay, approximately 10 cents. 10 cents it will charge you per hour. Okay, so it is advisable that after doing the demo, just stop your instance or you can terminate it. Okay, stop your instance or you can terminate it. So if you stop your instance, then you are not losing anything. But if you terminate it, everything will be lost. Okay, so it's up to you. If you want to terminate it and redo it later on, that also you can do. If you want to stop it, then also you will not get charged for that instance for some time. Okay, so I'm going for T2 medium, and other steps are same. Other steps I'm not changing anything. So I'll select the 6 security group, and that's it, and say launch instance. Okay, now my instance is coming up. My instance is getting run. Okay, so Supermom is nothing. Now, if this is going into detail about Maven, Maven is just for Java, so you don't have to go into too much detail of it. But if you're interested, super POM is what? Like in case of some project, I'm showing you that project. Okay, don't worry, I'll show you. I showed that project in yesterday end of the session also. I think to someone was asking a question on that. But let's say I have a project like this. Okay, I'll show you that. Okay. I might have some project which have multiple modules. I might have projects which have multiple modules. For example, I have had a just a second. Let me get that repository that we made it clear. Oh, sorry. Your repositories. So I have a lot of repositories there. So there was one repository, maybe Maven samples. Yeah. Yeah. See, in this particular code, this is also project. This is the project. This is my Maven project. In this, if I go to multi-module and a single, now this is multiple complex symbols. Look at it. So there are multiple modules in my project. So this is my Maven samples project. This is a project called Maven samples. In this project, I have multiple modules. I have a single module. I have these are different modules. Okay. Now let me give you one more example. Okay, this is a bit complex. This is a bit more complex. Let me tell you one more thing. Yeah, take this example. This was one I was showing yesterday. This was one which I was showing yesterday. So yeah, look at it. Let's say I'm creating calculator. This is a calculator application. Now calculator might have different modules. We'll have addition module. It'll have a subtraction module. It'll have a multiplication module. It'll have a division module. Now I'm writing a addition module. Look at it. If I go to addition code, so in addition module, I'll write all my code related to addition. Now addition module, it's having a pom.xml. Now if I am into addition mode, if I want to build only addition, if I want to build only addition module, so I will compile this only. So this will give me a package for addition. Now if I want to build only subtraction module, so I'll go to subtraction, and here also I have pom.xml. Now this pom.xml is only for subtraction. Okay, so I'll build my subtraction code coming here. So this will build my subtraction code. Now I have a main pom.xml also. Means outside addition and subtraction, I have a pom.xml. Now if I build it here, if I run a Maven command here to build it, it will build my addition also. It will build my subtraction also. So here my parent pom is called this pom is called a parent pom. This pom is called a parent pom. Okay, and this parent pom will be calling these child poms. Okay, because you can assume calculator is a parent, addition, subtraction, multiplication, division, these are child modules to it. So addition will have a parent pom, addition will have its own pom, subtraction will have its own pom, multiplication will have its own pom, division will have its own pom. Okay, and I will have a main pom that is for my calculator. So my calculator pom is called a parent pom, and other poms inside the modules will be called as child poms. Okay, this is a structure also we can have it. Pawan is saying, what if we don't, what if we have non-Java project, does Maven work? So Maven is used only for Java projects. Okay, mainly it can be used for Java projects. So you can, with some tweaks and with some configurations, you can make it available to use it for C# and other projects also. But 99% of the time, you will be seeing Maven to be getting this for Java projects. Okay, so that's why you don't need to go into that detail about Maven. Don't need to go into that detail because you might want to work in some other project also in Python or in some other. So you can focus on other things. Okay, I mean that is all. No need to go into Maven that detail. So our EC2 instance is up. Okay, our EC2 instance is up and running. So what I'll do, I'll connect to my instance. Now you have multiple options. You know how to connect, right? So either you can connect using a PowerShell and all those things, or you can simply connect it from here also. Just select your instance, go to connect, and just say connect. Simple. Okay, it will open it in the browser only. Okay, let's go with this process only. Let's open it in the browser only. Don't need to go and open it in the. We'll clear the screen. So now commands to install Maven. Commands. First of all, I will log in as a root user. Okay, I'll do all the installations using root user. So I will do sudo su. Okay, if you run sudo su, this command will log you as a root user. So I hope everyone is compatible with Linux commands now. Everyone is compatible with Linux commands now. So see, earlier I was logged in as a Ubuntu user. Let me increase the font size. Okay, now I am logged as I did a sudo su and I'm logged as a root user now. Okay, I hope everyone is clear with the Linux commands. Okay, now commands to install Maven. So to install Maven, there is a prerequisite. There is a prerequisite. That prerequisite is to install Java. So means first you need to install Java, then you need to install Maven. Tinka saying, is Maven only for Java projects? I mean, Pinga just explained. I just answered this question a few minutes back. Yes, Maven is many times, most of the time, Maven will be used for Java projects. But with some tweaks and some configurations, you can also use Maven for other projects. Okay, but for other projects, you will use something else mostly. Okay, with Python, you will use something else. For Node.js, you will use NPM. You will use some other things in some other projects. Okay, so now commands to install Maven. So I'll share you these commands, don't worry. So first you need to install Java. Okay, so I have all the steps copied here. Okay, so you need to run these steps one by one. So I'm just copying these steps and running it. Okay, you need to first add the repository. You're adding the repository. It's saying press enter to continue. I'll say enter. Okay, after it is done, I'll run update. I'll run update. So these steps are for installation on Ubuntu. Okay, these steps which I'm telling you, these are the steps to install Java or all the applications on Ubuntu. So it is done. That step is done. After that, I'll run my step number 2. It's updating the repository. Now, if you are having some other operating system, if you have created an EC2 instance of some other operating system, the commands will change. The command will change. Now, here with this command, I'm downloading Java package. Okay. With this, I'm installing Java. You see, I'm installing front config, I'm installing OpenJDK, JRE, I'm installing JDK. Okay, I'm installing these. You can just use these commands only. Okay. Now, so installation is not that important. So this is the first tool that we are seeing. Okay, Maven is the first tool that we are seeing, and we'll be seeing tens and tens of tools in our use case, in our throughout the session, not the session, in our DevOps sessions. Okay, now every tool has to be installed. Right, every tool has to be installed. Now installation will differ based on different operating system. You have different operators. You have different installation steps to install the tool on Windows OS. You have different steps to install the tool on your Linux OS. You have different steps to install on Ubuntu. You have different steps to install on Red Hat Linux. So every steps are different. Okay, so don't remember these steps. No need to remember these steps. Okay, no need to remember these steps. So you can go to the documentation of that particular tool and you can find these commands. Okay, you can find these commands. These are the notes we did. Yeah, for this, I'll share the notes. No need to take the screenshot of this. I'll share this file. I'll share this. I'll share you this file. Okay. So my Java got installed. Okay, my Java got installed. Now, if you want to check the version, so check Java, or I can check later. Okay. Right now, I installed Java. Then comes setting up Java home. Okay, so I need to set up Java home. So Java gets installed in a particular directory. Okay, the directory is usr lib jvm. Okay, inside this directory Java got installed. Okay, I just installed Java and it got installed in this directory, user lib jvm. Okay, now no need to go into that. So you just need to know that okay, Java gets installed in this directory. And what you need to do, now you need to set up Java path. Well, use this command on line number 6. Copy this command and just paste it. So it is setting up a Java home, a variable called Java home. It's just an environment variable. It's just an environment variable. Okay, and this path I'm setting it to user lib jvm Java 17 OpenJDK. Means this particular folder. Okay, in this particular folder I have everything. All the Java related files, all the libraries and of the software are inside this folder. So I set it up as Java home. And then what I do, I will include Java home to the path. Okay, and then I will source my profile so that it gets incorporated. Okay, whatever the path I'm setting, that gets incorporated. Okay, after doing all these commands, so I copied one by one all these commands, right? I copied one by one, but you can copy all the commands and run it together also. Okay, just copy all, and just paste it here and say enter. All those commands will run together. Okay, now after running all these commands, I will just check Java hyphen version. Java hyphen version. So this will give me that okay, Java has been installed. You can see Java has been installed. So we are installing Java 17. Okay, you can install Java 11 or any other version also, but it should be greater than 8. That's it. Okay, Java version has to be installed which is greater than 8 because Maven works on Java greater than 8 version. So we are installed Java 17.0, not 9. Okay, Java got installed. Now after Java installation, so this was a prerequisite. This is a prerequisite to install Maven. You need to have Java installed on your server. So we have just followed the steps to install Java. Okay, now what we'll do? Now we'll install Maven. Okay, to install Maven, you need to follow these steps. Again, these are similar steps. So here, what I'm doing, I'm installing this version of Apache. So Maven is a tool from Apache. Apache is a company. So Maven is a tool from Apache. So I'm installing 3.9.6 version of Maven. Okay, now I can run all these commands one by one also. But what I'm doing, I'm just copying all these commands and running it together. Okay, so I'll copy all these lines from line number 12 to 17 and I'm just pasting it here and say enter. Okay, done. So all those commands run. All those commands ran. Now it took you, so the last command you see, last command is actually, it's taking you inside this TMP folder. You see CD TMP. It's taking you inside TMP. So that's why you are in /TMP folder. Okay, but if you want, you can go back to your folder again if you want. It is not important, but it doesn't matter a lot. But let's go into this folder because other installation we'll be doing in this folder only. /home/ubuntu. Okay, let's go back to /home/ubuntu. Okay, so our Maven got installed. Now, if I want to check Maven version, whether Maven got installed successfully or not, so I'll do mvn version, and this will give me Maven version. Look at it. This proves that Maven got installed. So, which version of Maven got installed? Maven got installed as 3.9.6 version. What is Maven home? Maven home is opt Maven /opt/Maven. Means this is a path where my Maven got installed. And which version of, so Java is a prerequisite. So which version of Java it is using? It is using Java 17.0.9, which we have just installed as a prerequisite. And what is the path of Java? You see, it's user lib jvm openjdk 7. This is the path. Okay, so we have installed Java and we have installed Maven. Is it clear? Dinesh is asking question. Dinesh is saying, can I use these commands on git bash as well? Yes, you can try using these commands. So on git bash, I think it's Linux, maybe yum on git bash. I think yum works. I don't think so. apt, check if apt get it's working. On git bash, check if apt get is working. apt command is for Ubuntu. Okay, we are using apt commands, right? You see, apt, you see everywhere apt. So apt is for Ubuntu. If you are working on Amazon Linux or some Red Hat Linux, their command will be yum. So we do yum install this, yum install Java, yum install Maven. Then we do yum. So apt and yum are nothing but they are package managers. Okay, they are package managers which are managing your packages. Okay, here in Ubuntu, are we using apt as a package manager, but in Linux, Red Hat Linux, and other machines, we use yum as package manager. So it doesn't matter. Only the command will change. Only the commands will change. That's it. Yeah, on Git Bash, you don't have to install Maven and Java. Yeah, right, correct. Yeah, that is right. On Git Bash, you don't. On Git Bash, see, Git Bash is on a local only, right? It's on a Windows machine, right? It's on a Windows machine. So you have to follow Windows installation procedures. So this is the command that I'm sharing you. These commands are only for installation on Ubuntu machine, the machine which we are using, Ubuntu machine. But if you don't want to install that Java and install Maven in your machine, in your laptop, where you're using Git Bash, so there you can go for using Windows step. Okay, how to install Windows? Just search on Google, and you can go to Maven document and check how Maven can be installed on. It's like installing any software. Like you install any software, right? You download a zip file, unzip it, and just exe file. Just install the exe file. That's it. So we've installed Java. We installed Maven. Okay. Now, okay. So in that case, you can raise a request to Intellipaat. So you can check with them what the process is. Okay, they will help you out there for sure. Okay. Now let's continue. So we have installed what? We have installed Java. We have installed Maven. Now let's continue. Now what they will do? What I will do? I have the code here. Now this code has to be compiled. Let me close it. I don't care about this. So this is our code. This is our sample Java app, which I was telling you all these. So I have all the code here. Let's say now a developer wants to work on it. Let's say a developer wants to work on this code. What he will do? He will go to the code. You know how to clone it, right? So this person would clone this repo. He'll copy this URL and he will go to his machine. Sorry, okay. Yeah, we were here, right? Yeah. So we have installed Maven, we have installed Java. Okay, both the things we have installed. Now, coming to my developer's point of view. Now, I am developer. I am a developer. So what I will do a git clone. I want to start working. I'll do a git clone. And I will just paste this URL and the sample Java web app will get downloaded. Now, if you go to cd sample Java web app, so I'm inside my Git. I'm inside my folder. This is my project. So I have cloned this sample Java web app from here, from my GitHub repo. And we have done it multiple times till now. We have done it multiple. You can also do the same thing at your side also. Okay. So if I see what's in there, so we have basically all the files. You can see we have pom.xml, we have deploy, we have other things are there. Right now, no need to worry about other files. The two things that we are concerned about right now is src folder and pom.xml. Nothing else. Just ignore other things. Just see only two things right now, src folder and pom.xml. And we know what's in the src folder, right? If I go to cd src, what will I see? I'll see main folder and test folder, in main app code and test app unit test, and we already know all these things. Okay, and let me go one step back. Okay, and here if you see again, I have pom.xml, and we know what is in the pom.xml. Pom.xml contains dependencies and all those things. Now, as a developer, what I would do, I would enhance it to write my own code. I might go to SRC folder. I might want to modify things. I might want to add few things, some more code. I will add some unit tests. And imagine I'm done with changes. Now I want to test. Now what I want to do, I want to test whether the changes that I have done, are they working fine or not. So what I do, I will follow these steps. Which steps? These steps. I'll do a compile. I'll check whether my code is following some good practices. I will run some unit tests. I will run some code coverage. Then after I'm satisfied that everything is working fine, then finally I'll package it. So let's do all these things with the help of Maven commands. Okay, so there are Maven commands for every step. So first I'll do mvn compile. So Maven command starts with mvn, and then you write what you want to do. So first I'll do mvn compile. Mvn compile will compile your code. Okay, so important thing is you have to run mvn commands where pom.xml is present. You have to come to the directory where pom.xml is present. There only you have to run mvn command, because again repeating, pom.xml is the heart of Maven. Okay, so right now I'm in the same directory as my pom.xml. If you do ls here, you see there is a pom.xml and I am standing here. So now I can run all the Maven commands. The first Maven command that I'm running is mvn compile. So this will compile. So Maven will automatically find all the Java files that are there in my code and it will compile them. So I'll do mvn compile. And you will see what will happen. You see what is happening. It's downloading. Downloaded from central. Look at it. What is doing? Downloaded from central. Now remember our concepts. Remember our concepts. What I told you. As soon as I run mvn compile, Maven is checking that are these files present, are these dependencies. Maven is checking that, Maven is seeing that your code is dependent on a lot of dependencies. Are these dependencies present in local repo? So obviously I'm running it for the first time, right? I did a compile for the first time. So obviously those dependencies will not be present. So Maven is downloading the dependencies from central repo. Look at it. It says downloading from central. This is. So it is downloading all these dependencies. These are all jar files. Look at it. Plexus, code, class, world 2.0, jar, compiler, and all these are. Look at that. So many dependencies. So many dependencies. All these dependencies have been downloaded to my local. And then after downloading all these dependencies, Maven is trying to compile all the 13 source code files. Okay, there might be 13 Java files. All those files are compiled, and the answer is success. It is successfully. The files have been successfully compiled. Okay, Mani is saying sample Java app is in the server instance you have created, right? Is that accessible to us anyway? I'll tell you how to clone it. Or you can just fork it. I'll tell you that. Don't worry. I'll tell you that. Understand right now. Don't worry about that. I'll tell you that. Don't worry. I'll share the notepad again. I'll share the notepad. Don't worry. I'll share the notepad file. Right now, I don't want to share right now. But after the session, I'll share it. Don't worry. After the session, I'll share it. They are saying where those are all listed in the pom.xml. Yes. In pom.xml, there are some dependencies that are listed. Now those dependencies will have some more dependencies. Those dependencies will have some more dependencies. You do not have to worry about it. So Maven is managing it. I don't care what this is. I don't care what is JUnit log4j I have mentioned in my pom.xml, but many other dependencies I have not even mentioned. So who's taking care of it? Maven is taking care of it. You do not have to worry about it. You just mention the things in your pom.xml and sit back and relax. You just run this mvn compile. That's it. And after compilation, it says build success. Okay, now if I run this again, look at it. If I run mvn compile, do you think it will download again? Let's see. It's not. Look at it. Did it download again? No, it did not. Because those dependencies on which my code is dependent on, they have already been downloaded to my local repo. Now, next time I'm running these commands, those dependencies which are already downloaded in my local repo, those are being used to compile my project. Again, answer is same, build success. So these are the actual steps. They are saying what are the updates about dependencies, what about updates to the dependency later. So now if you want to update these dependencies, you have, as a developer, have to modify pom.xml. So in pom.xml, you have the versions. If you look at the pom.xml, there are a lot of dependencies that you have mentioned. Okay, you see, for example, this. Just take a random example. Let's say this dependency. Org SL4, SLF4, this dependency. Oh, you have mentioned 1.7.7. Now let's say there is a new upgrade coming in. So you'll just change it here. 2.7, something like that. So Maven will automatically download that latest version of dependency. It's maintained by developers. Okay, DevOps person will not do it. It is usually done by developers. Okay. Now my code got compiled. Now if you look at my directory structure now, if we check how many what are the situation here, now you see all the files are still the same. All the folders and files are still the same, except this target folder. A target folder got created. Means as soon as you run any Maven command, as soon as you run a compile command, it will create a target folder. Now inside this target folder, you have all the things that Maven generates. So in our case, right now we will compile. So means all the .java files have been compiled to create .class files. Yeah, now if I go to target folder, it's a target folder. What you have to be concerned is about classes. Look at it. In this classes folder, you'll be seeing all the class files. Those are compiled files. Okay. You see, if I go to com, demo, let's open any. Okay, look at it. This is a class file. If I try to read it, let's have a look at it, how it looks. Let's see what's in there. Look at it. Can you read it? This is the content of my .class file. Can you read it, guys? Is it readable? No, right? It's not readable because it's some other, it's in bytecodes. It is it's a class file. You cannot read it. Okay, so I don't care. I don't care about reading it. It is just Maven is generating class files. That's it. Let me go back to my folder now. Okay. So I did a compile and a target folder get created. Now if I want to make changes and I want to clean it, there is mven clean command also. Mven clean. What will mven clean command do? Mven clean command is just cleaning your target folder. You see, if I do mven clean, it will just delete your target folder. You see, it says deleting this target folder. So it's just cleaning. Whatever the runs you have done, it is just cleaning it. So if you see ls here, so you see now target folder is deleted. Okay, so this was compiled. Okay. Understood. Is compilation fine? So I'll let mven clean also here. Okay, is compilation and cleaning fine? Are these two commands fine with everyone? Yes or no? Okay, now next step. Mven clean, no, mven clean is only used for cleaning. Mven clean will just clean your target folder. Now if you want to run, if you don't want to run, it's up to you. Okay, now we did mven compile. Okay, we did mven compile. So mven compile is just compiling your source code. Mven compile is just compiling your source code and it's creating a target folder. In the target folder, all your class files are getting copied. Okay, it's just cleaning your target folder. That's it. It's just deleting the things in your target folder. That's it. Srinivasan saying, can you please help to create form different from scratch, not needed. Serious, not needed, not at all needed. So mostly developers will do it. You will not do it. That is developer's responsibility. As a DevOps engineer, you don't have to do, because you don't know, right? Code you are not writing. Code you are not writing. So the person who writes the code, he will only know what his code is dependent on, right? When Pranad is saying, will it delete the dependencies? No. You're cleaning. Ambient clean is just cleaning your target folder. That's it. Nothing else. You see, I did a ambient compile again and it again created a target folder. And again created a target folder. Now, if you want to clean it, so it will start fresh. If you want to start from fresh, you want to build your code again. If you want to compile your code again, so you would want to delete your target folder. So you do ambient clean. That's it. Nothing else. Nothing else. Okay. Now next is what? Next is it's an additional step. Clean is just additional step. If you want to do, if you don't want to do, it's up to you. I just told you a command. It's there. Now next step was we want to do static code analysis. Now for static code analysis, there are various tools available in the market. They can be SonarQube. There is something called PMD. There are many tools available. SonarQube is popular. PMD is also used. So we'll use PMD. Okay, we will use PMD. So to use PMD, I'll give you the command mvn-p matrices PMD colon. This is the command you have to use. Okay, this is a command you have to use. Okay, now if I run this command, let me run this command. Okay, mvn-p matrices PMD colon PMD. Enter. So now it is downloading some more dependencies. For which dependencies? Now PMD is something tool. PMD is a tool. Now PMD will need its own dependencies. PMD is dependent on a lot of the things. So now Maven is downloading all the PMD and it is just now look at it. It is now if we go to the target folder. Now if I go to the target folder, if I open the target folder, now you will see something additional stuff. If I see what's in the target folder, now you see some additional things. These some files got created. Java unused code XML, Java imports XML, Java basics, and there's a called pmd.xml. Now if you open this pmd.xml, now this is XML. Now this is like a static code analysis of your code. Now your static code analysis of your code is done. And everything is reported. You see, it's saying that in this particular file, look at it. If you want to read it, now it's not very readable right now. It is not very readable right now, but you can, if you want to read it. Look at it. It's saying that okay, there is a file in this folder called contact services.java. Okay, this particular file has some useless parentheses. There's some useless parentheses issue here. Okay, there's a file called property helper.java. In this file, in this line, begin line 57, in line number 57, and in column number 10, there is some empty code. Okay, it's saying avoid empty code. So again, these are good practices, right? These are some good practices. Now, what are these? No need to care about it. You don't have to worry about it. What are these practices? Okay, so every programming languages will have some set of good practices. Every programming language will have some set of good practices, and you are evaluating your code against those good practices. Okay, you are evaluating your code against those good practices. Okay, so this is a PMD step. No, this is a PMD step because we are using PMD as a static code analysis tool. Now, in your case, you might be using SonarQube or some XYZ, there are many different types of tools. Okay, for every phase, even for build, we are using Maven right now. There is a Gradle also. There is Ant also. So there are different tools available for every phase. Okay, now you don't have to worry about all the tools. You focus on one tool and other tool will function like that. Right now, we are seeing PMD. PMD is a static code analysis tool. Okay, where you are doing the static code analysis of a tool, of a project, of the code, and it is generating a pmd.xml, and this pmd.xml contains all the details of your things that your project is following and the project and what the project is not following. It has generated an XML file for you. Now I know that this XML file is not very readable, okay, but later on I'll tell you how to use Jenkins to read it. Now look at it. This is a big file. Okay, this pmd.xml is a big file and it has a lot of things. Some issues, useless parentheses. Okay, some avoid eh, some issues it is pointing out. It's pointing out issues that avoid unused private fields such as logs. Okay, avoid empty cache blocks. Avoid this. No, this means that my code is not following some of the good practices. Okay, now I'm a developer, right? Right now, whatever I am doing as a part of developer only. I am making the changes to my code, then I'm compiling it, then I'm doing some static code analysis. Now, after looking at the static code analysis results that got created in pmd.xml, I know that what I have to fix. It is telling me in very detail that on line number 183, you have some this issue. On line number 66, you have this issue. On line number 98 of this particular file, you have this issue. It's telling me everything in detail. So I as a developer would make those changes, okay, and fix it so that my code is fitting those good practices. Does that make sense? Oh, right now, what I'm doing? Right now, my role is a developer. I'm sitting as a developer in front of you, and I am doing all the developer related tasks. I, as a developer, will write a code, will do some enhancements. Then, what I'll do, I will compile my code to check whether everything is working fine or not using ambient compile command. Then I'll run this PMD analysis on my tool just to check whether my code is following all the good practices or not. But right now, I'm doing all these steps manually, right? I'm going to the code and running, I'm cloned my code and making changes and doing this step manually, right? But later on, I'll tell you how to automate this all. Okay, this will follow and you can understand it like a story. Okay, watch it like a story, like a movie. What I'm telling you. Okay, right now we are on this step. Now, as a developer, what I did, I did the analysis of my tool, of my code. Okay, now if PMD says that okay, on this line, there are some issues that your code is not following some of the good practices of Java, so we'll just fix it. Okay, then I will run a unit test. Okay, then after fixing, now it's up to you if you want to fix or not. It's up to you. Now I will run my test, ambient test. Okay, I'll run ambient test. So what will ambient test do? Ambient test will test your code. Means the unit test that you have written, so those tests will be run. See, in my code, I have 23 unit tests. So tests run 23. Failure 0, error 0. So there were no failures. All the test cases have passed. So tests also run. Tests are also done. Okay. Now, if you check in target folder, so everything, you see, after every step, few things are getting created in my target folder. Okay, as a result of every step, few things are getting created. So as a test, as a part of unit test also, okay, few things got created here. Okay, test classes, you see, surefire reports, okay, jacoco.exec, okay, test classes, generate test sources. Okay, these things got created. Okay, now I can analyze. So it is showing me here only. Okay, I don't need to go into anywhere. It is showing me here only that okay, in my code, I have 23 unit tests, and all the 23 unit tests are successful. There are no failures, and it says build like success. So I, as a developer, am happy. The test cases that I've written are being passed. Okay, let's talk about these. We have only, so let's complete all these stages. Then about port PC, I'll take your query. I'll address it. Okay, if you're writing somewhere. So right now I am doing like this. So I'll tell you the concept of webhooks and how to automatically trigger it. Okay, those I'll tell you. Okay, so I'm telling you just commands, what Maven commands are there, because Maven is a build tool and Maven is integrating basically everything. Most of the things means all unit tests, all the coverage, and all the verification. So Maven is, you have Maven commands for it. Okay, that are written here. If your team now, I'll tell you how to learn Maven. I'll tell you Maven everything. So you are saying you have to learn Java. Okay, if you want to learn Java, if you are a developer, then you already know Java. If you are then let's say your team is working on C sharp. Okay, you move to a team that is working on Node.js. You move to a team that is working on Python. You move to a team that is working on Golang. So you cannot learn all the languages. Okay, you have to understand that you cannot learn all the languages. So you have to understand the basic things that happen. Like every language will have some compilation thing. Every language will have some matrices or static code analysis thing. Every language will do some tests, some verification, creating a package. So these are very basic things. Now, every tool that you will be using, a build tool like a Maven or an npm or any other tool depending on the programming languages, they'll have their own stuff. Okay, so that's why I told you, no need to go into that detail about understanding about the language, how to write a form, example. So mostly you will not do. If you're a developer, if you're a Java developer, then Java is your primary skill. Okay, then you have to know about Maven in detail. Okay, because you will have to fix it. You have to do mn compile every time when you are running a project. When you are fixing anything, when you're coding something, every time you have to run a mn compile, mn clean, mn verify pack. Every time you have to run it. But as a DevOps engineer, there is a very thin line. I know there is a very thin line, but as a DevOps engineer, you have to integrate all these stuffs. Basically, the role of DevOps engineer is to make developers' life easy. So, developer right now, whatever I'm doing, I am doing everything and I'm doing manually. Right, I am running ambient clean command. I'm doing ambient compile command. I'm doing ambient matrices this command. Ambient this command. I'm running all these commands manually. So, as a DevOps engineer, my role would be to help my developers to automate all these stuff. So there, Jenkins will come into picture. If you want to go into more detail about what is about details about Maven, like you asked how to generate Maven files from this form example from scratch and up of too much details about Maven. So there is no harm. You can know more about it. But understand what is necessary. You have to be very careful of what is necessary, what is important for a DevOps engineer. It's a static code as a tool. Okay, TMD is just a static code and as a tool. That's it. And there are many such tools. Many such tools. There is on Sonar Cube. Okay, and there are many such tools. Many such tools available in the market. So we are on test phase, right? We did a test. Okay, now test phase generated some things, few things. Okay, now I can see the logs also. Okay, tests that have passed. Now next step. Next step is verify. Next step is verify. I will do a verification. In this verify phase, what happens? What happens? Your code is being verified. Means, is it now? Remember about code coverage. Remember about code coverage? I told you. Code coverage is doing what? In code coverage step, what we have? We are checking that our unit tests are are they covering most of my code or not. So written the code, and I have to write some unit test. So in verify step, it is just verifying. When I will verify, okay, so it gives an error because there is, it says the goal specified requires a project to execute. Ah, sorry. See, why I'm getting error? Why? Because I'm executing this main command inside target folder. And what I told you, we have to execute our main command inside where? Inside our where my pom.example is present. So my pom.example is present in sample web app folder. So I'll do main verify. Okay, so this will initiate a verification process where it is just checking everything. You see? Yeah. So it created a Jacoco file. It means Jacoco dot exe. Okay. So it is just analyzing what? It is analyzing my code coverage. Okay. That how many unit tests I have written and what is the percentage of code my unit tests are covering. Okay. So a report gets generated for it. Okay. Now these steps developer will do sometimes not it. And again, there are many tools for it. There are many tools for it. Okay. So this is a verification step. Now finally, after everything is done, the person will package it. Okay. I will do MVN package. Okay. Now MVN package what will do? MVN package will create a jar war file. Look at it. It's creating sample.war. And how I know that sample.war is created? If I go to the target folder, now you see a sampled war file created. Now the sampled war file is your executable. It's your what you wanted. This is what you wanted. But how did you achieve it? We did all the steps manually to get what you want. Now, and that too on our local machine. I'm doing it as a developer. Okay. Now this can be install it. If I do mvn install, okay, this sample web app .war will get installed in my local repository. Okay, will be installed in my local. Right now, I'm not defined at my local repository. Okay, sorry. Is it? I don't have to run in target folder. I have to run all the mvn commands inside the place where I have permanent example present. So run mvn install. So this will install my war file into there, into my local repository. It's installed in. This is a local repository. You see, it's written installing this particular war file to this folder, to this folder, root.m2. So this is a local repository. And if I do mvn deploy will install my dependencies, will copy my dependencies to my remote repository. Okay, so basically deploy we are not doing. Deploy is a part of CD and all those things. So deploy, I'm not sure, but deploy we have to use some other a central repository. We have to map a central remote server. Then we need to install Nexus or some other artifactory. Okay, we are not covering that. Okay, but I told you, yeah, this is artifact. Exactly, this is what the artifact is. Correct, money. This is what the artifact is. Okay, now if you notice one thing, that if I run package command, all things happen. So I did a mvn package command just a few steps ago. Look at it. For example, mvn install. I did mvn install. What happened? It is scanning for the projects. It is building the project. Look at it. It's building the project. It's compiling the project. It is running tests. After running tests, it is doing a verification. You see, Jacoco. Jacoco is nothing but Java code coverage. Jacoco stands for Java code coverage. So it is just checking your code coverage. Code coverage also checked. After checking the code coverage, it is it created a package also. You see, it created a war file also. So that's what I told you. In Maven, what happens if you run any of the phase? So the phase previous to that phase also get executed. Okay, if I do any phase, if I do a package phase, package is on number 4. That means validate, compile, test. These all 3 are getting executed. If I do install, right now I did install. So it validated, it compiled my code, it did some tests, it packaged my code, and then it did a verify. And then it did install. Okay? Got it? Does it make sense, guys? Yes or no? Till here, everything is fine till now. So we have done all the steps parallelly till now. Or if not, we can end the session. Right? Thank you everyone. Thank you. Bye. Okay, thank you. Bye.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
So we are going to understand regarding Kubernetes, everything, how to do that. So if anyone asks simple question, what is Kubernetes? Kubernetes is a container orchestration tool. Okay. we are going to learn a lot of things. Okay, we have architecture. We will compare what is Docker Swarm and all those things. We are going to see in detail also something called as what is services, that is networking concept in Kubernetes. Then there is deployments. There are a lot of stuffs. Okay, there will be many things that we will say. We will have something called as an ingress, which will control the flow of the traffic. Okay, we have a lot of things which it will come later. But if anyone asks, usually what happens is when we learn Kubernetes in depth, later on, learners forget. Okay. In simple words, Kubernetes is container orchestration tool, enterprise level, production level, management. That we are going to do that in Kubernetes. Okay. See, initially Kubernetes was created by Google. It is open source. Open source in the sense the actual software is open source, but if you go to any of the public cloud, AWS, Azure, GCP, over there, they provide their own Kubernetes services. If we are going to use their services, we have to pay for it. But if you download the Kubernetes and install it by yourself, then it is not chargeable. But if you are going to use out of the box Kubernetes provided by them, then it is going to charge. It will be chargeable. Why? Because obviously they are providing it. It's their service. And there is one more reason that I'm going to discuss after we understand master and slave. So initially in the market, it was released somewhere around 2015, but Google was working on it from like 2002 or 2003 internally for its own projects. Later on, it got matured, and anyways, for the market, for the internet, it was released in 2015. And it is a very active repository. It is being contributed regularly by hundreds of software developers across the world. So what we will do, we need a discussion on what is the difference between Docker Swarm. This is just a simple discussion, but we will also have a discussion on in more in detail, like what is the difference between Docker Swarm and Kubernetes. Then we will have a discussion on what is the architecture. Say, what is cloud Kubernetes? First of all, Kubernetes can be installed in different ways. Okay, there is kubeadm. So kubeadm is one of the way. Another thing is EKS. The third thing is Azure AKS. Then you will have GCP GKE. Now there are multiple ways we can install Kubernetes. One is this is a tool provided by the Kubernetes itself. Kubernetes has provided this tool. This is free of charge. Then you have AWS EKS, Azure AKS, GCP GKE. Now, what is the difference between the AWS, Azure, GCP? The difference is installation is easy. If we use AWS, EKS, comparatively, I mean, if you just get used to it, this is also very easy. The main benefit is control node, or you can say master node, is managed by cloud provider. It's the responsibility of cloud provider. See what will happen in AWS EKS, Azure AKS, GCP GKE. Generally, the cloud, the control node, okay, the master node is managed by cloud provider. Master means master server, from where the management is going to happen. So if the control server goes down, it is the responsibility of the cloud server to bring it up. If any issues happen with the master node, they are responsible for it, to take care of it. We are not responsible. We are only responsible for the worker nodes. But many of the companies, like multinational companies, who themselves will have their own data centers, they will have their infrastructure on legacy systems. They will have their infrastructure on OpenStack. They are going to use kubeadm for having Kubernetes. Okay. And this, for practicing, this is for free of charge. We only have to pay for instance. But for all these services, you have to pay for each and every service, whether on EKS, whether AKS, whether GK. In GK, you have two categories, standard, autopilot. Standard means control plane is managed by the GCP. Autopilot in the sense both control and worker nodes are managed by GCP. It's just you are only going to deploy the application inside the cluster. So the nodes are here means instances. It's just the terminology. So the use of Kubernetes is container orchestration in the sense the use is you are going to deploy production level, enterprise level applications inside this cluster. And inside this cluster, what will happen? Basically, your management, how the traffic is flowing to your containers. Okay, there is a concept called as a pod, which we are going to come to later, how the traffic is going to flow inside your cluster from outside, how multiple applications are going to get deployed. There is namespace isolation. There is a concept called as a namespace, how your applications will further get isolated. Then how the deployment is going to happen. Okay, Kubernetes is the tool. Kubernetes is not container. Kubernetes is the tool. Inside that tool, the tool is going to create the cluster. Inside that, we are going to deploy our applications. Now, it provides features called as deployments, replica set. Then it provides networking features, advanced level networking features. It provides something called as ingress. Okay, so there are a lot of things it's going to provide. But in simple terms, it is a container orchestration tool. It is used to manage several containers, how to create, how to manage, how to delete, how to basically route the traffic from outside to inside. All those things will be done. Kubernetes was written in Golang. KubeADM is a tool on-premise in the sense that is an example for OpenStack. If you're going to use OpenStack, usually KubeADM will be used. Okay. For our demo, we are going to use KubeADM. It's just installation. After installation, you will have your own cluster and it is going to be the exact same Kubernetes production level cluster that we are going to see. Inside that cluster, we are going to discuss all the concepts. The concepts and the deployments will stay same. We are going to install this on EC2 server, but the instance type is going to be different. Kubernetes cannot be installed on T2 micro. The reason being it has certain requirements for CPU. So we need at least T2 medium in order for the Kubernetes to work. If we use T2 micro, there are some tweaks. People use it. They will reduce the CPU. They will reduce the other requirements and they will try to install it. But what will happen when we try to deploy applications, when we try to deploy ingress, it will not work. Okay. So I'm just going to show you the installation now of Kubernetes. Okay, see here everyone, the only difference is I'm using T2 medium. Yeah, this is the worker node. In the Kubernetes terminology, we will call master and worker. Okay. To install Kubernetes, we need to install from the root user. So in order to install it, the first step that we are going to do is we are going to do this vi etc hosts. So the first thing that we did is we went into /etc/host. Okay, here I'm just going to enter Kubernetes master, paste the private IP address of the Kubernetes. Okay, for both master and worker, we have to enter it here. Why we are entering here at this location? For local DNS to happen. So let me grab the IP address of the worker as well. So I'm pasting the IP address of master and worker, private IP address. Why? Because both are in the AWS environment. Same thing, I'm going to copy this. I'm going to come back to my worker node. And I'm going to paste this here. So these steps that I'm going to do, we have to perform at both master and worker. Currently, we are preparing the master. So see, if you have SSH, it's like 4 or 5 servers. Okay. So it's not a big deal. You open terminals, you do control and V. After this, I'm just going to install.sh. In this, I'm just going to grab the commands from the shared drive and we'll paste it. Same thing we'll do on the worker. I will tell you what we are doing now. Just give me a minute. Just pasting the same thing on the worker. Okay, we came back to master. Kubernetes prerequisites install. Okay. I'll just rename it so you don't get confused. We are just installing the prerequisites. We'll talk about this. Okay. So let this run. I will, in the meanwhile, we will say what is it that it is happening. Say what we are doing is inside this, currently we are installing the prerequisites. If you see here, Kubernetes, basically we are giving the location from where the Kubernetes tools should be installed. So for the Kubernetes tools, we are installing kubeadm tool that we talked about. Now there is something called as kubectl. What is kubectl? We will discuss after the installation. Then there is kubelet. This is an important component. This is basically a tool to interact with Kubernetes, and this is the tool to install the Kubernetes. Okay, we will see all these tools. So basically, we are installing the prerequisites before installing the Kubernetes. Now, what is this? This is going, there is something called as swap memory. Now, this is more of a Linux concept. This is more of a Linux concept. What we are going is we are disabling the swap memory because there is a component called as a kubelet. Now, this we will study in architecture. Here in the architecture, you see there is a component inside the kubelet. So in order, what is the purpose of kubelet? What it will do, that will come in architecture. So usually when the kubelet component is communicating across the master and slave, across the control and worker nodes, communication, it will have an issue. So we have to turn this off. After that, Now, these commands, basically what it is in the Linux, you will have these two modules. These are kernel level modules. Okay. These are kernel level modules. Now, this is responsible for networking, internally networking to happen. So we have to load these modules. Okay. After we load these modules, basically we are enabling the IPv4, IPv6 inside this so that the networking is happening, and this command is used to apply all the previous configurations. Now, after that is done, now, obviously, at the end of the day, inside the Kubernetes, we have to run the container. Okay. In Kubernetes, I'm going to discuss the smallest deployable unit is pod. What is a pod? We will see. But inside the pod, again, the container is going to run. So from the Docker, we have a container engine, something called as container D that we have to install. So using this, the containers will run inside the Kubernetes. So this is a component which needs to be installed. So that is what we are doing. We are installing that. And after that is getting installed, we are restarting it. So these are like all the prerequisites that we are basically taking care. So let me just install this. So both of the things we are doing this on master and slave, master and worker node. So APK mark means hold means that whatever the modules kubectl, kubeadm, kubelet we have installed, okay, whatever version I have installed, I don't want any automatic installation, any automatic update to happen to those versions. So that is what it means. It will just, whatever I'm installing, it will just hold that version. That is a Linux command. So we are installing version 1.28. Now 1.29 will not get installed automatically without my knowledge. Okay, no automatic update kind of a thing will happen. Now after this, so we are entering the command here. This command we are entering, it will not do the update automatically. So both master and server we have installed prerequisites. Now say this kubeadm init. This is the command which using which we are going to I'll grab the IP address. All right. Hyphen IP address is sufficient. Now this command is used to initialize your Kubernetes cluster. Kubeadm init hyphen advertise address followed by the master IP address. Okay, basically this is the master IP address. That is what we are giving here. What is pod network CIDR range? Basically, the container is going to run inside a pod in Kubernetes, and they will have their own IP addresses. So basically, we are giving this range. This is a standard well-known range. So all the IP addresses for your pod, okay. What is a pod? You do not have an idea. You can consider all your containers are going to get IP addresses from this range. This is the standard range. What is it? kubeadm.com. No problem. kubeadm is there. Spelling is wrong. And this command is only to be run on the master. Okay. See here, it is initialized, everything is done. It will just give you this. Okay. Successfully initialized. Now it will give us some instructions. That instructions is fine. The main thing is here. It will also give you a token. Copy this token. Go to your worker node. Paste it. Then it will, what does it say? This node has joined the cluster. Okay. You can go back and you can see what you can see. This is the token. You need to paste it onto the worker node. Okay, this is done. See here. Currently, we are in the root user. So obviously, I do not want to run all my operations from the root user. So I do not want to use Kubernetes from the root user. I want to use it from the Ubuntu user. What I have to do? Just copy paste this command. So this command is being showed here, copy paste it. Just copy from here and paste it here. What will happen if we are going to paste this commands? You will be able to interact with the Kubernetes cluster from the Ubuntu user. You don't have to be in the root user. That is what is going to happen. Okay. And finally, for the networking with respect to Kubernetes to happen, we have to apply kubectl. Now I will confirm this. Say, so this is the command that is used to check what all different nodes, master and worker, are there inside your cluster. Okay, your master is your control plane. Your worker is your worker node. All right, that's the thing.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
I'm just turning on instances. So today, Sachin Tyas, we are going to understand what is Kubernetes. Then we are going to see something called as Kubernetes dashboard. And if we have time left, I'm going to show you how to integrate with Jenkins. The full flow we will see, Docker, Kubernetes integration, and how the deployment will happen if we have time. All right, the instances are up. Let's first discuss what is a namespace. Okay. So in Kubernetes, we have a concept called as a namespace. Basically, it is a feature which is provided by Kubernetes. So what will happen using a namespace inside Kubernetes? What is the use of it inside the Kubernetes? So the benefit of namespaces for isolation and segregation. Okay, it is basically providing us a method, a way on how can we logically organize and isolate resources for different projects, different teams, and even with respect to the same project, but isolating and segregation. So what do we mean by that? How are we going to organize, logically organize inside Kubernetes cluster, or how are we going to isolate the resources? So the answer is this. Suppose we create two names. How to create, we will see hands-on. Suppose we have three namespaces. Okay, if you want, we can have, I can deploy an application. Okay, that is your deployment. I create a namespace, and inside a namespace, I deploy this called as application. Then after that, within the same namespace, I'm going to deploy service. Okay, I'm going to deploy service. After that, whatever you're going to deploy, whether service, whether replica set, whether some other object, or you're going to deploy anything inside this namespace A, for example, that will not be visible anywhere else. Suppose if I want to access this deployment, this application, which I have deployed inside namespace A, I have to go inside namespace A, only then I will be able to access this application. So by default, namespaces are isolated. Okay, I cannot be in namespace. I mean, if I want to access, suppose I deploy application B, for example, inside namespace B, and so on and so forth. I deploy the respective service of application B in namespace B. In order for me, I mean, services are cluster wide, but this service will be deployed inside namespace B. If you want to see what are the services deployed inside namespace B, we have to mention namespace B. Okay, so what is the use of this namespaces? Basically, the use is that it is helping us to logically organize our Kubernetes cluster so that we are able to put different things inside different namespaces. Why? Because suppose you have 20-30 applications, then all 20-30 applications you will have in one particular namespace. Then 20-30 services will be there. Then 20-30 again, whatever the relevant, ingress rules are there, that will be there in the same namespace. So it is going to become cluttered. So instead, we can have multiple namespaces and we can put some application in some namespace, another application in another namespace, so that it is easier to manage. Okay, easier to manage. Now, how to create a namespace, how to deploy inside a specific namespace, we will see. And by default, okay, by default, what is going to happen? Whenever we are going to deploy anything, whenever you are going to deploy anything inside a specific namespace, what is going to happen? Suppose I am not going to mention namespace A, namespace B, namespace C. I am deploying an application. By default, it will be deployed into something called as default namespace. Okay, we will see this today. So if you are not going to mention which namespace your application should be deployed while deploying the applications. So by default, it will get deployed in the default namespace. We will see this. So let me share the screen. That's right, Panavar. In default, Ingress yesterday got installed in Ingress-Nginx namespace. See here, everyone. When I'm doing kubectl get pods, I'm getting this. This is nothing but we have not defined the namespace here. Okay, anywhere I have not defined. If you want to define namespace, this is an option -n to see specific things. See, I'm going to type this. We got exactly the same thing. Okay, see. So if the application is deployed inside the default namespace, we do not have to give -n default. By default, it is going to come here like this. I'm going to create a new namespace. Okay. I'm going to create a new namespace. What I will do now is I'm going to deploy the application inside the new namespace. Okay. So in order to do that, this is the command kubectl create ns means namespace. Okay, maybe I will say web. So what does it say? Web namespace created. Now we have all these different manifests. We have pod. We have different manifests. Now how to deploy this particular any object inside Kubernetes? Pod, replica set, deployment, services, anything. How are we going to deploy inside the Kubernetes specific namespace? So there are two ways. I'm going to show you this. The first one is you can go here inside the pod manifest. You come here and you type it here, namespace. I'll type as web. Okay. Inside the manifest, we type here namespace : web. Then you can do kubectl apply -f pod.yaml. Nginx -pod got created, right? So where did it got created? It will create in your web namespace. I'm going to show you. See, first let us do this kubectl get pods. Obviously, I am not able to see it. Okay. Obviously, I'm not going to see it. So Manasvi, I'm going to show you other method also. Okay. Obviously, we are not able to see here. So how can we see? -n web. Say here kubectl get pods -n web. See this? So I am able to see Nginx pod that we have just now created. And how am I accessing it? By entering -n web. By entering -n web. Now I will delete this. All commands remain same. How to delete? pod/nginx -pod. The only thing is you need to mention inside which namespace. Just add this option. Apart from this, all the previous commands remains the same. So this pod exists in the web namespace. So I'm going to delete here. So it says deleted. Okay. If I do kubectl get pod -n web. So currently I am seeing no resources found in web namespace. Isn't it? Why? Because we have deleted it. Now I'm going to show you other method also. So I'll remove this line. See this, I will deploy the same object, kubectl apply -f pod. Okay. Now if I press enter, it will get deployed in the default namespace, but I don't want that. I want to deploy this into web namespace. So what is the method? -n web. You add the namespace name, in which namespace you want to deploy. So if you're not going to give that inside the manifest, when you are going to apply it, just mention -n and web. -n web. Okay, see? Till it got deployed. So whichever is more convenient, you can use it. Okay. As a general rule, usually inside the GitHub, you are going to mention inside your manifest itself. That's a general thing. But these are the two ways. Anything which is more suitable, you guys can use it. So this is something called as a namespace. Okay. We will now discuss something called as Kubernetes dashboard. And we will see how to deploy applications using GUI. So config maps and volumes are not covered as part of your courseware. Once I finish all the topics, if we have enough time, we are going to see for another. So Prithvi, your question is out of the courseware. You want something maybe for your specific task. To the end of the class, I'm going to give you a command. You can use it. Okay. What we will do now, the Kubernetes is providing something called as Kubernetes dashboard. Okay, it is a GUI thing wherein we can see a lot of things, like visual representation of the cluster, and we can deploy our application using the GUI itself. So we are going to see this. Okay, how to do it. All right. So I'm going to apply the manifest given by the Kubernetes itself. And we are going to see further on the next steps, what needs to be done. So one FYI, see, even though we can deploy from Kubernetes dashboard, okay, but in real time, the command line based knowledge is more preferred with respect to interviews as well as with respect to troubleshooting that you are going to do. GUI is there, it will deploy, it will show you the overview, but it is not everything. So I will just apply it. So let's put it this way, I'll copy and paste. So this software is going to run something called as Kubernetes dashboard component, which is the exact actual software. And the service by default for Kubernetes dashboard is going to be cluster IP. Now, obviously, we want to access it over the browser, okay, for the practice. So I'm going to change it to node port so that we can see Kubernetes dashboard over the browser. So this is another command. I mean, we can directly go live and we can edit this. Edit. So this is the live, whatever is the configuration, it is live. So just I'm going to change this. Okay. 30082. We will try to access this and we will see. Dashboard is accessible on HTTPS. One moment. My fault, the port number is wrong. Okay. So there are two methods to log in into Kubernetes dashboard. One is token and one is kubeconfig. What is kubeconfig? We are going to see this when I'm going to integrate Docker and Kubernetes with Jenkins. Okay. For Kubernetes dashboard, we will just create a token in order to log in. So how are we going to create a token for Kubernetes dashboard? We are going to see that. So live manifest is nothing but it is like the services is deployed. It's just a cluster IP service which got changed to node port. The type we are changing. So we have already seen how to create a cluster IP service. We have already seen how to create a node port service. Okay, this is basically service itself. It is applied inside the Kubernetes. The only thing you have to do is you have to enter edit command. Okay. So it is nothing but service. If I scroll down, it is just going to have metadata information like what is the namespace it is created, what is the label, when it was created. Okay. So because it had created cluster IP, so what is the IP address? Now everything was there, but node port I had to change. Okay. Selector we have already seen. All this is default information. Just change the type to node port and this port number will get created. Yes, that is metadata information. See, it is inside your metadata. Uniquely, it is going to create. That is for internal Kubernetes, not for us. Okay. So we are going to create something called as a token. Token is nothing but you can consider like a password. Okay. We need to create a username and password for Kubernetes in our dashboard in order to log in. So inside Kubernetes, how to do that? For that, we are going to create service account. This is a command for it. I'm creating an account with the name dashboard admin. Okay. -n Kubernetes dashboard. So this is a command using which we can create an account. I'm giving the name of the account as Kubernetes, dashboard admin for Kubernetes dashboard. Okay. Not exactly JWT token, it's token. Earlier it was different, now it is different. What's the token? kubectl create. Okay. Now I have created this account. I have given the name as admin, but admin permissions are not there to that account. It's just the name of the account is dashboard admin. Now I am going to give permissions to this particular account. I will give permissions to this particular account. So how to give permissions? This is the command. So here, what we have done is in this command, okay, I have given this particular account that we have created. To this particular account, I have given the cluster admin permissions. Okay, I have given cluster admin permissions for the Kubernetes dashboard namespace that to this account. Okay, dashboard admin account exists in Kubernetes dashboard namespace. Okay, it was created over there. Okay, anyways, so I have given the cluster wide access. In the sense, I have given the cluster admin access to this particular account. So why I have given admin access? Because so that we are able to deploy inside the Kubernetes cluster. Okay. After we do that, we are going to create the password for it. Password in the sense we are going to create token for it. So to create token, we will say create token. This is the name of the account. So what has happened? Token got generated. So we'll copy this, paste it, click on sign in. So we can see on the top right hand side, yes, keywords are predefined. But we are not going to decrypt token or else there is no security. I mean, that we should not do this. Say here, we have logged in using the dashboard admin account. We have logged in using dashboard admin account. Okay. And this is the general view. For example, currently I can see in the default namespace, Nginx deployment is okay. Yeah, Manohar, I will explain. Please repeat the token part. Okay, I will explain with flowchart. So the first thing is, it is going to show you inside your Kubernetes cluster what are the things deployed. For example, in the default namespace on the top, we can see that deployments are done. Okay. So for one deployment, obviously, there are 3 pods. See, there are 3 pods. So inside the deployment, you have a replica set. Okay. Inside the replica set, you have your pods. Anyways, see what we are going to do. Suppose I want to edit this deployment. Just click here, click on edit. Okay. So you can edit the like manifest if you want. You can edit the like manifest from here. Suppose you want to restart the deployment. You want to restart this particular deployment. You can restart it from here. If you want to delete, it will get deleted. If you want to scale, okay, instead of 3, I will put like 5. Click on scale. What it will do? Within couple of seconds, what it's going to do? It is going to run. See, now earlier there were 5 pods. I mean 3 pods. Now 5 pods are running. See? So what does it say? 14 seconds, 15 seconds. Also, yes, new things also we can create. Suppose inside a particular pod, I want to go inside particular pod. Go to pods. See this on the right hand side. Click on logs. You can see all the logs. So obviously there are no logs, it is not showing log. Obviously there are no logs, it is not showing logs. Maybe we will deploy a new thing, so it will show logs. Anyways, see, I want to go inside, click on exec. So what has happened here? You're directly inside the what has happened? You are directly inside your container. So you can do whatever commands you want. We don't have to type kubectl exec -it pod/pod name -bin bash. We don't have to do that. You can directly come here and type whatever you want to do. Then you can go back. Apart from this, suppose you want to delete the pod, you click on delete, it will get deleted also. Okay. Suppose we want to create new things in the sense, or else we can browse different namespaces also. That is also possible. Just select your ingress, nginx, whatever. With respect to namespace, deployments will come. So if you want to, this is the main part. On the top right hand side, we see this plus symbol. On the top right hand side, we see this plus symbol. Click on this plus symbol. Okay. Now we have couple of methods for creating any object inside the Kubernetes cluster. So when you click on plus, what you can do, you can define what you want to paste. So I'll paste one of the manifest maybe. We already have manifest. Okay. We already have manifest. What we will do, I will copy maybe pod manifest and it's okay. From the terminal. So just paste it here. Okay, just copy it, paste it. Maybe you will have it on your GitHub. You copy it, paste it, click on upload. So we will immediately see that the resource is getting applied now. Now it got applied. See, just now this got applied. It also shows where exactly the pod is deployed. Like what is the label? Obviously to a pod, we have not given a label. What are the labels? What is the status? Has it got restarted? Is the application using how much CPU, how much memory? Obviously, applications are not processing anything. That is why it is not showing here. So what happened? This Nginx pod got deployed. You click on it, it will give you more information. When was it created? What is the current IP address? What is the IP address? Okay. It is going to give that. Even events, kubectl describe. You don't have to do events. All the information will come here. Okay. Suppose I will click on this plus again. Anything you want to deploy. Maybe you want to deploy services. You want to deploy cluster IP service maybe. So if you want to deploy cluster IP service, maybe I'll just copy from the terminal. I'll bring it up again. So what you will do, you are just going to go to your GitHub and you are going to copy. So I copied, I pasted. So you just have to paste it here and then you are going to deploy it. So how to deploy it? Just click on upload option. These are not commands. These are manifest configuration files. These are already uploaded on the shared drives. Okay. So what has happened? We have deployed, it got deployed. Okay. So any object inside Kubernetes you want to deploy, click on plus, paste it here, and click on upload. It will get created. Now, second method is you upload those manifest file. Okay, usually we will not use it. YAML files, which we have in the terminal. You click on upload and upload it. Then you have this also, like instant creation. Like what is the application name? Application name is Nginx. What is the container image? Maybe application name is like Nginx. 1, 2, 3 something. Container image is nothing but your Docker image. How many parts you want to create? 2 parts. You want to create any services for it? internal, external, all those. Click on deploy. Okay. Now, usually create from form is very less. Usually we will not use that option. The Nginx 1, 2, 3 got deployed. So Rajesh, the answer is companies will use both. kubectl commands are not only used for deployment, it is used for troubleshooting also. Dashboard means you're deploying, you're viewing everything, that's fine. Companies will use dashboard, but kubectl will always be there. Yes, app name is Podnet. Okay, I will explain you the flow. Okay, step 1. Deploy the Kubernetes dashboard manifest. Okay, it is there in the shared drive. You have to do kubectl apply to it. Step 2. Okay, deploy the Kubernetes dashboard manifest. What is step 2? Step 2 is we are going to create the account. Okay, no, first for practice. Okay, this is for practice only. Make the service to node port. This is for practice. Step 3, create service account. Step 4, okay, give permissions to service account. Step 5, create token for service account. Token in the sense you can consider as password. Okay. For everything, we have a command, and all the commands are listed in the shared drive. This is the flow. First, deploy the Kubernetes manifest. For practice, made the service account to the node port. Step 3 is create the service account, give the permissions to service account, then create token for that service account. After that, step 6 is going to be paste the token in Kubernetes dashboard. Then you will be able to log in. Okay, this is the flow. We will also see now like how to integrate Kubernetes, Docker inside Jenkins and do like a CI/CD flow automated with webhook records. That is what we are going to see. Yes, you will have access. It's my personal shared drive. I mean, I've kept it like that. You can access whenever you want. You can download the whole shared drive. I mean, build access is there. You can download the documents and keep it for yourself. So I will show you how to integrate this. Whether you use PowerShell or command prompt, the condition is that you need to do SSH inside your Kubernetes cluster. Once you have access to your master node, then you are going to do all this inside your master node. We'll just wait for Jenkins to start up, and then I'm going to show you how to integrate it. Okay. We can't do that. That will not happen in real time. Kubernetes cluster we will not touch with anything else. Okay, it has come back up. Whatever is the application, the process and the flow will remain same. So we'll see if we have enough time for another, we will see. No worries. In today's class. Okay. So we are going to adjust this. The first thing is, okay, we have git clone of our repository. Okay. Second thing is we have GitHub debug trigger, which we will see how to configure this. The third thing is after this, we will use something called as secret and files. What do you mean by secret and files? We are going to add credentials for the Docker. Okay, for Docker Hub, we have something called as username and password, right? But I don't want to type username and password in plain text. So what I'm going to do, I'm going to write username and password in the credentials I will use so that I don't have to use username and password in that way. Okay, so I will add the username and password now so that it is easier for us to use it inside our job, and we do not have to use something called as plain text. Okay, click on username and password separated. I'll write maybe Docker underscore username. Okay, the second thing is I will write Docker underscore password. These are my own variables, so that whatever the inside the credentials, I'm going to type the username will get saved. I mean, it is going to get fetched under this variable. The password is going to get fetched under the Docker underscore password. All right. Okay. So click on add if it's not added already. So it's not added. Scroll down. See this in the username. I will say my username. The password, it's my Docker Hub password. I will just say Docker Hub threads. Docker Hub credentials. Okay. Yes, this is Jenkins. Using Jenkins, we are doing CI/CD for all the components. Okay. So after we are going to add this, what we are going to do, password names are all of Docker means. I mean, I'm not going to write in the execute shell or something, right? I will not say Docker login -u like this or -p. I'm not going to write actual password. Why? It can be seen in console output. I can't write my password. This is not secure. So that is why we have added the Docker username and password in the credentials. We will fetch it from there. Okay. After that, what is the next step? We scroll down. Maven, we already know. Okay. Then after Maven, we are going to see this. What do you mean by tags? I will just put pwd just to make sure we know where exactly the job is going to run. And also I will run this on slave 1. Okay. So I'm going to enter a couple of commands, but those commands you should know. So first what we will do, I will type the command, but the thing is that we should know what is the use of that command. Okay, I'll just save this. We'll come back to it later. I will log in into the slaves. Okay, this is Jenkins slave. Okay. So we already had that Maven plugin installed. See here what I'm going to show. I will grab the repository. Now it's going to be always different. Docker username password will always be different. I will just clone this repository. Okay. I will show one command so that you are not shocked what we are doing. So this is the repository. Okay, I want to know what is the latest tag number. Okay, latest tag number. If I just do git tag, I'm getting so many tags. When I don't want this, I only want to fetch 1.6, whatever is the latest tag number. Every time the job is going to run, it should always fetch the latest tag number. That is what I want. It should always fetch the latest tag number. So how are we going to get the latest tag number? See this. Get rev list. Okay. Get rev list -- tags. See. Now this is giving the commit IDs for all the tags. We don't want this. Git rev list -- tags. Then -- max -- count equal to 1. I'll press enter. Now what this command has given us, git rev list -- tag -- max count -1. It has given us the latest tag number commit ID, the commit ID of the latest tag number. Okay. Now see this. What I will do. I will do another command. Okay. Describe -- tags. Okay. So what I will do, I'll paste this. Okay, basically whatever is the commit ID, I am giving input to this command. So what did I got? 1.6. It is equivalent to this, which we have done just now. That's just a Linux shortcut. Not this one. If I just copy this and paste it here, it is going to give 1.6. So we have combined both the commands, git rev list -- tags -- max count, and we have given this inside this command itself. So what it is going to do, what is the use of this command? It is going to get us the latest tag number. So whenever a new version is getting released, 1.7, 1.8, 1.9, as soon as it is getting pushed to main, what will happen? Automatically the Jenkins job is going to get triggered, because we have something called as GitHub webhook, which we will see how to configure. then Jenkins job is going to run by itself. It is going to clone the repository. Then it is going to do the Maven build. After doing the Maven build, what it's going to do, it is going to take the artifact. Okay, we are going to use it inside a Docker file, and then using the Docker file, we are going to build Docker image. Then we are going to push the Docker image to Docker Hub. Then from Docker Hub, we will pull it inside the Kubernetes cluster, and we are going to deploy inside Kubernetes cluster. All this will happen automatically. But for the first time, obviously, we have to define the flow. We have to do the configuration. From the next time, we do not have to touch it. The same thing I'm going to do. Same command, we will use it. See this. What I'm going to do now, this whole thing, this whole command, I'm going to put it inside one variable. Variable may be tag equal to $. Whole command I have put it inside one variable, tag, press enter. Now if whatever is the value of this particular command, it got stored under this variable. Now you do this 1.6. Okay. Yes, we will see the artifact from Jenkins. We have already seen last time. I will show it to you this time. Okay, I will show the flowchart. Now that's fine. So let's continue with the Jenkins. So this is the command that we are going to use. Echo tag. We will copy and paste this. So I'm going to copy the command and paste it inside the Jenkins job, so that whenever our from the repository, any new changes, any new pushes are happening, what is going to happen? It is going to happen that this particular job will get triggered and new tag is fetched. So that whenever inside the Docker image, it is going to get created with every new release, it will use this particular tag number and it is going to create it with respect to that. For example, now this is our source code. Okay. Inside the source code, currently we have 6 tags. So what is going to happen whenever a new tag is created and eventually pushed to main? What will happen? This job will get executed, and the Jenkins, what will Jenkins do? It is going to fetch the latest job, latest tag from this particular source code, and the same tag will be used when we are going to create Docker image. And using the same tag, we are going to push it into the Docker Hub. See what will happen. If I scroll down, okay, so in this variable, we are going to get the tag number. So we are going to use this further. All right, maybe I'll just print it also for you so that we can check it inside the Jenkins output. Also, I'm going to save this particular, the version inside one file. Maybe I'll call it as tag file.txt. We are going to save this. Why we are saving this inside a file, we will see in some time. Now, tag version got saved. I want to do Docker build. Okay, I'm going to enter the command. Okay, I'm going to enter the command what? Docker build. So what is the command for creating the microservice? Docker image, basically. What is the command? Docker build -t, the name of the account, followed by the name of the application, followed by the tag number. So what is going to happen? I have given $tag. Suppose the job is running one time. Okay, latest tag is 1.6. So if this job gets executed here, it's going to be Docker build :1.6. Next time on the GitHub in the source code, what will happen? Tag 1.7 will get pushed. It will get merged to main. Then what is going to happen? in that case. Second time, the job is going to get executed. Second time, what is going to happen? Instead of 1.6, 1.7 will be mentioned. All right, 1.7. And again, what will happen? The image, Docker image 1.7 will get created. Okay. After image gets created, what are we going to do in Docker for collaboration? What we will do? Yes, no, I'm talking with respect to Docker. What we will do after Docker image is getting created? Yes, we are going to push the image to Docker Hub. So in order to push the image to Docker Hub, what is the command? Docker push. That's the right. So that is the command that we are going to use in order to push the image to Docker Hub. Okay, that is the command that we are going to use. So we will come here and we will say Docker first before doing a push. I will do Docker push this. Okay, followed by whatever is the R tag number. This will push it. But there is one step we are missing. Before doing a push. What is that step? Docker run is for running the container. No, not commit. We need to authenticate. We need to do Docker login. Or else how we are going to push. So Docker login -u. Okay, because it is a command line. In the terminal, we entered Docker login, press enter. Then I was typing username and password. Obviously, we will not give interactive shell. Okay, so Docker login -u means username. And what are we going to enter here? See this particular variable. Dollar means it is going to fetch the variable. So this is nothing but my account name. Okay, -p dollar. Copy this, paste it. Okay, so it's going to log in. Docker image will get pushed, then Docker logout. So inside this job, what is happening till now? Okay, we are running this job on the slave server. That's the first thing. Apart from that, what is happening? Yes, apart from what is happening? After cloning the repository, we are enabling the GitHub webhook trigger. So as soon as something is pushed over the GitHub repository, this job will automatically get executed. Okay. In this job, after the cloning is done, obviously Maven will run. It will generate the artifact, and that artifact we are going to use inside Docker, but also we are using the tag from the source code. Whatever is the latest tag, that tag is nothing but the tag of your Docker image. Okay, whatever is the tag, that is the latest tag is the version number of your image, and that is what we are pushing it after authentication. And yes, and we are adding the Docker credentials here. Okay, so we have done with all of these things. We will run this. I'm just going to remove the downstream job. I will show you how to integrate Kubernetes also, but let us do this first, and then we are going to come back to doing something else later on. Okay, so what we will do, in order for this to run, what should happen? Yes, in order for this to run, yes, I will show Docker file on how artifact we are using inside Docker file. So what is Maven, everyone? It's a build tool. Okay. So we will execute this first. Okay. Then we are going to come back. We will save this. We will execute it and we'll come back. But I will configure GitHub webhook trigger also. So how to configure GitHub webhook trigger? I'll save this. We'll go back to here. Yeah, I will copy it. The URL Jenkins. Now inside the repository, let me log in. Okay, I'll authenticate it. Maven code means source code. No, Maven does not mean source code. It is a build tool. Okay. So inside this source code, click on settings. In this settings, scroll down. On the left hand side, you will see webhooks. In this webhooks, already I had an existing one here. Okay, I'll delete it so that I can create new and show it to you. So where you have to click, you go to your Jenkins Maven code. Over there, click on settings of the repository. On the left hand side, you have webhooks. Click on webhooks. Click on add webhook. Okay, here paste the URL of your Jenkins, followed by this GitHub-webhook. This we have to mention. Scroll down, just click on add webhook. After we add it, automatically it will send like a ping, okay, and test it. So webhook is live. So if I make any change inside the repository, basically inside the Maven branch, okay, what is it going to happen? The webhook is going to get triggered. So Ketan, after you create a webhook, it is going to send a request to check if it is live or not. So the sending of the request, it is calling as the payload. Okay. So what I will do, we have configured this job already, right? We have configured this job already. And I want this job to get executed. There is one dependency though. Okay. On your Jenkins slave, we want Dockers to be installed. Okay, only then those Docker commands will work. Anyways, I will make the change here inside the Maven code, the source code here. I will make the change, and this particular job will automatically get executed. So we will see that this job will automatically get executed. So I'm just going to make a change inside the GitHub. I'm going to make a change inside the GitHub. So maybe I will go inside here. I'll just add something inside README. Here I'm just going to make a small modification. I'll just make a small modification. Maybe I'll just say webhook demo. Okay, or basically the Jenkins demo. Okay, I'll just put a comment also inside this. Okay, build number 7. Okay, remember, so automatically build number 8 should start. I'll click on commit changes. It's okay. It's like someone is pushing change to the main branch. Okay, automatically what should happen within couple of seconds, build number, you see on the left hand side what has happened just now, bottom left hand side, build number 8 has started. So basically what should happen when this job is running till now? Software developer pushes code to main branch. Okay, it can be other branches also, but we have configured for main branch. Then we have configured. So what should happen? This is webhook in the middle, remote repository on GitHub. That is why we have mentioned GitHub here. So this complete thing, the whole job is inside Jenkins. I don't have to mention that. Inside Jenkins only we are doing all the configuration. It's just that we are integrating different things. So software developer pushes the code to main branch. What will happen? Jenkins job is going to get executed. Now everything is inside Jenkins job itself. The configuration will be on the master. Execution will be on the slave. Jenkins job is going to get executed. Inside the Jenkins job, what we have done, inside the Jenkins job, I have configured. Inside the Jenkins job, I have configured in a way it will do git clone first. After that, it is going to use Maven for building. Okay, it will take the source code, convert it into a executable format, build tool. After that, inside the job, what we are going to do, we are going to build Docker image. In order to build the Docker image, what is required? In order to build the Docker image, what is required? First of all, first we are fetching the tag version from the GitHub, right? After cloning those commands, git rev list, which we have seen. After fetching the tag version, we are logging into Docker. Building Docker image. After building Docker image, what we are going to do? We are going to push Docker image to Docker Hub. Now, while building the image, we will use the tag which we have fetched here, the same version. Yes, everywhere we are inside Jenkins itself. Everything is happening inside Jenkins. After this, okay, there are next steps. From Maven, the tag is not generated. This is next steps. We are getting the tag from the git clone, from the repository only. But it's that we are fetching the tag after Maven. But we are fetching the tag from the repository itself. Okay, after this, again, Kubernetes steps will come. We will see that. In the meanwhile, let us go back. Okay, we can see here on the left-hand side, as soon as that GitHub webhook trigger was triggered, automatically this job number 8 on the left-hand side, it got executed. So what it has done? It has done git clone. It has done the Maven build. It has generated the artifact inside the Docker file. Using the Docker file, we have built the image, and obviously we have fetched the version. Okay, we have done all those things. Now, how to integrate Kubernetes? While showing Kubernetes dashboard, I mentioned that there are two methods. One is the token method. The second is kubeconfig. Okay, in the beginning of the class, in order to log in into Kubernetes dashboard, I said there are two methods. One is using the token. The second is using kubeconfig. I said kubeconfig, we are going to see. So what is kubeconfig? So here, inside the Kubernetes, one hidden folder will get created, .kube. Inside this .kube folder, you will have this config file. If I see this config file, obviously, I'm seeing all this. Okay, this is nothing but your Kubernetes certificate. Okay, so inside Jenkins, we have to copy and paste this certificate in the credentials so that we are able to communicate with the Kubernetes. I will copy it, okay, and I will paste it inside Kubernetes. But what I can do is I can segregate. I mean, in the upstream job, I have already mentioned till Docker level. If I want, I can use the same job and mention Kubernetes also, or else if I want, I can put it in the next job as well. It's up to our wish, how we want to do it. Certificate will not get expired. I mean, usually it depends on what method you are doing. If you are doing kube ADM, there is one command, it will renew it by itself. Within 1 year, you have to do it. One command is sufficient, but again, it is not done by freshers. Okay. So I'm going to show this now. One moment. I'll paste this particular thing inside my config. I don't have any config, right? Cat config. I'll paste this. I did not get pasted. One moment. Okay. So the config got pasted. That's fine. The config file got pasted. So I'm going to upload this, or I can also upload the whole file. Okay. So basically what I'm going to do, inside another job, okay, as soon as this job is getting executed, everything is Jenkins. After that job, it is going to trigger another job. What will that job have? That job, the second job, what it will do? It is going to trigger. Okay. Basically, in the other job, we will have Kubernetes integration. In the sense, we are going to use kubeconfig file. We are going to use kubeconfig file inside the other job. We are going to configure now. Inside the credentials, we are going to save it. Inside the credentials, we are going to save it. Okay. Then we are going to use a command. In the another job, we will have this kubeconfig file, which belongs to Kubernetes. We will save it first. The second thing is we are going to do git clone. Now git clone for what? Git clone for Kubernetes manifests. So in real time, we will have Kubernetes manifest on your GitHub. I will show this. So inside this particular repository, what I have done, I have, see this, there is something called as Kubernetes deployment branch. So we have created one Kubernetes deployment branch. Inside that branch, we have the manifest, like we have the deployment YAML. Okay. Then we will have the Kubernetes manifest. Then we will have something called as, if you want node port, if you want cluster IP, whatever you want to deploy inside the Kubernetes, you will have a branch inside that you are going to have manifest, because we want to apply the manifest. Okay, and manifest will be inside the GitHub itself. So what we are going to do, we are doing the git clone manifest. And what are we going to do apart from that? The next thing that we are going to do in this is we are going to fetch the tag version from job one, upper job, okay, upstream job. It's like Docker image, one version 1.6. We have sent it to Docker Hub. But inside Kubernetes manifest, how should we know what is the latest version? Latest version is nothing but whatever we have pushed to Docker Hub, that should get installed. So whatever was the tag version in the previous job, we are going to fetch it so that we will be able to give inside the Kubernetes manifest. For example, suppose I open deployment. Currently it says version 1.2. Okay. Later on version 1.3 will come, eventually 1.4, 1.5. What will happen? Every time they are doing a push, a new version is getting generated. So even this version should also get updated and get deployed inside the Kubernetes cluster. So in order for this to get updated and deployed inside the Kubernetes cluster, we are going to fetch the version from the, okay, no, I don't want to update manually, right? That is what I want, automatic. So fetch the tag version from upstream job, and inside the Jenkins job, I'm going to configure it so that before applying the Kubernetes manifest, it will update the version in the manifest. Okay. Then what it will do? It is going to apply. Then what it will do? It will apply the manifest inside Kubernetes cluster. Okay. This many steps we are automating. So let us go back and check. Okay, where is our? I can go back to this one downstream. In the meanwhile, this is the output of upstream. Everything it will do by itself. It is building it. Okay. And also after that, after doing that, what it is doing? Docker. Okay. It is building the image. It is logging in. It is pushing it. So pushing. Okay. So all these things it is doing. Then after that, eventually it is doing Docker logout. So these many steps this is going to do. Also, there is one plugin we have to install. If job 2 wants to fetch the version number from job 1, there is something called as copy artifact plugin. Using that plugin, what we are going to do? We are going to fetch the tag version from the upstream job. Okay, that we will say. Also, we have to make sure that Docker is installed on the Jenkins slate, because we are typing Docker commands. If you want, you can do it. But usually, if you want to save it in environmental variable, you have to use other method, right? I'm storing inside the command, but is it possible? It is possible. You can try that. So inside the downstream job, okay, we are going to configure it. Downstream job will also work on layer 1. It is going to do the clone. Here, the branch is Kubernetes deployment. All right. Now what is going to happen? I can say whenever the upstream job is running, after it gets executed on this job. Then here, what I can do, okay, in the secret file, I can say secret file. I'm giving some variable. The name of the variable can be something, okay, I will say config file maybe. So Amit Mishra, we can learn this command for more practice. What do we mean by, I have not shown. If in order for practice, you need to install EC2 instance and practice. That a learner has to do the practice, right? How can I do a practice for you? So guys, what are we doing? We did not understand the concept. What are we trying to do using Jenkins? Till now inside Jenkins, what is it that we are trying to do inside the job? What is the purpose of Jenkins? CI/CD. That is what we are trying to achieve. So basically, what is CI/CD? In the first class also we discussed about CI/CD. Even in the Jenkins module, we discussed about CI/CD. The moment software developer is sending the push, okay, to the GitHub, what will happen? All the tools are integrated. Automatically, everything will get from the build phase to the deployment phase. What all is required, everything will happen. Automation is going to happen using the Jenkins. That is what we are trying to achieve. And we have already seen Jenkins in the beginning, how to do clone, how are different options, how to install plugin, what is Jenkins master slave. And the only thing left is how to integrate Docker and Kubernetes. That is what we are saying. So that is what I'm mentioning. If we don't practice, we will forget everything. Maven is a build tool used to convert the source code into executable format. That executable format we are calling as artifact. Okay. Now, where is my workspace? AWS config. I can say kubeconfig. Kubernetes kubeconfig file. This is a typical Docker file. Okay, we have used Java. Okay, this is a sample application. Inside this, you have a source code. Inside the source code, we have sample Java application. This Java application is a web-based application. Okay, in order to run that application after the Docker is built, we need Tomcat web server. Okay, so we are calling Tomcat web server here. Inside Tomcat web server, these are the commands which are needed in order to, before running that application. All right. Then we are adding the required files. Okay. And this is your artifact. Artifact is generated in the target folder. We have seen this in Jenkins. This particular artifact we are placing inside the Tomcat specific location. What is exposed? It is for documentation purpose. Okay, this is not now something new. Basically, we are telling that the application runs on port 8080. Many people will have doubts over the internet. They will think that expose means we are opening port number. That's not like it. It's just for documentation. Expose 8080. It is just nothing but we are informing that this particular application works on port 8080. Expose does not mean that application is going to, you're opening port. It's not like that. It's just for information. Thank you, everyone. Bye-bye.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASCOM certified DevOps professional, do check out the course link mentioned in the description below.
So today's agenda is to start Docker module. We will try to understand what is virtualization, what is containerization. Then we'll try to understand Docker. What is the life cycle of Docker? What is Docker image? What is Docker? Then we are going to see how to install Docker. Then we'll see Docker commands and so on and so forth. We'll proceed. That's the agenda for today. In microservices, what used to happen is whatever individual components you have, like whatever components you have inside your software, the inside microservices architecture, what we are doing, each and every component, we are not doing tightly couple. Okay, we will not tightly couple. We are not going to put it in a single program. All components are, okay, all the components. If we see the diagram now, earlier it was like in one box. Okay, it's tightly coupled. It's converted into one single program. After the integration, it is deployed. In microservices, what will happen? You will have the components of your software. Okay, you will have. Now, microservices basically came into the market in the sense it got famous. It got famous and the whole world started to develop using the microservices architecture. Okay. So if you say that, yes, can it run without containerization? So basically, yes, you can run it. It's not a strict requirement. But what is going to happen? Yes. So this happened in 90s in Linux. In Linux, if you talk about containerization, right, in Linux, it is in 1990s. There is something called as LXCs and LXDs, but it is not famous. The world did not use it. Okay. Microservices is nothing but usually all the processes are running separately in the sense. All right. But after containerization, what is going to happen? The problem is going to get resolved, because if we are not using containerization, then there is always a resource overhead with respect to VMs. Okay. And there is always a environment consistency issue. Environmental issues will be there if you are not going to use microservices with containerization. Also, how are you going to deal with scaling? The scaling is going to become very complex for microservices if we don't use containerization. Okay, so isolation is there, resource overhead is there, environmental issues are there, scalability problems are there. So both goes hand in hand. That is why it has now spiked across the market. So that's the answer, Anirudh, to your question, and Ketan. All right. So in microservices, what we are doing, we have different components of your software. So what are they going to do? They are not going to integrate tightly and they are not going to deploy it as a one single unit. Instead, you have your individual components, okay, of your software that are going to run it. Like this is going to run it inside one container. This will run inside another container. This component will run inside another container. This is going to run inside that container. So what will happen if suppose there is a bug in the customer service component? So all other services, all other containers are going to run without a problem. Okay, maybe only this container is faulty. So what is going to happen? Obviously, we can redeploy just the customer service. Okay, we can just deploy the customer service logic and it is going to work. And even if there is a bug which is basically causing a lot of problems, then only this module will not work, but all remaining other modules will work. Even if there is a minor one-line code of change inside the notifications module, then what will happen? That notifications module will only get redeployed. Not all other microservices, not all other different components are going to get redeployed. So here basically we are not integrating all the components of the software into one single unit. Basically we are all having all this microservices, all these services individually, okay, and they are going to communicate whenever that is required. And it is solving the microservices with containerization. It is solving the problem with respect to the environment issues, with respect to isolation, with respect to scalability, and even there is a lot of resource overhead on the VMs that is also going to get resolved. Okay, as well as containers are very portable. The size is very less. Suppose I develop a container image. What is a container image? We will see. Suppose I develop a container image. What is going to happen? I can port it. I am in India. I create the container image. Okay, it for each component. Maybe this component it will take 300 MB, 300 megabytes. So anybody in the US, anybody in the Australia, anybody in the Japan can take that 300 MB and redeploy it onto their servers. So it is very portable. Whereas if you just put it inside the VM, you're not using containerization. VM space is usually 16 gigs of RAM, 100 storage, 100 gigs of storage. Okay, 8 CPUs. Now, if you want to port the VM, then it is going to be a challenge. All right. So Ketan says, can we say individually means there are separate code structure? Yes, see, this mail will have its own code, source code, payments will have its own source code, passenger management will have its own source code. That's right. Should we have to maintain each component to each server? So Prithvi, after with containerization, we don't have to do it. On a same server, you can deploy it. I mean, it basically depends on how large your server is. Okay. Also, yes, also see, I'm going to tell you, see, with containerization, obviously, usually APIs we are going to use. It depends on the architecture, but is it possible technically? I'm telling you. Maybe you can write customer service in Python. Okay, you deploy it inside the Linux. Location service. Why it is famous? See, location service, you can write under Golang. It is possible. Across the project, okay, convention is you are using specific programming language, and basically depending on the project you are implementing it, that's fine. But I'm talking about, is it technically possible? So customer service you can write in Python, location service you can write in Golang, then passenger management if you want you can write in Python, or you can write in Java. That is fine, it will still work, because internally they basically why it is happening, because isolation is there inside the containers. So you can use different languages for different components also. Still you can make it to work. Microservices with containerization. Okay, so the technology dependency is very less with respect to this. So that is the use of microservices with respect to containerization. So Ruchita, yes, that's right. I would not say latest, I would say the world is using microservices now. I hope everyone got it. So Meher has a question. Let us suppose if Linux new version has to be updated in all different microservices, we have to do it, or how does it work when it comes to monolithic? Only once is enough. So Meher, first of all, why would we want to update the Linux new version in all the microservices? What is the reason? Anyways, when we are creating an image, we will just change the version number. It will just take it inside the Docker file. Yeah, so we can do it with the microservices also. There is something called as a Docker file that we are going to study. Inside the Docker file, you just change the version number. That will take care of it, because it is going to be helpful inside the CI/CD. Okay. Can we use Ansible for this use case? If you want to install Docker using Ansible, you can do it. I mean, but launching the containers, it's like after the installation, the Docker commands we are going to learn that we have to run it. Okay. All right. So now Docker is the tool using which we are implementing containerization. Now inside Docker, we have certain components. We have something called as Docker engine. We have something called as Docker image. Okay. Then we have something called as containers, where we create the container, stop the container, delete the container. There is something called as Docker Hub. All right. Now we will discuss what are the components. What is Docker Engine, for example? In simple terms, Docker Engine is basically the main component. Okay, it's the actual software, it's the core component, which is allowing us to create the containers, manage it. All right, the main containerization, it is helping us to do it. It is helping us to do it. Now, what is Docker image? What is Docker container? We will discuss what is Docker image and Docker container. It's not hardware, it is actual software that we are installing. Okay. Okay. Before I explain Docker image, I'll take one example. Suppose I want to install Windows operating system on my laptop, or you want to install Windows operating system on your laptop. Okay. How can you install? Okay, DVD. Okay. All right. These days, obviously, inside the laptop, okay, for easier understanding, I'm just showing this example. These days, obviously, inside the laptop, we don't have something called as CD-ROM, okay, CD drive. We don't have it. Earlier, we used to have something called as CDs, okay, DVDs. Inside that, we used to have Windows OS or any other software setups, maybe 8 years back, 9 years back. Yes, everyone? Now, inside this CDs, you basically have the setup of the software installation, right? Then we used to insert this CD inside the laptop, and then we install whatever software we want, or basically, with respect to here, we used to install Windows OS. Windows OS. After we install Windows OS, then obviously on the laptop, we have a running Windows OS. Okay. Till this, everyone, is it clear what is happening here? All right, I just got few responses. Anyone who is not able to understand till here? Okay. Now what we are going to do, for example, one quick question I have. Inside the CD, what do we have? Image. That's right. Inside the CD, we have the setup. We have the image of the software. Can I say that inside the CD, Windows operating system is running, or can I say that Windows operating system is running on the laptop? Okay. So I can say on Windows CD, basically you have the image, you have the setup. Today we just have bootable image. Okay, I just gave an example for easier understanding. But on the CD also we had image. I mentioned, right, 8-9 years back. And I can say that this is the running instance of the software. Okay. On the CD, whether it is a CD, whether it's a pen drive or whatever it is. Okay. Basically, you have the image. Okay. Image of the software, the setup of the software. And using the image, we have the running instance of the software. If it is a Windows OS, then it is a Windows operating system which is going to run. If it is some other software, it is going to get installed and it is going to run. Can I say with one CD, I can install Windows OS on multiple laptops? I'm not going to ask about key, okay? Keys, obviously, it is going to be unique. But I'm telling using one CD can be installed multiple Windows operating systems on different laptops. Yes, I'm not bothered about the license. Suppose we have the license, okay? All right. Okay, physically, if we think we can do it at a time one, okay, that's fine. But still, if I insert it inside multiple laptops, we can do it, whether it's a CD or whether that's a pen drive, so on and so forth. Okay. So basically, you can have multiple instances. Okay. Using one image, you can have multiple instances of the software, whatever the software you want to install. Now I'm just trying to correlate, okay? In Docker terminology, okay, I'm correlating it. The image is called as Docker image. The image is called as Docker image. Whereas the running instance of your software is called as container. The running instance of the software is called as container. So what is the difference between Docker image and a container? Docker image will have the setup of your software. Apart from source code, whatever is required, all the libraries, dependencies, everything, the setup is going to be inside your image. You can call it as template, okay? It's like a template, set of instructions, whatever you want to call. But it is having the setup of your software. Now inside the container, using the Docker image, we are going to create a container. Now inside the container, you have the running instance of your software. Now this will include everything. Apart from source code, what all is needed to run the software, everything is running inside the container. Basically, this is a running instance and this is just the setup. This is just the template. This is just the image. Okay. So what is the difference between Docker image and container? Image is just a template, set of instructions, your setup file. You can consider like that. Okay. What is a container? It is the running instance of your software. Using the image inside the container, you're running the software, whatever you have written inside the image. See, we cannot use Ansible example, Ketan. The reason is, in Ansible playbook, we are just declaring it and you are just writing set of instructions. That's fine. Okay, that's fine that it is going to execute. But inside Docker image, apart from that playbook, apart from source code, you are including the dependencies. Okay. You are including dependencies, you're including libraries. We are not doing all that. Usually Ansible internally is taking care if you're using modules. So we cannot correlate. And Ansible is for configuration management. Whereas Docker is for any custom software you want to containerize. I have drawn one running instance. If you want, depending on the hardware capacity, you can run 100 instances of the software. You can run 200 instances, 5 instances. Okay. All right. Everything under one container? No. Everything is not under one container. As we have discussed when we were discussing, where is that example? Not here. Microservice. So basically, each and every different component. So mail component will be inside one container. Notifications will be inside one container. Payments will be inside one container. So on and so forth. It's like that. Okay. It's like that. All right. Now, what else? That's right. Do you have auto scale Docker base? So Manasvi, if the first thing is you should have hardware capacity. If you don't have hardware capacity, you're trying to create more replicas, you're trying to auto scale, it will not work. So hardware capacity has to be there, then you increase the replicas. Basically, Docker image is portable, lightweight. It includes basically everything that is needed to run the software code, the runtime, the libraries, the environmental variables, configuration files. Okay, PXE boot is for network booting protocol. That is a different thing. So GitHub will just have the version code. the source code, and inside the GitHub, you basically just have, where is my, okay. Inside the Docker image, what do you have? Apart from source code, basically we are doing containerization. Containerization is we are putting everything, we are packaging inside one particular thing. So in Docker image, what are we doing? We are basically, apart from source code, what are we including? We are including runtime, we are including libraries, we are including environmental variables, we are including configuration files. Everything we are including in order to make the software work, and that particular image is going to run inside a container. All these things will not happen in GitHub. GitHub is just a platform where we are hosting the remote repository. Other than that, it is not going to do containerization and all these things. Okay. Manasvi, so in case you want to change a part of microservice, would you not require downtime? So Manasvi, we don't require, because in real time we will have something called as Kubernetes cluster. In that we will have strategies for deploying it. It will be instant. There will be something called as blue and green deployment. There is something called as other strategies that will come into the picture. Okay. So now we are going to install Docker. After the installation, we'll come back and we'll see more things. Difference between Git and Docker. Git is a tool used for writing the source code. Okay, when you're writing the source code, basically you're doing the tracking. Who has written the source code? Who has written this Python file? Who has written this Java file? When was it written? Who saved it? When it was saved? Can we go back to the previous version of the file? Okay, it's for version control system. It's not about contains the source code. What is the purpose? The purpose is for versioning, tracking the code. It's just tracking the code. Now Docker will use the source code, and after using the source code, if we remember the DevOps lifecycle, that is just phase one. You have the source code. Now you will take the source code, convert it into a package, executable format, and then you are going to put it into a containerized format, and then you are going to eventually deploy it into the Kubernetes cluster. So there are phases when we are developing and deploying the software code onto the production servers, basically inside the Kubernetes cluster. Now GitHub and Git is just phase one. Okay, we have other things. Docker is not just for deployment. Basically, eventually the deployment is going to be for inside the Kubernetes cluster. Docker is for containerization. In GitHub, you are not doing containerization. Yes, we can automate. We can automate. Okay, let me just log in. Give me a minute. Logging in into my AWS thing. Okay, I'm logging in. Okay, logged in. All right. So we know what is a container engine and what is the purpose for it. See, container engine is one of the core components of Docker tool. It is used to containerize the application. Basically, whatever application you have, we have been discussing that we are going to take the source code, we are going to take the libraries, dependencies, modules, we will install everything, and then we are going to package it. Now container engine is going to do all those things. It is going to run our applications inside the containers, start the container, stop the container, manage the container. It's going to do all of those things. So there are other tools also in the market, something called as RKT, Podman, and other things apart from Docker. Okay, but obviously Podman is still catching up. It is still catching up, but there are other tools called as RKT and stuff, but industry-wide Docker is going to get used. I'm just going to create an instance. I will install it. Then I will show you the DevOps lifecycle. So Manasvi, for Kubernetes, we'll again use the Docker image itself. Okay, there is a component called as Docker D. It's going basically a component that will be used. Okay, Docker can be installed on a very micro T2 micro also. It can be installed on a large hardware also. For demo, T2 micro is enough. Industry level, we will use both. Both have for different purposes. One is for containerization, that is creating your Docker image. Another is for deployment. Interesting one. Okay. To install Docker, there are different methods. Anyways, I have pasted all the commands of the installation. You can just copy paste it from here. Okay, regarding the installation, or else even you can just grab the same commands from the. You can grab the same commands from the website. Okay, we are going to install it just in case. Let us continue with the installation. All right, I'm just going to grab the commands from the shared drive and paste it here. All right. So the software is installed. I'm just going to run something and confirm. So I'm just going to run sudo docker run hello world. It's doing something. Unable to find image locally. Okay, remember this. We will discuss in some time now. So what does it say? Hello Docker. Installation is working correctly, which is nothing but the installation is successful. And first time we got something called as unable to find image locally. Okay, if I run this again, I'm not going to see that error. Why, we will discuss in some time. Apart from this, whenever I enter Docker commands, I don't want to type sudo. Each and every time whenever I run the Docker commands, I don't want to type sudo. So if I don't want to type sudo, I am going to use one command. Okay, and then I'm going to stop using sudo. I'm basically adding this user Ubuntu to Docker group, adding the Docker group to the user. Now when I run the command, it will work. Okay, so I don't have to type sudo. It will get installed in the installation instructions that we have. It will get installed and create the group. See, we entered this command, docker run hello world. What is this command doing? Okay, this is a docker command. Hello run hello world. So this is the command which is responsible for creating your containers, running your containers. The moment you type docker run and the image name, it is going to start your container. Now this hello world is the name of your Docker image. Hello world is the name of your Docker image. If your Docker image is not available on your local server, first it is going to check for Docker image on your local server. If you do not have it, then it is going to download from somewhere else and then create your container. See, I'm going to show you something interesting now. So across the world, there is a website called as Docker Hub. Okay, it will just host your images. So across the world, you name any software. Okay, apart from Windows, they are not giving open source. Apart from Windows, okay, Microsoft. So you name any software, for example, MySQL database. Just type MySQL. What will happen? The image of MySQL is going to come up. How many times it has been downloaded altogether? More than 1 billion times it got downloaded. Just last week, around 6.3 million times it was downloaded by the people. If we see Maria database, MariaDB, it was downloaded 1 billion times. And how many times it was downloaded in just last week? 2.5 million times. Type anything. Maybe I'll just type PHP. Say, the image of PHP was downloaded more than 1 billion times. And just last week, it was downloaded for how many million times? 1.7 million times. Okay. Pratibha, I will answer your question. So on and so forth, just type anything. Okay. Most of the languages, whether it's a programming language, whether it's a software, most of the things are already here. See, Golang. If you are developing something in Golang, you want to run the Golang file, just download this. It's already downloaded more than 1 billion times. It's already ready for you. Maybe you want something called as a web server, Nginx. Web server. Click on this. How many times it was downloaded? More than 1 billion times it was downloaded. It's a web server. So it's already ready for you. It's not like from scratch you have to create it. See, last week it was downloaded 68 million times. Golang is basically a programming language developed by Google. So most of the things are already ready here. So what you can do as per your use case, you can download this image, and on the top of this image, you can make modifications as per your requirements and use it. So basically you do not have to create from scratch. And if If there is a requirement, if you really want it, you can create from scratch. That's not the problem. You can create your own custom images. That is fine. But I'm just showing you here. So Prithvi, extensions in the sense it is just the name of the image. You don't have to give any extension. That you just give the name of the image, it will download. So Pratibha, if you want to add any MySQL inside your containers, say if you do not have to start from scratch, just download the MySQL image from here. For example, inside this image, do whatever configurations you want to do. And then you can create your own custom image if you want to. Yes, that is right. It is there. Commands are already here on the shared drive. Okay, basically here you will get everything I have uploaded it. You will get commands for installation, and also you are going to see all other commands that we will learn. So you can check it up. So we are going to go back to the terminal. See here, Docker images. Docker images is the command which is going to let us know the list of all images that is present inside the server. Docker images is the command which will help us to know the list of all the available images that are onto your local system. Okay, I'm just going to use this command. What is the use of this command? I will tell later. Okay, I'm just deleting this image where something is running. No, it's okay. See, I'm going to show you the default behavior. Suppose you run this command. What is it basically happening? If you run this command, what is it happening here? Is what I want to discuss. So the moment I press enter, what is happening? The moment I press enter, it is basically telling that unable to find the image locally. So the default behavior is this. First, it is going to look inside your server, inside your local machine, whether the image is available. In case if it is not available, then it is going to download from Docker Hub. That is what it's going to do. It is going to download from Docker Hub. Okay, then it is going to create the container and run it. And it is for any of the things, it's the same thing. Suppose I run something called as Docker run Nginx. I'm running a web server. Okay, I'll press enter. What message I got? Unable to find the image locally. So what it did, it downloaded the Nginx image and it started the container. So currently this output is from the container. Basically the Nginx web server is running. Okay, Nginx web server is running here. Now interestingly, I lost the terminal here. Basically the command prompt, the shell. I don't have this. Okay, because the container is running. Now if I come back, if I just do a control C, it will exit. It will exit. I don't want this. I want the containers to keep on running also in the background, and also I want this shell. Okay. Say this. What I want is when I'm running this Docker run Nginx, for example. Now, when I enter the command, obviously it is starting the container, it is using it, for example, but I'm losing the shell access, the terminal access. I don't want that. So in order to make sure that the container is running in the background, what I'm going to use something called as Docker run -d. Okay, -d means detached mode. Basically, run the container in the background. Now, if I press enter, I'm just getting this. This is nothing but the container ID. I got my shell prompt. Now, if I enter this command docker ps, it will show me the list of containers which is currently running. So this container is currently running here. Okay, it is showing the container ID. If we compare this, this is the container ID. Okay, this is the short form. Nginx is the name of the image. Entry point. What is entry point? We will see later. Created 12 seconds back. Currently it is up, running from 11 seconds. Okay, and if we don't give a name, it will randomly allocate a name. So what have we seen till now? We have seen docker run, image name. We have seen something called as docker ps. We have seen something called as docker run, -d, and the image name. Okay. Yes, that is a name. Randomly, this will take a name. If we don't give it, how to give a name, I will show it to you. So Pratibha has a question. Suppose we run Nginx on Docker. Okay, where exactly we use Nginx and how we use it. See, we are not running Nginx on Docker. Okay, using Docker, we are running Nginx. It's not like on the top of Docker we are running it. No, I would not put it in that way. Using Docker tool, I am running the Nginx container. If you don't want Nginx, don't use it. Use whatever is required. Suppose you are working on a database application. Create a MySQL database container. Whatever you are working on, just create that container. Okay, inside the project. Suppose you are working on a front-end application, web server, then use Nginx. If you are working on database, use MySQL, use MariaDB container. Okay, based on the application, based on the use case, you have to use it. Suppose I used MySQL using Docker. How do I use it? Launch it. Run the container. Inside the container, the application MySQL database is going to run. Okay. The MySQL database will run. Now, first of all, why are we using MySQL database? Okay, we have to provide environmental variables. We'll provide that. But why are we using MySQL database, Pratibha? What is the use of it inside your application? So to store data, what kind of data? Is it a relational database or is it a NoSQL database? What kind of a database it is? Employee information is fine, but what kind of a database it is? Relational database. So inside the software architecture, how are you going to store the database? Are you going to store it in a standalone fashion or are you going to store it using a web server? So based on the architecture, we have to implement. If you are going to use standalone, then just run the container, go inside the container. You run any container, for example, this is just an example. Now this will come in a serial fashion. We have to see all the commands one by one. Okay. For just now, I'm showing this, but I will go in a linear fashion. Once you run a container, you can go inside it also. Now this is you are inside the container. Okay. That is how it's going to be. Now inside the container, whatever you want to do it with respect to your use case, you can do it. So Anirudh, that will depend on what is your software architecture. You have to give the software architecture. There are two things. One is infrastructure architecture, one is software architecture. How is your software architecture designed? If you're just going to create a single DB, okay, no, that is fine. You move from monolithic to micro. That is fine. So inside the Kubernetes cluster, there is a concept. Docker, we are just going to use to create the Docker image. Industry-wise, we are going to use Kubernetes cluster. So inside the Kubernetes cluster, we will have something called as PV and PVCs. You are going to deploy the MySQL database inside the Kubernetes cluster. You will have something called as persistent volumes. Inside the persistent volumes, we are going to store the data. So you can go inside and you can log in and store the data. Okay, and also you will give API information. That is how it will happen, but that will come one by one. As we have scenarios or examples, things together like Docker with project. So currently we are trying to understand first the fundamental concepts, how to use it, where to use it, what are the different commands, okay, inside this concepts, where what it will do. We are understanding all those things. But before understanding the fundamental concepts and all these things, we can't go over there. All right. Okay, where were we? So let us continue in a fashion of where was I? I was here. Docker run -d nginx. Okay, till now what we have seen is we have seen something called as Docker run nginx. We have seen Docker run -d. Okay, this is just an image name, whatever is your image, and it is going to run in the background. Basically, it is going to run in the background. So currently we can see 3 containers are running. We have 3 containers running. Now suppose I want to just download the image. I want to download the image, but I don't want to launch the container. I don't want to create the container as of now. I want to just download the image, but I don't want to create the container. How is it possible? You can do this. Docker pull. This is a command that is used to pull the images from GitHub, the Docker Hub. Okay, it is going to pull the image from Docker Hub and it is going to download. For example, if you want to download CentOS, press enter. It is going to download the CentOS image. If you want, you can even download the Ubuntu image. So any image you want to download, then you can do Docker pull and the image name. Just do Docker images. It will show you the list of images that you have on your local machine. Okay, CentOS. Interestingly, we just now downloaded CentOS, but it is showing 2 years ago. Why is it showing 2 years ago, 12 months, 2 weeks, 2 weeks? Why the timeline is changing? We have just downloaded it because the image was created 2 years back. The image of MySQL, the latest image, was created 2 weeks back. Okay, basically based on that, we are getting the timelines, and for each and every image you will have a unique ID, and this is the size of each image. Okay, now suppose I want to name a container. See here everyone, till now we ran like this -d nginx. I want to name this container. How can I name? If I don't give a name, what will happen? A random name will get allocated. See, random names will come here. So instead of this, I want to give the name to my container. Okay, I will just put -- name. Then maybe I'll just put, maybe it's a web server. I will put as web server. So what is this command? This is the name of the container. This is the image name, Docker image. This is Docker image, and this is the name of the container. If I press enter, let us see what happens. So currently we can see that just now whatever the container we have launched, that got named to web server. So the command to name the web server is this --name web server. Okay. Now I want to rename a container. Is it possible to rename a container? This is the name, Magical Newmon. I want to rename it. Is it possible? Just copy the container ID. Docker rename container ID. What is the name of the new container? For example, I will say front end. We can see that the name of the container is front end. So what was the command? Docker rename container ID and the name of it. So if you want to push it to other location, then you just launch it from the image. It will just come up. Container ID, this is the container ID. 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 For each and every container, you will have a unique container ID. Say this Docker PS. Docker PS is a command which is going to show you the list of current running containers. Docker PS-A. Docker PS-A. -A means all. Basically, Docker PS-A will list the current running containers as well as the containers which have ended, which has exited. Okay, you see on the right side. It got exited. Okay. So Docker PS-A will show you the list of containers which is already running as well as the containers which were exited. Okay. Now what is the command? Now obviously this is looking very cluttered. I want to clean it. I want to delete the containers which I am not using. For example, all the containers which are not running, which are in existing state, I want to clear it. What can I do? I will say Docker container prune. Okay. I can say -f also, but see this, what will happen? It will ask you, do you want to remove all the stopped containers? Yes. Now if I see Docker PS-A, it is only giving me the list of containers which are already running. What happened to the containers which were exited? It got removed, it got deleted. So what was the command to delete the containers which were in the stopped state, exited state? The command was Docker container prune. Prune means remove unnecessary things. Okay, we are deleting it. All right. Thank you, everyone. Thank you. Bye bye.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
All right. We were seeing the integration between the different tools, how GitHub, Jenkins, Maven, Docker, and Kubernetes are getting integrated together. And eventually, whenever there is a code push from the software developer side, that is, they are pushing the code to the GitHub, and eventually, automatically, the Jenkins job is going to trigger. Automatically, the Maven is going to happen. The build is going to happen. And then the Docker, we will integrate Docker. So whatever is the Docker file, we will try to use it. We will convert an image, basically create a Docker image, then push it to Docker Hub. Then eventually we are going to deploy that inside Kubernetes cluster. So all these things will happen automatically. That is what we are trying to do. So basically we created two jobs. That is upstream and downstream concept. Okay. In order to achieve it. So the flow is not broken, and then we will take it forward. turn on my Linux instances, the Kubernetes instances as well. Anyways, it will load in 1.2 minutes. I've just now started the instance. By that time, we will discuss this. The list of plugins that we are using. Okay, I'm just going to tell the prerequisites so that it's more clear. Inside Jenkins, we need to install Maven plugin, and there is something called as copy artifact plugin. These are the two plugins that we are using. Apart from that, in Jenkins instance, we are going to install two things. Docker. The second thing is going to be kubectl utility. In Jenkins credentials, we need to store Docker credentials, Docker Hub credentials actually. And then there is something called as kubeconfig credentials. What is kubeconfig? I will tell you. I will show it to you. Then, apart from this, in the Jenkins instance, we need to install these two things, and then credentials we have to do this. Then we will have two jobs. The first job, it will do git clone. Then it's going to do Maven build. When it's going to using the Docker file, Docker image is going to get created, and eventually it is going to be pushed to Docker Hub. Also, for the version, like what should be the version number? Version will be fetched from Git. Docker image version that will be fetched from Git using a command. In job 2, we are going to fetch version number from job 1. Whatever is the Docker image version number. Then here we are doing git clone for what? Kubernetes manifests. Then we are integrating the Kubernetes here. Okay. How it will get integrated using the kubeconfig file, which we will discuss. After doing a git clone, we are going to update the in short form Kubernetes manifests with the latest version, whatever the version we are doing. Okay, update the version number inside the Kubernetes manifest for the application, whatever is the Docker image version number, that version number we will update. After that, what is going to happen? We are going to deploy application in Kubernetes cluster. Okay, so all these things will happen. We are going to configure it once. Once the configuration is done, what is going to happen? All the configuration should happen automatically. That is what we are aiming, so that once the configuration is done, and again, if the software developer keeps on pushing the change, what is going to happen? It keeps on getting executed. In the sense, jobs, whatever the jobs we have, it should get automatically getting triggered. Apart from getting automatically triggered, what it should do? It should run whatever it is supposed to run eventually for all these pipelines. What will happen? Basically, after running, it should get deployed inside the Kubernetes cluster. That is what it should happen. Okay. So what is it that we are achieving? From the initial git clone, from the Maven build, then Docker image should get created from the Docker file, then it should get pushed to Docker Hub. And after that, what should happen? Then it should eventually get pushed to do it. We usually create one job for CI, one job for CD to have segregation. We don't want to clutter everything inside one job. Okay, and also using this, we are seeing upstream and downstream. Okay, so what we are going to do, I'm going to launch the Jenkins instance. We are going to see all the configurations now that we need to do for all this to happen. I will explain to the flow again. See, what will happen is basically inside this is configuration part. Okay, what plugins are needed, what we need to install in the instance, what are the credentials needed. Okay, the actual flow is inside the jobs. So in the job one, what will happen is whatever the application repository we have, okay, it will get cloned. After the application repository is getting cloned, what else is going to happen? Maven tool will get used. Okay, Maven tool will be used, and that is going to build the software. Build the software in the sense it is going to convert the source code into an executable format. Okay, and we are going to get that executable. After that, using Docker inside the repository itself, we will have a Docker file. So whatever we got the executable format, using that, we are going to take it up, copy it inside the Docker file. We are going to build the Docker image. After building, and in order to build the image, we have to obviously give the version number, okay, tag number. The tag number and version number, we are fetching it from the Git tool only. We are going to type certain commands for that. Okay, I've already pasted that in the shared drives, but we will see that hands-on. After that, after the Docker image gets created, then Docker will get pushed. Docker image will get pushed to Docker Hub. Okay, that is the only thing that is happening inside job 1. After that, in job 2, what we will do is we are going to fetch the version number, like Docker image version number is there, right? That version number we are fetching from job 1. Then we are going to, usually in real time, even the Kubernetes manifest is going to be on your GitHub. Okay, so we are going to clone your Kubernetes manifest, whatever is your deployment, whatever is your service. And every time the job runs, a new version number, latest version number will be used in Docker image is going to create it, right? So the latest version number we are updating inside the Kubernetes manifest. Okay, after that, what we will do is we are going to deploy that inside the Kubernetes cluster. So that is what we are doing. Okay. So that you will have source code in SRC there. So you will have the Docker file inside your repository itself. Okay. So what will happen when we are doing a clone? Basically, Maven is going to convert to an executable package .var, and in Docker file, I am actually using it .var, and it is going to place it inside some location. Okay, for the web application for Tomcat to run. All right, the instance that I'm going to use, it's going to be just a normal Jenkins instance. It doesn't have anything installed. It's a simple same, like a blank instance. Why? Because I'm showing you everything from scratch. Or else I have existing instances also. But configuration and all the plugins, everything is installed, right? If I open my previous instances, I have multiple Jenkins instances already ready, but all the configurations and all the plugins, everything is installed. But I wanted to show you from scratch. Okay. All right. So we are going to see the configuration now. Click on new item. So maybe I'll just do it as job 1. Okay. So here, what I'm going to do inside the job one is the first step is going to be doing the git clone. Okay, or else let us go back. I will save this off. First, let us install the plugins and come back. Let that be our first step. This is just a theme for Jenkins. We don't need anything for that. We have two plugins for the artifact. This is also installed. We'll go to tools. Maven. Just select whatever version you want. Say, just type Maven. Okay. I'll go back to my jobs. I'll copy this link. All right. So the first thing is, say, we are going to run this job multiple times, so we are comfortable. Okay, we are going with the flow. First, we are doing this, copying the code, main branch. Okay. Then I'm going to click on top level Maven targets. Select Maven. So till this part, we already know we have seen this multiple times. I'll just execute it. Okay. Then we will add one step, two steps, then we will execute it. You can use fork and use it. If you want to use it directly also, it's possible. It's a public repository. I made it public. Great success. Right. So the Maven build is complete. So two steps are already over. Git clone and Maven build. So we can quickly verify this in the instance. So after the Maven build is happening, this target folder gets created. And this is the package that got converted from source code. The next step is to integrate Docker on the instance. We need to install Docker and this particular utility. So we'll just install it quickly. And then we will go back to the job and we'll continue with the configuration. I mean, if you want, you can create an automation. You can use Ansible for it. Okay. You can also basically create another job and run all the shell scripts for it. For now, I'm just pasting it. Okay, because my focus is not Docker installation actually. My focus is the Jenkins job explanation. Okay. Going on master itself, we don't need master and slave as of now. I'll just confirm that without administrator. Okay, this is able to add. That is fine. This is one thing. Another is this install kubectl -classic. This one command is sufficient. This will install the utility. All right, it got installed. So that is done on here. I guess. Okay. So here, the next step is Okay. Now, after the Maven build, there is a Docker file here, okay, which will get cloned. When the git clone is happening, the Docker file is already there. Now I can enter the commands, as in I can say docker build -t. Obviously, this is the username of my Docker Hub account, followed by the application name. My application name is address, for example. Now I have to give image 1.1 or 1.2, 1.3, some version I have to give. And obviously, this job will run multiple times. So I have to update this version automatically all the time. So how to get this version number? How to get this version number? Okay, Docker build will be there, but how to get this version number? Now, how we are going to get this version number? We are going to get it from GitHub. In GitHub, we have seen tags concept, everyone. In GitHub, we have seen tags concept. What is the use of tags? It is for version number, fetching the latest version number. Okay. So what I want to do is I'm going to, usually what is going to happen, a version number, a tag number will be given in the GitHub and it will get merged to main. So whatever is the latest tag, okay, whatever is your latest tag number, that is going to be my version number. So anytime software developer works on new feature, eventually after all the branching strategy, everything is happening, all the version number is done. So new version number will come 1.7 and that will get merged to main. So what I want automatically the job 1 should get triggered and in the version number 1.7 should come. Okay, so I want this to happen automatically. So in order for that, I'm going to use a couple of commands. Before I show you inside the Jenkins, I'm going to dial. Okay, this is the repository. Now I would like to fetch the latest tag number. If I do git tag, I will get list of all the tags. I don't want this. I want all that whenever the job is going to run, it should fetch the latest tag. Currently it is 1.6. Next time, if it is 1.7, it should fetch 1.7. To do that, we are going to run command and fetch it. Okay, that is what we are going to do. So I will type this. This command will fetch the commit ID of the latest tag 1.6. Then we will do git describe. So basically we got version 1.6. Now I will combine these two commands. Just copy paste it. So something did not get pasted properly. Let me clear this file. So I'll keep it. Is 1.6, we got it. What I'm going to do in this particular version, this particular command I will run in my git job and it is going to fetch the latest version. I will store it in some variable like this, tag equal to copy, paste. So that the output 1.6 is stored here. If I do like this, I'm going to get it. Okay. Why am I pasting inside the variable? We will see, so that we can give in the next steps. So I'll paste it like this, so that here I can give like this $tag. That is why we are saving here. So every time the job runs, the latest tag number, the latest version number comes, it is going to get saved here like that. Okay, if we want, we can do PWD. If we want, we can do echo also, just to check. After this, obviously, I need to push this Docker to Docker Hub. In order to push this to Docker Hub, first I have to do Docker login. And how can I do Docker login? In the CLI in Docker class, we have seen, I will type the Docker login command, then I will type username and password. But obviously, when the job is running, I will not have that option. I will not be shown prompt to enter username and password. Neither do I want it. I want automatically everything should happen, no manual intervention. So you just add this. You just add this -u. -u means user. Okay. Now my user is going to be obviously user. I can type maybe. Okay. But obviously password we cannot type in plain text, because it will be visible inside the console output. I don't want it to be visible. So what I'm going to do, I'll scroll up. I'm going to use this option, secrets. Click on add. Click on last option. Okay. I'm going to save my username and password. I will say docker _ username, docker _ password. Okay. Then click on add username and password. So what is the actual username we are going to type? This is my actual username. If you want, you can just type this. Then what is your password? Maybe give some ID for it. Unique ID. Docker Hub credits. Docker Hub credentials. Just a description. Okay. Click on add. So what is happening? I have added the Docker Hub username and password, and that got stored under the Jenkins. So I do not have to type the username and password in plain text. We can fetch it from the Jenkins. Okay. And obviously, whatever is the username and password, it will not be shown in the output. Okay, because we don't want that to be happening right? Because obviously it's a security thing. Then come down. See this, just copy this. Whatever Docker username is going to be there, it will get copied into this variable. Whatever password was there, it will get copied to the password variable. So inside this variable, we will have our username. If we scroll down, sir, okay, -b $. Scroll up, Docker password. So using this command, what is going to happen? We will be able to log into Docker Hub. After we are logging into Docker Hub, the next thing that we are going to do is we are going to push the image to the Docker Hub. In order to push the image to Docker Hub, what is the command? Docker push. Okay. Followed by this. Followed by whatever is the tag. That is what we want to push. This is the command to push. After this, after the image gets pushed, we want to log out. That is what we want to do. We want to log out. Okay. We want to log out. So this is what we are going to try now. This is what we are going to try now. Okay. And we are not going to do anything else. We are going to see remaining part later. Okay, we'll come back, we'll again modify, and we'll see the remaining part later. First, we are going to say this, and then we are going to come back to it. All right. Very safe. Okay, let us just run this and we will see what will happen. So second time it has started running. So I am expecting all the steps should get executed. Something got an error. We will see where is the error. Okay, this is a common error. What we are saying is, it says that basically Docker command, okay, when Docker build command was running, it is throwing error stating that this particular Docker file is not accessible. Docker socket var run Docker. This is a common error. Once we run it from Jenkins, usually we get it. So how to resolve it? I will show it to you. Jenkins is trying to run the Docker command, okay, via Jenkins, but it is throwing error. To fix this is the fix for it. We are just giving permissions to this particular file. That's it. Okay, we are just changing the permission so that via Jenkins also it can get executed, not just via the direct commands. I will run this again. That's a very common error and the fix for it. Now it will not throw that error. Okay, now what happened? The Docker build got started. It is building the image now. And also using this rev list, what has happened? The latest version got fetched. The Docker image is getting built. Okay, Docker login is also over. Login got created and it is pushing the latest version 1.6. Okay, it got pushed. Success. So what we have achieved till now, in the job one, we have done the clone, we have done the Maven build. We fetched the latest version. We had the Docker image also. We pushed the image to Docker Hub. These are the things that we have done. Okay. Now what we will do, we are going to create job 2. But before we create job 2, basically we need to fetch the version number from job 1. So in order for job 2 to be able to fetch the version number, we are going to do certain configurations. Review in the sense, the only thing is after Maven we have done is Docker build and pushing to Docker Hub. That is the only thing that we have done here. See this. This is just cloning. We already have seen this. Docker credentials is what we have stored. After Maven, what is it that we are doing? We are building the Docker image. We are logging into Docker Hub, pushing the image to Docker Hub, doing Docker logout, and also fetching the version number from the repository. These are the things we are doing. So going back to the diagram, first, we are seeing what we are trying to achieve. So in job 2, it needs to fetch the version number from job 1. So we have to make minor modifications in job 1 so that job 2 is able to fetch the version number. First, I'm going to just create job 2. And just save it. I'll come back to job 2 later. So in this command, what will I do? I'm just going to add one statement. Maybe I'll just say $tag echo. I'll create a file called as tag file. Wherein inside this file, I'm just saving the version number. And this file inside this file, we have the version number. I'm going to fetch it from basically this file will be fetched by job2. Okay, so at the top, scroll at the top, I will give permissions. I'm just giving permissions to job2 to copy it. So at the top, you just click permissions to copy artifact. Then scroll down in post build actions, add this. Okay, the artifacts. Here, just type the name of the file. And also, it will just say it because we just now created it. After this, click on build other projects. Type job2. So what will happen here? What we have made the change, we have added the version number inside this file. Okay, and for it, in order for job2 to fetch it, we have given permissions here. Then at the end, after the job runs, okay, after all the command runs, we have asked this file to be archived so that it will be passed to job2, basically. Then we have also selected this option, build other projects. So what will happen after job 1 runs, automatically job 2 is going to get executed and job 2 will be able to fetch this file. I'll save it. I'll come back to job 2. I'll configure it. Okay. First, what I will do, I will show you a small output. All right, so I'm going to scroll down, say, right, what we can do here in job 2, select this copy artifact from other project. Just type job 1. It's okay, just scroll everything. What is it that you want to copy? I want to copy tag file.txt. Just remain everything as default. We don't need anything. So what is it that copy artifact from another job, type the name of the job, that is job 1, and tag file.txt. That is sufficient. After that, what we have to do is, okay, I'm just going to add this step. I will execute and show it to you. Then I will add the further commands. Maybe I'll just say cat and the tag file. Okay. Tag and the file. That should be sufficient. Or else I can do like this also. Version. Echo $. So let us just execute this. Later on, we'll continue with other commands. There is more 2 or 3 commands. Then this should be done. I'll save this off. So job 2, I'm not going to run. Okay. I'm just going to run job 1. Say here what has happened. Obviously, the job one succeeded. Okay. And it has also executed job 2. So we'll go back to job 2. See it got executed automatically. So let us see the output. So see what has happened. It was able to fetch this file. Okay. And inside the file, we had this version 1.6. All right. So version 1.6 came inside the job 2. What we are going to do now. See, in this same repository, on some other branch, usually we will have Kubernetes manifest. Okay, we have this Kubernetes manifest. For example, we will have deployment and we will have services, so on and so forth. So here it is saying 1.2, but every time the job runs, it should get updated 1.6, 1.7, 1.8. In job 2, we are going to do clone again, but we are cloning the Kubernetes manifest because we want to deploy Kubernetes manifest inside the Kubernetes cluster. I'm just going to change the branch here. Kubernetes deployment. All right. Then I'll just scroll down. Obviously, I need to integrate Kubernetes. I will show that how to integrate. The first thing is I need to update. What I need to update? I need to update this one. For example, I'll show this. Okay. We have this branch, Kubernetes deployment. Inside the Kubernetes deployment, we have these files. Okay. Now inside the deployment, I have this version number 1.2. What do I want every time the version gets updated? 1.3, 1.5, 1.6, 1.7. I want to update this. I want to update this automatically and then deploy inside the Kubernetes cluster. So how am I going to do this? For that, I'm going to use one command, which will basically update inside this file. So what is the command? For example, this is a Linux command. Basically, I'm going to select this and change it. I'm just going to say okay, dollar version. I'm not sure if that's the version here. Okay, one moment. I'll just manually type like this. Version equal to 1.6. Okay, version we are already fetching it, so it's not a problem for us. Okay, set command. We did not present it, it will not store. The image is obviously my name followed by application name. That was the top, then the file name. See what is going to happen when I enter this command. Now, if I open this YAML file, automatically the version got updated to 1.6. So inside the command, what has happened is I have directly selected inside this line image, Sohail, and this address book. Okay, followed by after colon, whatever is your number. Okay, change it with dollar version. So it is just changing that. And this is your deployment.yaml. So we are giving the file name. So with this command, what will happen is whatever is your latest tag each and every time, it will get updated. So we are going to paste this inside our Jenkins job. I'll paste this off. After this, okay, our Kubernetes file is ready. Deployment file is ready. Now how to apply, how to integrate Kubernetes cluster with job 2. The command is, I'm just going to put it. See this kubeconfig. Okay, let me go to Kubernetes cluster. This is your Kubernetes cluster. All right. This is your Kubernetes cluster. Okay, fine. In Kubernetes cluster, you will have one hidden folder .kube. Inside this .kube folder, you will have this config file. This is called as kubeconfig file. Basically, this is certificates. This is the certificate of your Kubernetes cluster. Okay, if you have access to this particular certificate, then you will be able to interact with the Kubernetes cluster. So we are going to copy this. Maybe I'll exit or maybe I'll just come outside. This is going to be my terminal. Okay, I'll just create something called as config. I'll save it off. Okay. So and I have saved this. Okay. We will see now what I will do. Now I'll go back. I'm going to save the Kubernetes configuration, that is kubeconfig, in the credentials, because we can't give the whole certificate in plain text. So what we are going to do is we are going to click on secret file. Okay. See what I've done. I went up. Okay. Click on secret text on user. You click on add. In add, click on secret file. Enter the variable kubeconfig. Okay. Select this option, secret file. In secret file, upload the file. Enter here as kubeconfig. Enter here as, obviously it will take ID is taken because I've already used it. Kubeconfig file. Okay, click on add. Once you click on add, it is going to come like this. Okay, just upload the file that we have downloaded, the kubeconfig file. Scroll down. kubectl -- kubeconfig equal to config file. Okay. Followed by, what is the command? Apply -f star.yml star. So what basically we am telling here is that when the git clone is happening, okay, if I do like this, see what is happening, with this kubeconfig. I don't have the config file here. I have to save it to show you. Or the CLI kubeconfig. Yes, authentication is happening. Basically, it will interact with the Kubernetes cluster, and then this is the normal command: kube apply -f star.yaml means all the files, this deployment and this node port, both the files will get deployed. So if I go back to the Chrome, this is what is happening. It is applying all the Kubernetes manifest. All right. So we are going to run job 1, and then we will see what is going to happen. Basically, what should happen if we are going to run job 1? Everything should happen now. Okay. Everything in the sense, git clone should happen in job 1, git clone of the application source code. Then Maven should happen, the version number should get fetched, Docker image should get built, Docker image should get pushed. Then job 2 should fetch the version number from job 1, git cloning of Kubernetes manifest should happen, Kubernetes manifest version should get upgraded. Then deployment happen inside the Kubernetes cluster. All the things should happen by itself. So let us go back and check. So I'm going to go to job 1. I'll close on the start. I'm just going to run this again. The job 2 automatically ran. It is in pending. Okay, let us see. Okay, so running is fetching everything. And what has happened? It changed it, it applied. So what got happened? Deployment got created, service got created. Service was already there. So it got created. Let us go back to the Kubernetes cluster and check if everything is deployed. So I'm just going to do kubectl get deploy. All right. So I see this is the deployment. Okay, it happened 41 seconds ago. This is the old deployment, so you can ignore it. So it happened 41 seconds ago. If I do kubectl describe deploy / what is the version number? See, address book 1.6. So it get deployed inside the Kubernetes cluster as soon as the job is running. And what is the service? I have just deployed the service. So 30089. Basically, this is a small application to store the customer information. What is the name? What is the email? What is the first one, and so forth, etc. Anyways, we are bothered on the job 1 and job 2. So what was job 1 able to do? Job 1 was able to do a git clone of the repository. Okay. Then it did Maven build. Then we fetched the tag number, version number from here. We did the Docker build. We pushed it to the repository. Okay. And we triggered job 2 and we passed this file to job 2. Inside the job 2, I have pasted the repository, but Kubernetes deployment branch. In here, we fetched the tag file. We got the version number. We changed the version in the deployment.yaml. We applied it into the Kubernetes cluster. Then what happened? It got deployed inside the Kubernetes cluster. Okay, so 3 minutes back. So whenever it's going to run, it is going to just deploy it inside the Kubernetes cluster. We need to see one more thing. There is a webhook trigger configuration that we have to do. As we were discussing, what do we want? I mean, this is till now what I have done is in the job 1, I'm clicking on build now. That is what we are doing in the job 1. Till now, what did I do? All the configurations are done. I'm clicking on build now. Then the job is getting executed. I don't want this behavior. I don't want this behavior. What do I want? Whenever the software developer is making any change, I want the job to get triggered automatically. Okay. For example, in the source code. Software developer is pushing a change. Okay, in the main branch. So basically what I want is, I want to trigger it automatically. So I'm going to make change. Okay, for that I will log in. See here, what I am doing. This is the settings. Settings of the repository. Click here in the settings. Click on the webhook. Okay. I'll delete this off. So go on to your repository, click on settings, then click on webhook. Click on add webhook. Save the URL. Here, paste it here, Jenkins URL. Type here github-webhook/ okay. URL followed by this is compulsory. github/webhook. Click on add webhook. What this webhook will do is it will notify the Jenkins whenever we are going to do a push. Then software developer is doing the push. Okay. The repository, the webhook will notify Jenkins. Specifically this job. How will it notify? In this build triggers, I'm going to click on this option, GitHub hook trigger. So whenever there is any push in the repository, it will automatically notify job 1 and job 1 will get triggered. Okay, that is what will happen. GitHub will notify Jenkins. Jenkins will trigger job 1. So the config is very simple. In the repository, just go in the settings, go in the webhook, just add the URL /github-webhook. And in job 1, just select this option. This is more than sufficient. This will do the job. Then we do not have to click on build up. Okay, we do not have to click on this. It will happen automatically. I'll do a sample. I'll not add a tag. Okay, I'll just do a sample. In job 1, I'm only cloning main branch. So it will happen to main branch. I'll make a small change, okay? Just to test it. I'll make a small change here. I'm just going to delete this, okay? I'm not going to add anything. I'm just going to push. I'm going to make a change in the main branch, a commit. Okay. So what will happen? If I go back to job 1, okay, I'm going back. I did not click. See on the left-hand side, bottom side, what happened? Automatically, the job got started. And what does it say? I mean, if I go back, started by GitHub. Okay. Started by GitHub push. So GitHub webhook trigger will happen whenever there is a push on your GitHub repository on your main branch. It will automatically do it. Okay, automatically the jobs will get executed. This is the flow.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
So we'll start Terraform. The agenda is in the Terraform to understand what is something called as infrastructure as a code. Okay. And to understand, like we have already seen Ansible, what is the difference between structure as a code versus configuration management. After that, we'll look into Terraform, how to install, set up everything. Then what is Terraform operations? How does it work? What is the syntax? Then we'll try to do demos on that. So we'll see. Okay. Infrastructure as a code works in simple terms. Inside a file, we are going to write configuration. Okay. With the help of that configuration, infrastructure will be created. When we say infrastructure will be created, we are talking about servers, VPC, gateways, subnets, okay, all those stuff. Anyways, inside a file, configuration is written. Usually we'll call it as a infrastructure as a code. Basically, for creating the infrastructure, we are writing a script. Okay. We are writing a script. Script is nothing but we are writing the configuration on how the infrastructure should get created. Infrastructure in the sense EC2 server, VPCs, NAT gateway, basically all those stuff, routes, so on and so forth. So using inside the script, okay, either we can create the infrastructure, also obviously we can destroy the infrastructure as well. Now, whereas configuration management tool means, okay, the purpose of configuration management tool is not to create servers, not to create VPCs, okay, not to create infrastructures. The purpose of configuration management tool is that already existing hardware, in the sense on existing server, we are just trying to make modifications, that is software uninstall, reinstall, changing couple of files, okay, modifying certain files or certain folders on a certain location. So already on the existing server, you are basically trying to doing modifications. That is the focus of configuration management tool. Now, if you ask me, is it technically possible to create EC2 server using Ansible? The technical answer is yes, you can create. Okay, but as per the real time, no one will use it. Why? Because it's complicated. Because configuration management tool should be used for configuration only, not for infrastructure building. Whereas if we use like Terraform, it is very easy and it will have more features compared to Ansible. Okay, both are doing different things. The purpose is different. Now, using infrastructure as a code, what we can do is, suppose we are building a server from scratch, a new server. While the server was getting created for the first time, we can install the softwares. That is called bootstrapping. In the sense, I created the server just now. Okay, as soon as the server got created, at that moment, I can install the software, not after that, using infrastructure as a code. Whereas configuration management tool, you can install, modify softwares however you want. Okay, but not at a hardware level after the servers are up. So that is what it is, right? So infrastructure as a code should be used only for building infrastructures. That is the purpose of it. It should not be used for configuration management. Neither configuration management tool should be used for infrastructure building. Now, the first question arises, why would anyone use Terraform, for example? There are other tools as well. GCP has its own tool, Deployment Manager. AWS has its own tool, CloudFormation. Azure has its own tool. Why Terraform was chosen across the industry? What is the reason? Now, what we have to realize is AWS CloudFormation will only work for AWS environment. GCP tool, Deployment Manager, will only work for GCP, so on and so forth for Azure. But whereas Terraform is multi-cloud, okay, if you learn one tool, obviously the syntax will vary. The general syntax is same, the syntax keywords will vary. But if we learn one tool, we can build infrastructure on all the clouds, on AWS, on GCP, on Azure, as well as on OpenStack. We can build infrastructures on all the clouds. Also, now currently see the Terraform was usually belonging to a company called as HashiCorp. But recently, IBM has taken over it. They purchased it. Okay. So currently it is open source for individual users. Individual in the sense, for everyone, it is open source. But will it remain open source in the future? I mean, IBM has to tell us. Currently, it is open source for individual users. So we can use Terraform. So now there are some certain operations, like there are certain commands called that init, plan, apply, destroy. We'll come back to this later. First, we will install Terraform, okay? And then we are going to come back and try to understand the operations, try to understand the syntax, okay? So we'll just launch it and wait for it to come up in a minute. Okay, just give me a minute, guys. I'll log in into the instance. I'll just rename this. So in order for the Terraform to work in the sense, we are going to write the configuration. Now, obviously, when we are going to execute the configuration, I want the infrastructure to get created on AWS as of now, right? Because we are seeing the demos on AWS. So we are going to, like, how will the integration happen between Terraform and AWS? In the sense, whatever scripts we are going to write, it should get executed. Okay. it should get executed on the AWS. That is my account. Inside my account, the infrastructure should get created. So how will that integration happen? Like what are the stuff needed in order for that to happen? Okay, in order for the integration to happen. So in order for the integration to happen, we need two things. We basically need some kind of a user ID and password. That is some access ID and some secret ID, secret key from the AWS. Okay. And then we need to enter that into something called as AWS CLI. So we need two things. The only primary stuff which we need is AWS CLI. Okay, let me just grab it. Okay, here it is. I'll just quickly grab and install it. So what we have done, the first thing is I have installed unzip. Okay, unzip tool I have installed. The second thing is if we just enter this command, it will download this AWS setup. The third thing is we have extracted the AWS setup. Fourth thing is we have installed it. Finished. I mean, installation is super easy. It should be there in the document. Okay. After AWS is getting installed, we have to generate the user ID and password. User ID in the sense secret key and the secret password one. Access ID and secret ID. Let me share it again. I'm going to show you how to create it. See on the top right hand side. On the top right hand side, just click on your account. Click on security credentials. Where did we click? On the top right hand side, click on user account, then click on security credentials. Scroll down and just get rid of it. I already had keys, so I'll just remove it. All right. Click on create access key here. Now it is just going to show it, doesn't matter. We need access so that we can create infrastructure. So we got something called as access ID and the secret key. Copy this access ID. Then let's go back to the terminal. We'll type the command AWS configure. Press enter. So we need to press to the access ID. Okay, I'll grab the secret ID also. Anyways, okay, press default, press enter. Now these are the only two things which is required. I'll enter a command and it will just tell us whether the configuration was successful. Successful in the sense whatever we entered, it's there. This is the command. Get the identity. So this is my user account. Okay, ID. ARN means AWS Amazon resource name. Okay, so it's done. So what did we do first? First we installed AWS CLI. Okay. Second, what did we do? After installing AWS CLI, we went to our account on the top right hand side. We clicked on security credentials. After clicking on security credentials, scroll down, click on access case. Okay, click on create access case. What will happen? Access key gets created. Okay, access key gets created. Yes, this is what we have done. Don't need the second one. Then let us go back. The third thing is we install Terraform. Okay, we already have the commands given by them. We'll enter it. So the Terraform got installed. We will just say Terraform version. Terraform got installed. So in Terraform, the first thing that we are going to do is I'll create one folder first. I'll just say demo. Go inside demo. See the first command that I am going to enter in the sense before I enter a command. Okay, I'll write a script, then I will enter a command. There are a couple of commands that will remain constant. Whatever script you are going to write, those commands we have to enter. Okay. So first thing, let me write that script. So before writing the script, what is the ending part here? .tf. Okay. Convention is the name of the file is main. .tf. TF means Terraform. Here, the syntax that we are going to write is called as HashiCorp configuration language. Okay, it's called HCL. Language does not mean like a programming language. It's just its syntax that we are going to use. So whenever we are going to write the syntax will be usually common. It's just that the keywords will change. And with respect to whatever we want to create, how to find out the exact syntax that we will discuss after some time. Now I will show you. So where are we creating our infrastructure currently? I am creating my infrastructure on AWS. So I will say provider is AWS. And inside which region are you creating your infrastructure? What is the region that we are going to create? For example, currently I am in Waterfall region. Okay, that is AP South 1. So I have to give the name of the region where I am going to create the infrastructure. All right. So I'm going to give this region name. If you want to create infrastructure in any other region, then give any other region name. Okay. The region I have pasted here. Basically, in the AP South 1 region, we are going to create the infrastructure. That is why we have mentioned it here. Now, whatever we want to create, we are going to type resource. Suppose we want to create any infrastructure. The syntax is first we are going to write resource. Then we are going to basically write what is it that you're creating. What is it that you are creating? Okay. For example, I'm creating AWS instance. Obviously, these are keywords in the sense we have to type exactly the way it is. If you do type something else, it will throw errors. So how to get the exact keywords and syntaxes I will show you at the end. AWS underscore instance. Then basically just write a different name. I will just name this block so that later on we can use it somewhere. You can name this to anything, the last thing. It's just a name for this. Inside this flower brackets, we are going to write the configuration for instance, in the sense what kind of EC2 instance we want to create. Okay, this just says that we want to create instance on AWS, but what kind of instance do we want to create? That configuration we will do in these two brackets. So first I'm going to write AMI, Amazon Machine Image. Basically what kind of image you want to create, like what kind of operating system you want to have, and what kind of instance, whether you want T2 micro, whether you want something called as T2 medium or T2x large. So what kind of instance you want to create, that we can give here. So I will be showing T2 micro because we are going to see multiple times. Now, if you want to just give some tag names, maybe I'll just say that this server tag name is Terraform hyphen instance. Okay. We will start with simple example, then we are going to see multiple examples on top of it. So I will save it. The first command that I am going to enter is Terraform init. I'll press enter. So what does it do? It is basically initializing, basically it is downloading the plugins. So in order for the AWS and Terraform to get synced, what will happen in the backend is when you type the command Terraform init, okay, it will download AWS plugins in the backend, which will internally Terraform will use to communicate with AWS, and it is going to create the infrastructure on the AWS. Then what was that AWS configure we did? We entered some secret ID, we entered some key access ID and secret ID. What is that? That is for authentication only. Okay, that is for authentication. What is this? Internally, these plugins will be used by Terraform to build the infrastructure on AWS. For example, when the moment you do Terraform init, there will be one folder called as .terraform, which will get created when you type Terraform init. Now let us go inside that folder. Let's see what is happening. The AWS. Let's just clear this. So what has happened? It has downloaded the plugin. Okay, this is called as plugin. Internally, in this .terraform folder, it will download the plugin. Okay, which will be used internally by the Terraform. When you type Terraform init, it is basically getting initialized. If you want, you can type this command 10 times. I mean, it's not going to harm. You can press this again. It will not impact, not destroy, not create any kind of problems. It is not going to create any kind of problems, even by mistakenly if you type this command. Okay. The next command is something called as Terraform plan. So what it will show is, basically it is showing you like what is it going to happen if we execute. Okay, currently the execution has not happened. Currently execution has not happened. It's like a dry run. Means it is just showing you what will happen if you actually execute the script. So we have written a script. Actually, if it's going to get executed, what is expected, like what is going to happen? It is just showing you. So it is telling that resource will get created. Resource will get created. And it is just giving the details. Okay. This is the AMI number, like T2 micro instance will get created, so on and so forth. Basically, one resource will get created. One resource will get created. So it's just showing you what is going to happen. I'll say this, Terraform apply. This is the command which is used to actually implement on AWS. What is the command? Terraform apply. This will actually implement your script, implement infrastructure. That is EC2 instance will get created now after Terraform apply. So it's just asking for a confirmation. We are just going to type yes and press enter. Now it will create the instance inside my account, inside AWS. Okay, so what has happened? Instance got created. Okay, let us go back and check. So we can see here something called as Terraform instance got created. Okay, Terraform instance. We can quickly check the ID. See here. Else we can only take the characters from backend. 3883. See? So instance got created. Okay. So we created the instance. Now I suppose don't need this instance or whatever. We will just see how to destroy it also. So we have a command called as Terraform destroy. I'll press enter. Yes. So what will get destroyed? You see, it's in red color in minus symbol. So it will destroy the instance that we have created just now. I'll just press enter. So what happened? The instance got destroyed. Let me just refresh this. So what does it say? Terminated. So the instance got destroyed. If you want to apply it again, you can apply. And yes, see this. We'll talk about it. What is happening? Now, this was our previous configuration. I'll apply it again. Okay, it's okay. I'll apply it. I'll do Terraform plan. Okay, it's always recommended. First, we do a plan and then only apply. I want to talk about two things here. So instance got created. Okay, if I just do a refresh, instance got created. Okay, I'm going to talk about two things here. First is the instance got created. That's fine. Now, when I'm typing Terraform destroy, I'm not giving the ID of the instance. I'm not giving the name of the instance. I'm also not giving in which region it should destroy, it should delete, terminate the instance. But still, how does Terraform know that it has to destroy that specific instance? Now, using Terraform, we have created specific instance. Obviously, after the creation of the instance, we got this ID and relevant informations. I enter the command Terraform destroy, and it is able to destroy, it is able to terminate that specific instance which was created. But I have not given the information about that instance. Neither I have given the instance ID, neither I have told like in which region it should destroy it, but still Terraform is able to do it. How is it able to do it? Okay. Internally, what will happen? It will create a file. Okay, after you are doing what, it will create a file. We have done Terraform plan and also we have done Terraform apply. So basically, we have created the infrastructure on the AWS. So it will create a file called as terraform.tf state. It is also called as state file. Terraform state file, some people will just refer it to the state file. Now, what will be there in the state file? Basically, it will store all the information when the instance got created. Okay, what was the name of the instance? What was the subnet? What was the ID? Okay, what was the IP address? What was the public IP address? Where it got created? All the information it will store it. See, all the information it will store it. So whenever you're going to apply or make changes inside the instance in the AWS account using Terraform, what Terraform will do, it will save that information inside something called as Terraform state file. So when you are trying to destroy, it will internally use the state file and destroy that particular instance. Also, later on, when we are going to modify this main.tf file also, internally it will use Terraform state file. First, I will destroy. So internally, it will use the state file and destroy the instance. So what has happened? The destruction has happened. Basically, it got destroyed. I can see it got terminated. I'll just click on this instance ID. Okay. So here, when the instance got created, we have not assigned SSH key. Okay. If we have not assigned the SSH key, obviously we will not be able to do SSH. That is logging inside the terminal using SSH. So what we want to do next time, I want to create an SSH key, okay, while the instance is getting created. But before that, I'm going to show you other example. The second thing, there is something called as immutability concept. Immutability. Okay, I'm going to show you example. What do we mean by immutability? I'm not going to make any changes right now. First, I'm going to create the instance again. So I just now created the resource again. Resource in the sense AWS instance. So one now just not still initializing. It got created just now. So obviously, as I mentioned, it does not have SSH key. So what do I want? I want SSH key while creation. Anyways, I'll go back inside my script. Okay, I will create an SSH key. Okay, I will create an SSH key. How to create? I mean, if you want to create from scratch, we can create it. If you want to use an existing SSH key, that also we can do. Key name is existing. If you want to use existing, if you want to create a new one, we will do like a key pair. Maybe I'll just say SSH key. I will say key name is equal to SSH key demo something. Okay, this is going to be the key name. First, we'll go and create an SSH key. Then we'll come back. This will basically upload your SSH key pair. Now, what is the command to create SSH key? SSH hyphen keygen. Okay, I'll keep it default SSH hyphen keygen. This is the command to create the SSH key. All right, what has happened? The SSH key got created. It is usually inside this folder. This is public. This is private. .pub means public, and this is private. This is the directory where we have the key. I'll go back here and I will type it. Okay, I will type it and I will mention the key that I am going to use. Now, obviously, what this is doing is it is just going to upload the public key to my AWS account inside this region. It is going to upload, but I want to attach this key to this particular instance. That is, once the instance was getting created, already the instance is already created. Okay, so basically, I want to attach the key to the instance. So I'll give something called as key name here, but I want to use this one. I want to use it from this one. So how to use it? What should be done? See this. I want to use this block. So I will copy the name of it. Dot key underscore name. So what is happening here? This block will just upload the SSH key to my account. But here, what will happen? This will actually attach the SSH key to the instance. So in order to use it, I have just copied this here, .ssh, the key name. Okay. Now see what will happen regarding immutability. I will do Terraform plan again. Okay. If I go up, it says AWS instance must be replaced. Now, what do we mean by that? AWS instance must be replaced. That is, if we see here, there you will see a lot of minus symbols in red color. Okay, there will be all this. Okay, obviously this is nothing but new key is getting created, but you see. So basically what is happening is the existing AWS instance is getting destroyed and a new instance is getting created. Let us do a Terraform apply and we will see. My fault. Terraform apply. So what it is doing, as we see on the screen, first it is destroying the existing instance. After the destroying is complete, what was happened? It has, you say, created this key. And now it is creating the instance. Okay. If I go back, it will throw error because the earlier one got deleted. See, it is getting initialized. So the old one got deleted and this is the new one. In the new instance, what has happened? Or not the demo, right? It's Terraform instance. I clicked the wrong instance. This one. In the new instance, the key pair got attached. Okay. Now the question remains, why did it delete the instance and created the new one? why was it not able to just attach the SSH key to the instance? Okay, why did it had to delete the old instance and then new instance was created? The answer is immutability. So let us understand what is immutability. Okay, so we had just made a small change, but instead the instance was destroyed and recreated. Okay, so there is an concept called as immutability. Immutability in the sense the moment your infrastructure is created, okay, once it is created, it cannot be changed. If you do any kind of change in the infrastructure, it will get destroyed and it is going to create the new infrastructure. Immutability, if we make any change, okay, immutability in the sense after creating the infrastructure, we cannot create any change. In case we are creating any change, it will destroy the old infrastructure and create the new one. Now, why immutability is doing it? Why? Why is it that a small change is happening and it will destroy the old one and create a new one? Okay, because Terraform and the infrastructure, they are keeping immutable. In the sense, once it gets created, it cannot be changed. In case we are changing it, it will completely destroy it and recreate it. The problem that was happening earlier was called as configuration drift. There was a problem in maintaining the infrastructure, not just creation. The infrastructure was getting created, that is not an issue. But while maintaining it over a period of time, 1 year, 2 years, 3 years, the infrastructure was having a problem called as configuration drift. In order to avoid this problem, the world has moved to immutability concept. So what is this configuration drift problem? What is this configuration drift problem? Suppose as a DevOps team, you're managing multiple servers, maybe 10 servers, 20 servers, 100 servers. You're managing many servers. Okay. Now, obviously, the infrastructure got created. That is fine. But later on, as I mentioned, over a period of 6 months, 1 year, 2 years, you will make changes to your infrastructure. For example, we have seen just now, we added SSH key to one of the server. Then another server, maybe we will add some other kind of configuration. Maybe to one specific server, we will open ports. Then maybe some issue happens, we will go inside that server manually and fix it. Okay. Over a period of 6 months, 1 year, 2 years, what will happen? The infrastructure is not consistent. We will not remember exactly what are the changes are getting made inside those specific server because we are not maintaining any state of infrastructure. Okay. So after 1 year, 2 years, what will happen? So every server will have some other kind of a configuration. Every server will eventually have some kind of a different configuration. Now, if the problem arises, it's very difficult to solve it. First of all, we have to identify like what is the difference, what has happened, why it has happened, and earlier if someone has fixed or made any changes, what they have done it. Maybe 1 year back, what they have done it. 2 years back, what they have done it. It's very difficult to maintain the infrastructure. So what the world thought, it is very difficult to maintain the infrastructure because of this configuration drift. So let us use this immutable concept wherein we are going to maintain the infrastructure. Like we are not, after we create the infrastructure, we are not going to modify it. If we are going to modify it, we will destroy and get it recreated. And however, all the configuration that is required in order to build the infrastructure, for example, Terraform scripts, Terraform code, and even if it is some kind of other tool, all the configurations will be there on the GitHub apart from the state file. Okay. So all those configurations will be there. So it is very easy for them to fetch the configurations back and recreate the infrastructure immediately. Okay, that is why here in the example we have seen, that it destroyed first. Later on, it created. Okay. Now let us see another example. I'll go back here. This time what I will do, I will delete this. Instead of using the key, okay, I'm going to use existing key pair. Maybe I'll use DevOps. I can use something called as DevOps. This is my existing key pair name. So if I come back here, I have a couple of key pairs. This is the one we just now created. Okay. If I want to use an existing key pair, if we just type the name of it, that is more than sufficient. If we just type the name of it, it is more than sufficient. So we'll come back to this. Okay, I'll destroy the instance. I'm going to show you completely a different example, maybe. Okay, now I am going to show you a different example, that is bootstrapping. While the instance is getting created, I want to install or execute something. Okay, in the key name, if you type DevOps, this is sufficient. What will happen? Inside my account, I have an existing key called as DevOps. It will attach it. So this step, you do not have to create any new key pair. Here, if you just keep the name of an existing key, that is sufficient. Okay. Apart from this, see what I'm going to mention. I'm going to mention here the security group that should be attached to this particular instance. Security group. Obviously, I will have many because I showed demos, but this is the security group that I want to attach. So what will I do? I will just copy this ID. That is sufficient. And we will paste it inside the script. Okay. So what it will do is it's going to attach this particular security group to the instance. After this, okay, say provisioner. There are two methods. Once we create an instance, like while the instance is getting created, we can run commands or install specific things as soon as the instance is getting created. Okay, one is called as remote exec. There is another things also. Okay. See what is happening here. Once the instance is getting created, okay, I am going to do SSH. We are seeing two methods. First method we will see now. Private key I will mention later. Private key of this particular DevOps. The self, I will explain this config. We can decide this command we can type command or whatever it is, anything. So on and so forth. Okay. So I'll go from here and we'll come back. So inside this AWS instance, what we are doing is we have an existing key pair. Obviously, this is inside my account. So in order to use an existing key pair, you just give a name of it. So the public key will get attached to this particular server. Also, I have added this specific security group. Okay, existing security group to the instance. If I scroll down now, we have something called as provisioner. So as soon as this instance gets created, what will Terraform do? It is going to remotely log in inside the instance that is created just now using SSH. Okay, obviously we have to give the private key file. Similarly, whenever we are doing SSH every day, in order to log in inside the instance, we are doing SSH-i devops.pem. That is the private key. So even the Terraform will log in inside the instance remotely using SSH. So we have to provide that private key location here. Post equal to self.public IP. Obviously, when the instance got created, so Terraform knows what is the public IP address of this particular instance. So it is going to use that public IP in order to log in. Then in this inline, basically we are typing the commands. After doing SSH, these are the commands that should get executed inside the AWS. Okay. So the only thing pending is we have to give the private key location. I have to give the location of private key. Obviously, private key, I have stored it inside my personal laptop. I'll just paste it. Okay. So I copied the private key from my personal laptop. I'll paste it here. So this is the private key. Okay. See this? This command is standard. Basically, we are changing the file permissions for private key. In AWS, the private key permission should be either 600. If that doesn't work, then it is 400. Okay. Now I have saved it. We can do Terraform plan. So it will create the infrastructure. We will apply it now. So it's creating the instance. After creating the instance, it is now currently trying to do SSH inside it. Okay. So what has happened? First, it created the instance. After the instance was getting created, it SSH'd inside the instance. After doing SSH, okay, see, this command is getting remotely executed on AWS EC2 instance. Anyways, so it is running the commands and it is giving the output. So I tried to install Nano and it was already installed. Anyways, then it got updated. We got an update stating it got created. Overall instance got destroyed, so it's just an error from that. So what has happened? Terraform instance got created just now. And we can see it is using DevOps key pair, as we have mentioned. Inside this particular location, private key, we mention where is the private key located. Okay, so I have created the file inside this location, in the home location of the user. The username is Ubuntu. The home Ubuntu and the private key name. We will see a different example now. Till now, what we have seen is that, I mean, I don't need provisioner and everything. I can just get rid of this. Okay. Till now, we have created the EC2 server. Okay, one EC2 server. What if I want to create multiple EC2 servers? How is that possible? Till now, we have only created one EC2 server. Okay, I'll just destroy the old one. Spelling mistake. Okay. So till now, we were creating the infrastructure. Okay. And one server was getting created. I want to create 3 servers. Do I need to copy this and paste it 3 times? Is it like that? No. There is a simple option. See this. You just mention count equal to 3. What do you mention? Count equal to 3. If you want 2 instances, count equal to 2. Okay. Name I'll show you how to change the name. If you see count equal to 1, count is 1. If you want like 5 servers, put 5 servers. Want 3 servers, put 3 servers. It is up to you. Okay. Just give count and how many servers of the same exact configuration you want to get created. Just mention that. Now, here, obviously, the name is Terraform instance. So the name will be obviously the ID. Each and every Terraform each and every AWS EC2 instance will have a unique ID. Okay, even though just this is not FQDN, right? This is just a name to it. Tags. But I want to give different names. Maybe I want to give Terraform instance 1, Terraform instance 2, Terraform instance 3. Okay, because all the instances will have exact same configuration. It is just that we have multiple instances. So how can I append those values here? See this. You can do $. We are using count, right? So type count dot index plus. Okay. What is happening here? Count dot index means the count will start. Okay. Count means 3 are there. So 3 servers will get created. Usually, whether in programming languages or whether in scripting languages, the index starts with 0. 0 means the first item. 1 means the second item. 2 means the third item. So the index starts from 0. So 0 means first item. Index of 1 means the second item. Okay, like that. Plus 1. So I'm telling the name is going to be Terraform instance 1. Next time when it is creating the second instance, Terraform instance 2. Next time it's going to be Terraform instance 3. Like that. I'll save it. I'll say Terraform plan. I'll say, see what is it showing here? 3 to add. Terraform apply. You can see here index of 0, index of 1, okay, index of 2. This is nothing but 3 instances are getting created. And we have 3 unique IDs. So let us go and check. So we can see here 3 instances got created. Okay. 3 instances got created. 1, 2, 3. Okay. And we can see 3 IDs. 1, 2, 3. So automatic name got appended and 3 instances got created. Now what I want is, out of the 3 instances, I want to destroy 1 instance. How to destroy? Okay, till now, whenever we did the destroy command, it has destroyed everything. But this time, what we want is, instead of destroying everything, I want to destroy specific thing. So how is it? Well, how is it possible? So what we will do here, we will say Terraform destroy. You already know this command. What this command will do. Okay, you already know this. What are we going to do? How are we going to select? We are going to mention, okay, we are going to mention target. Like that is select specific thing. So we will say target, okay, AWS instance. Or else let me go back. Okay, I just said, you can see here. Basically, this is the resource. From this resource, one of the things we want to delete. So I'm going to type this resource. I'm going to type this resource. Because from this resource, we are deleting 1 instance. Target colon AWS underscore instance dot instance 1. Okay. Now I want to delete the third instance. So the index ID is going to be 2. Simple. I'll press enter. Okay. It will just say no object to. So I will just add an option and it will destroy it. So currently I have targeted that. Why I have not created? Because I have done something here. Yeah, Terraform 3 is created. Terraform 2 is created. Where is Terraform 2? Terraform 1 is also created. So I'm targeting specific instance. Okay. Just put target AWS instance dot instance 1 and give the index ID. So only a specific instance will get destroyed. Other 2 instances will remain same.
So our first question asks us, can we explain the Git architecture? Now, this is fairly an important question, reason being, only if you understand the underlying basics of how Git works, will you be able to troubleshoot a problem when you face it and when you are working in a company as a DevOps engineer. All right. So let us try to explain what Git basically is and how its architecture is. Now, most of you might know that Git is a distributed version control system. Now, what is a distributed version control system? Let us explain it using a diagram. In a distributed version control system, basically your repository it is distributed among the people who are contributing to that repository, and that is why it is called distributed. So that means that anyone who wants to make a change in the code that is present in this repository has to first copy this repository on his local system, commit the changes to the local file system of this repository, and only then he can push this repository onto the or push the code changes or the feature additions and everything to the remote repository, right? Nobody can work directly on the remote repository, and this is the main principle of how Git works, and that is the reason it is called a distributed version control system, right? If you were to talk about the life cycle as to what are the steps to implement if somebody wants to say upload or change some code present in our remote repository, so the first thing that they have to do is pull the repository from the remote system. Once they have pulled the repository, it becomes their local repository. Change whatever files they want to change, and then once they are done with the changes, they will have to do a git commit, or they'll have to commit the files to the local repository. Once the files have been committed, they will have to be pushed to the remote repository so that it becomes visible to anyone and everyone who will pull this project the next time. All right. This is how the whole Git architecture works. Now, I hope you guys understand what is the working of Git and what exactly is the architecture of Git. Moving forward, now let's talk about the next question, which says in Git, how can you revert a commit that has already been pushed and made public? Right? So basically you have done some changes in the code. You committed those changes to your local repository, and now you have also pushed the changes to the GitHub repository. Now, if you have a CI/CD pipeline in place, which basically means that the moment you commit to Git, it automatically takes the code and deploys it on a server. If that is the kind of configuration that you have done, then probably the code that you have pushed has also been deployed on a server. And that is when you come to a sense that the code is wrong, and you quickly have to change the code so that everything becomes working again, right? Now, this is a very hot fix, or this is a very quick fix that probably every DevOps engineer employs whenever there is a problem in the production server, right? So what is that quick fix? The quick fix basically says that whatever last commit was working perfectly, just roll back to that so that everything becomes normal until and unless you have fixed the new commit. That is basically the intention behind the revert procedure. Now, how can you implement the revert procedure? It can be implemented using the git revert command. And let me show you a quick demo of the git revert command so you know how you can implement it in a computer. All right. So this is my terminal, guys. Basically, I will SSH into an AWS server, and I'm in. So I have a GitHub repository that I have created for demo purposes. So like we discussed, the first stage in the lifecycle of Git is to clone the repository. So we'll just copy this address. So we'll just copy this address. 1 second. Yes. So we'll just copy this address, and then we'll come here and we'll type git clone and then the address. Okay. Now this project is basically a website that I created. It's a small website that I created. Now, in order to see that website, we will have to paste this code inside our Apache folder. So let us go inside an Apache folder, which is present in this directory. All right. Now I'll do a quick git clone along with the repository address, hit enter. And now if I do an ls, you can see that there is a folder called DevOps IQ, which has been created inside this folder. I will go inside DevOps IQ and do an ls. And you can see there's one more folder called DevOps IQ. All right, so let's go inside that. And now if I do an ls, these are the two files which are present inside my code base. Okay. Now, if you were to see what this website actually looks like right now, I can just go here and I can type in the IP address. So it's 18.222.123.58 slash DevOps IQ and slash DevOps IQ. All right. This is how the website looks like for now. Now I have to make some changes so that the background becomes a little more better. So what I can do, I'll just go back here. I'll go do a nano and change the code of the website and say I'll change it to, I have an image in the images folder. Let me change it to 1.jpg. All right, let us save it. And once you've saved it, the next thing that you have to do is commit the changes to your local repository. And let us do that. So first I'll have to add the files to the repository. Now I'll have to commit the changes. And the message should say changed background. All right. So the changes have been committed, and now I'll push these changes to the remote repository. So it's HSHAR and the password is this. Now before making these changes, let me quickly show you the code that you are currently going to see before I push anything on this repository. So can you see the code is images/2.jpeg. I've changed the code to be 1.jpeg. So let me hit enter and let's see if our code gets changed over here. So now if I do a refresh, let me do a refresh. You can see the code has been changed just now. So it says 44 seconds ago, the code was changed. Awesome. So now because my code has been changed, if I go to this website now and hit enter, you can see the background is now changed. It is now a different background. Now what I want to do is I realize that this change that I did is probably wrong, and I want to revert to a particular commit, to the older commit that was actually working. All right. So what I can do is I'll just come back to my terminal. Let me clear the screen. First thing that you do is do a git log. So now you get a log of all the commits that you have made to this particular repository. Now this is the particular commit that you have particularly applied right now, and this is causing you a problem. So just copy the commit ID for this.
Done.
And now just go ahead and do a git revert. So git revert and then give this ID which you just copied. Okay, and hit enter. So once you do that, it will tell you the information about this particular commit ID, right? So just review everything and then you can see that the commit has been reverted. So now I've not pushed the changes, but then if I come back here and if I hit enter, you can see the older website comes back because the code has now been changed. And if I want to make these changes to the remote repository as well, all I have to do is git push origin master, and it'll ask me the credentials, and the changes have been pushed, right? Now if I come here and I just see the code again, if I do a refresh, you can again see that the code has changed back to 2.jpeg, which was our earlier code which we made changes to. All right. So guys, this is how you can do a revert on basically a commit and a push that you have made to your remote repository as well, right? So if you encounter any problem during working, while working as a DevOps engineer, you should remember this session where I taught you how to revert a particular commit. All right. So with that, let's move on to our next question, which says, have you ever encountered failed deployments and how have you handled them? Now, see, any DevOps engineer in the world will have faced a problem in which, probably the things that he had planned, the things didn't go according to his plan, right? That absolutely happens. And if somebody is asking you in a DevOps interview, have you committed mistakes? So you should, just to impress them, probably never say yes, right? So if you have never committed mistakes, that's awesome, right? But then I know that every engineer or every DevOps engineer who has worked in the industry would have faced a problem while working and would basically account to a mistake that he made while deploying things. All right. Now, the important thing or the important key takeaway from this kind of a learning should be that whatever mistake you make, you learn from it, right? And you never commit it again. And that is basically the intent behind this question as well. The interviewer would want to know, if you made the mistakes, what did you learn from those mistakes? Okay. So if an interviewer was supposed to ask me this question, I'll say, obviously, I have encountered failed deployments, and what have I learned from them? I'll just give you the best practices that I think are viable for any DevOps engineer who is working in the industry. So the first thing that everyone should follow and should make it a thumb rule is that you should automate code testing. Not only does it save time, because now your tester does not have to wait for your developer to basically push the code and then check it. The developer can check it in real time because you have written a script for his for his application, and all the major tests which are to be done, which are pretty common, can be done using automated code testing, right? Now, like I said, it's not only for time saving, but also it removes the part where a human error can occur, right? So if you are working, if you are now, when you work with people commit mistakes. But if you can write a code which will basically test each and every functionality, that code will never make a mistake. And that is why you should always automate things as far as possible, right? So like in my example, what happened was that there was basically a commit to the repository, which was basically a feature addition, right? And the tester did not see all the functionalities, or forgot to see some of the functionalities that could impact the other components of my product. And because of that, when it got pushed onto production, basically disaster happened. Everything stopped working, right? And that was only because the testing did not happen properly, right? So for all the critical processes of your website or your product, you can basically create a code which will test that website. And basically that would basically close down most of the doors to mistakes. All right. The next thing is you should always use Docker for same environment, right? And this is basically the ideology behind DevOps, that these kind of problems where a developer used to work and a tester could not run his code on his computer, but the developer said that everything is working fine on his system. Docker basically solves that problem, right? So use Docker as much as you can for the same environment problem that you might face. Then we should always use microservices. Now, when you are working in a company, it could be that the product is in the legacy phase and hence it's on a monolith kind of a thing, but you should never encourage this kind of an architecture, right? Reason being, say you did a bad commit or you did a bad push on the production server, but it should not impact the other components of your product, right? If probably you have done something to search, and if it's a bad commit or a bad push, the only functionality that should be impacted should be your search functionality and not the other functionalities. And that is the sole reason behind why we should use microservices. That is, we should divide our application into different small products which we would deploy on servers, and these products should be independent of each other. When you talk about the monolithic architecture, all these components are coinciding with each other, have the dependency upon each other. But when you talk about a microservices kind of an architecture, you remove that dependency so as to, even if one component fails, it does not impact the whole application. Fourth point being, you should always overcome risks to avoid failures. Now, this basically means that if there is a code change, or if there is a feature addition which works sometimes and sometimes it does not, and you're not able to figure out why is exactly that thing happening, it is better to wait and troubleshoot it than to push it just to meet your dates, right? Because the latter can cause you a big problem in production when you're in a company like probably like Airtel, or in a company like Samsung or Ericsson, where their products, each second of their website's uptime brings in money, right? So if your website is down for 30 seconds, that could amount to a huge loss, and that would be on you, right? So for you to not face that kind of a situation, always be 100% sure before you make a change or a release onto the production server. All right. So this is the end to the domain of continuous development. Let's go ahead and now talk about virtualization and containerization. All right. So let's start with the first question of this domain, which says, what is the difference between virtualization and containerization? Now, this is a very important question, guys, because most of us get confused between virtualization and containerization. So let's see what are the differences between these two things. So virtualization is nothing but installing a new piece of operating system on top of a virtualized hardware. What does that mean? So basically, there are softwares like hypervisor or any other software which specializes in virtualizing hardware. So if you have a server which has around 64 gigs of RAM and 1000 TB of hard disk space, with a software like hypervisor, what you can do is you can take that space and divide it among multiple operating systems, right? You can deploy multiple operating systems on the same hardware by virtualizing the hardware so as to the operating system will feel. Let's say if you virtualize 1 GB of RAM from this whole system and say around 100 GB of storage, the operating system will think that, it only has 1 GB and 1 GB of RAM and 100 GB of storage space available to it. It cannot go beyond that. Reason being, it does not know of the hardware which is beyond or which is ahead of the hypervisor software. All right. So in virtualization, basically you have an hypervisor which sits on top of your operating system and virtualizes the hardware beneath it, right? Then you have a guest operating system. So basically, once you've virtualized the hardware, you install guest operating systems on top of that. For example, the best example for this would be VirtualBox, right? You install VirtualBox and then you can install operating systems on the VirtualBox with a given spec that you will decide, right? And once you've installed the guest operating systems, on top of that, there would be the binaries or the libraries that you probably would be downloading or that came with the operating system. And on top of that, you have the applications which would be running, right? So the key takeaway from virtualization should be that it's the whole operating system is installed from the kernel level to the application level. Everything is fresh, everything is new. Now let's talk about containerization. So the thing in containerization is that the host on top of host operating system, you install a software called the container engine. Now the container engine is just like any other software, like you have an hypervisor, you have a container engine. Now the container engine does not encourage installing a whole operating system. For example, if you want to run a container for Ubuntu on, say, a Mac machine, you can do that, right? It will basically, in that container, you will have basically the bare minimum libraries that amount to become the Ubuntu operating system minus the kernel, right? So in a container, you do not have a kernel. The kernel is always used of the host operating system. And this is the main difference between virtualization and containerization, that in virtualization, you have a separate kernel present of the virtual operating system. But in containerization, you do not have that. And that is the reason the containers are very small. They have the bare minimum libraries required for that container to behave as a particular operating system, but the container itself does not contain any operating system. It basically is based on the same kernel on which the host operating system resides. All right, and this is basically the main difference between virtualization and containerization. Moving forward, now the next question says, without using Docker, that is without using Docker to get into a container, can we see the processes that are running inside the container of the Docker container engine? All right. So this basically is relating to the same fact that if you want to see the processes of a container which are running inside the Docker container engine, if you can see them from the outside, basically that means that the processes are running in the same kernel of the host operating system, right? The processes that are running in the Docker container engine would be basically as an addition to whatever is running on the host operating system as well. And you can see that using the ps-aux command, right? So for the host operating system, it's just like any other software or any other process that it has to run. But for the container, it basically thinks that it is running inside an operating system, which it actually is not. Right? So can you see the processes? So the answer is yes, you can see the processes which are running inside a Docker container. And how can you see that? How can you basically see these processes? Let me demonstrate it to you. Okay. So we have come back to our AWS server. Let me clear the screen. All right. So if I do a Docker PS right now, you can see that there are no containers which are running on this system as of now. Now what I'll do is I'll run a container for Ubuntu. So I'll do a Docker run -it and then -d and then Ubuntu. All right, so this ran a container for me. And if I do a Docker PS now, you can see that there's a container running, which is basically of the Ubuntu image. So if I go inside this container now, so I'll do a docker exec -it and then bash. Docker exec -it and then I forgot the container ID. So the container ID and then bash. So if I do that, I'm inside the container, right? And there's no process running inside this container as of now. Now, if I were to duplicate this, let me quickly again do an SSH. So I'll do an SSH into the same server again so that I'm on $. Okay, great. So if I do a ps-aux, these are all the processes which are running inside the operating system right now, right? But let us make it a little simpler. What we can do is let me see all the processes which has the word watch in them, right? So let me make it more clear for you. So these are the processes which have the watch keyword inside of them, okay? So there are basically 4 processes which are running and which have the keyword watch inside of them. Now what I'm going to do is inside this container, I'm going to launch a watch process. So what is that watch process? That watch process is basically going to watch a particular command in a set interval of time. And what is that command? I basically want to say, let's see the ls-l command. Okay. So what is it doing? It is keeping a watch on the command ls-l in every 1 second, right? You can see the time over here. It is incrementing every second, and basically it's keeping a watch on all these files which are there inside the container continuously. Okay. Now again, so this is the $prompt that we are outside the container right now. Now if I again do the same command, that is again I search for processes which have the word watch in it, I can actually see that there is a new process which is running over here, and this process is running inside the container, which I'm able to see from the host operating system level, right? So the host operating system is basically treating this particular process as if it was running on its own system. That is, the container and the host operating system, because they are sharing the same kernel, the host operating system is taking this process as if it was running inside of it, right? But if we look closely, this watch command is running inside the container, right? Let me just quickly stop it. You can see we are still inside the container, and we have stopped the watch command. And if I go here and if I refresh, you can see that this watch command is again gone, which was being mentioned over here before. And this is exactly what we wanted. We basically wanted to see a process which was running inside a container from outside the container, that is from the host operating system, and that is exactly what we just did. All right. So the question that without using Docker, can you see the processes that are running inside a container? So the answer is yes, you can do it. All right. So the next question is, what is a Docker file used for? What do you basically use a Docker file for? So a Docker file is nothing but it's basically a text document to create an image using an older image and adding some files into it. All right. So it's basically like a script that you run in Linux, which can do all the things for you that are required. For example, I might need an Apache image, and I want my website to be put inside the var/www/html folder inside this particular Apache container. Now, in order to do that, if I were to do it without a Docker file, I would have to first download the Apache image. So I would probably type docker run -it-id and then Apache. Once I've done that, I will exec into the container and then go to the directory called var www.html. Probably I'll do a git clone of the website that I want, and then my website will be available in that container, and hence I'll be able to use it, right? This is one way. Second way is I can create a Docker file which will basically build this image for me without me having to do all these things, all these manual things which I just told you. All right. So let's see how we can do that. So let me just exit this container and let me remove the container which are just running inside my system right now. Okay. If I do a Docker PS now, it's clean. Now what I want to do is I want to run this particular container, docker run -it -p. I want to basically expose the port 83 to this container's port 80, and I want to run it as a daemon so that it runs in the background, and that is it. Okay, so I have the container running, which is this, and what I want to do is I want to basically copy the website into this container. So let me do a docker exec into this container -it. This is the container ID, and then container ID, and then bash. So I want to go inside this particular folder. So if I do an ls over here, you can see that there is an index.html and an index.php which are running, right? So it's on exposed on port 83, which basically means if I go to a browser And if I go to the server's IP address on port 83, I should be able to see this Apache page. And this is basically the container which I just ran over here. Okay. What I want to do is inside this particular directory, I would be basically copying the code of my website. Now let's see how we can do that. So let me just exit this container. Let me do a docker ps. Let me do a docker stop to this particular container. So what would this do? So basically, if my Apache was running over here, it should stop once I have stopped this container. Okay, so it's stopped. So if I do a refresh over here, you can see the site can't be reached. This is exactly what we want. Okay. Now, let me do a git clone of my GitHub. I'll do a git clone. All right. Awesome. Now I'll go inside this folder, and basically I want to copy this particular folder inside the container. All right. So for doing that, let's create a Docker file. And what I want to say is in the image shhar/web app, I want to add the folder DevOps IQ. And where do I want to add it? Inside the container, I want to add it in this particular directory. Okay. This is where I want to add it. And inside DevOps IQ. Okay, fair enough. And that is it. That is all you have to do. I'll just come out of this editor and I'll now do a Docker build of this Docker file with the name test. So it says successfully built an image and it has been tagged as test. Great. Now if I run this image now, docker run -it -p, say I run it on port 84, run it as a daemon and run the image. Okay, great. So if I go to port 84 now, let's see if the container is working first. So yes, the container is working. Now if I go inside DevOps IQ, what do I see? Great. So I can see the web. So basically my website is now available inside the container by simply writing a Docker file to do that. And this is exactly what we wanted. Awesome, guys. So what is the Docker file used for? It is basically used for creating an image without having to do all the manual stuff of adding your files and everything. All right. Now, once this image of yours is ready, you can push it to Docker Hub and anybody in the world can download it and can basically use your website on their local system. Great. Now, the next question is explain container orchestration. Okay, so till now we have seen that, we can deploy a container, we can use it, we can probably deploy an application on it, and we can use it on the web browser, right? But it is not that simple. When we talk about a website like Amazon or a website like Google, right? It has a lot of components with it. For example, on Amazon, you would see that you have a comment section. Then on the home page, you see that there are a lot of products which have the prices, the ratings. Now, each and every component, the prices, the ratings, the name of the product, the image of the product, the comment section, each and everything is basically a microservice. It is a small part of an application which is running independently of all the other parts of the website, right? And all of this is possible using containers. So basically what they would have done is they would have ran each and every component inside a container. Now, the problem over here is now when you have a website like Amazon, you would be dealing you would be dealing with minimum like 10 or 11 containers for one particular copy of that website or one particular instance of that website, right? Now, when you're dealing with 10, 11 containers, these containers have to be working in conjunction to each other. They should be in sync with each other. They should be able to communicate with each other, right? And they should also be able to, we should also be able to scale a particular container in case it goes down. For example, the comment section container, it goes down for some reason. Now, if it goes down, we have to keep a watch on it and we have to redeploy it if it goes down. And all of these activities, which I just told you, comes under container orchestration, right? If you were to manually deploy these containers on Docker, you will have to keep a manual check on all these containers. But imagine when you have thousands or 10,000s of containers that you're dealing with, in those kind of scenarios, you need container orchestration. Now, container orchestration can be done using various softwares. So you have a software called Kubernetes, and before that there was a software called Docker Swarm, which basically made our life easier by doing all the manual work for us. That is, it will check the container's health. It could scale them in case they become unhealthy. They could always also notify the administrators by an email in case something happens, right? They can also run a monitoring software for you, and which basically gives you a report or the health status of all the containers which are running inside that software. So this is a very small part of what a container orchestration tool can do, right? And basically, if you were to understand what container orchestration is like I said, when you work with multiple containers, you have to take in note a lot of things, and that is possible using the container orchestration tools like Kubernetes and Docker Swarm. Okay, so the next question is, what is the difference between Docker Swarm and Kubernetes? Now, they're both container orchestration tools. We just saw that. But why do we have two? Or if I were to choose between Kubernetes and Docker Swarm, which should I choose? All right, so let's look at the differences between each one of them. So the first difference, which is probably the most important difference, or probably I'll say is the deciding factor whether you should go ahead with this tool given that you have a short deadline and you have to deploy a project. So installing Docker Swarm is very easy. It comes pre-packaged with the Docker software. So if you have installed Docker Swarm is already installed on your system. You don't have to worry about anything. On the other hand, installing Kubernetes is a very tough job, right? There are a lot of dependencies for Kubernetes. You'll have to see the system. You'll have to see the operating system on which it is running, and a host of other things, right? It has a lot of dependencies, and hence it is very tough to install. But the moment you install it, it becomes very helpful. That is, Kubernetes becomes very helpful because of the features that it offers. Which brings us to our second point. Docker Swarm is faster than Kubernetes, reason being that it has less features than Kubernetes, and therefore making it a very light software and hence faster than Kubernetes. So if you want to use Docker Swarm, you should be reading about what Docker Swarm does not offer and what Kubernetes offers. And if you feel you do not need all the features that Kubernetes is offering, you can go ahead with Docker Swarm and deploy your application in a faster manner. But like I said, Kubernetes is complex and it has a lot of services and features, because of which its deployments are a little slower when we compare it to Docker Swarm. Third point, which is the most important point, is Docker Swarm does not give you the functionality of autoscaling. Meaning, if your containers go down or if your containers are basically performing at their peak capacity, there is no option in Docker Swarm to scale those containers. On the other hand, because of Kubernetes monitoring services and the host of other features, you have that option of providing auto scaling to your containers, which basically means you can automatically scale your containers up and down as and when they are required. And this is an amazing thing that Kubernetes handles for us. All right, guys. So these were the questions around the domain virtualization and containerization. So moving ahead, now our next domain is continuous integration. So let's shed a light on what continuous integration is. So our first question itself is, what is continuous integration? So continuous integration is basically a development practice, or I'll say it's a stage which basically connects all the other stages of the DevOps lifecycle. For example, you push your code to Git. Like we took that example, when you push the code to Git, you might have provisions which might allow you that the moment the code is pushed onto the remote repository, it automatically gets deployed on the servers as well. Well, if that is the case, basically that would be possible using integration tools that would integrate your Git repository with your remote server. And that is exactly what Jenkins does. It's a continuous integration tool which helps us integrate different DevOps lifecycle stages together so that they work like an organism, right? This is what continuous integration means. So, because we discussed about what continuous integration is, our next question says create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So on every push that you make to the remote repository, the code should automatically get deployed on a remote server. All right. So this is something that we're going to do just now. All right. But before going ahead, let's see what is the architecture for this kind of a thing. All right, so this is how the whole thing is going to work. Basically, the developer is going to commit the code to his GitHub. GitHub basically, once it sees a change in the branch that we mentioned, it is going to trigger Jenkins, which in turn will integrate or will take the website from the GitHub repository and push it onto the build server on which we want the website to be deployed. All right, sounds awesome. Great. Now let's go ahead and do this demo. So for that, we will have to SSH into our server. So let us do that. Okay, so I'm in now. Let me clear the screen. So first, let's check if our Jenkins is running on this server. So let me check the status for Jenkins. So if I do a service Jenkins status, I can see that the Jenkins service is active. Awesome. So I'll just go here and I'll go to the Jenkins website, which is basically available on 8080. All right. So I'll enter my credentials. And this is how the dashboard for Jenkins looks like. Now, our question is, or our aim is to create a job which basically will push a website that we are uploading to GitHub on a particular server. All right, so let's create a new job first. So let's call our job as a demo job. Okay, and let's name it as a freestyle project and click OK. So this will create a job in Jenkins for us. All right, so our job has now been created. So what we want to do is I want to take code from my GitHub. So I'll have to specify the GitHub repository over here. Okay. And similarly, I will have to say that I want to trigger the build the moment anything is pushed on my remote repository, right? And this should be it. Great. So I mentioned that anything that is pushed onto my master should trigger a build on Jenkins. Okay. And what should this build, or what set of commands do I want to run once build is triggered? So first I want to remove all the containers which are running inside my system. So I want to clean up, right? So for that I'll say sudo docker rm-f, then a $, this basically is going to clean all the containers which are running currently in the system. Once this is done, I want to build my website, which is going, or build my container, which is going to have my website. All right, now how can we do that? For that, I'll have to push the code to my GitHub, which will have the Docker file as well. Okay, so we created a Docker file inside Okay, so here it is. So we have our Docker file created in the DevOps IQ folder, which was there in my home directory. Now what I want to do is I want to push. So what is there inside this Docker file? We saw that we could create a Docker file using, if we write something like this in our Docker file, and this would basically create an image with our code which is there on GitHub. All right. So what we'll do, we'll just push this code to our remote repository. And let's add the message that we have ordered a Docker file. Great. And now let's push it to our remote repo. Great. So it has been pushed to my remote repo. And now if I just go here and check if my changes have been done or not, let me just quickly refresh it. So yes, I have a Docker file in my Git repository right now, which was committed 42 seconds ago. Awesome. Great. So now what I'll do is I'll come to my Jenkins and I will say that build sudo docker build the Docker file. Now, where is that Docker file? The Docker file will basically be downloaded in the Jenkins workspace. So that is in var lib Jenkins workspace, and then the name of the job, which is demo job. And that is it. So inside this, I will have my Docker file, and it will basically build it and name it as, say, Jenkins. It'll name it as Jenkins. In the next step, what I'll do a sudo docker run -it and then -p and say I want to deploy it on 84 or say 87 port.
Right.
Okay. And what do I want to deploy? I want to deploy Jenkins. Okay. So this should do this should basically do all the stuff. So in the first command, basically, we're removing any container which is running on the system. In the second command, what we're going to do is we're going to build the Docker file which is available in this workspace. And this workspace will basically have my GitHub project and the link I have specified over here. So it'll basically just copy, or it'll pull the project and save it in the workspace of demo job. So in this demo job, there's a Docker file. So we're building this Docker file and we're naming this created image as Jenkins. and then we are running this image and exposing it to port 87. Okay, so let's save it. Awesome. Now what we have to do is I'll have to go inside. So if you want to configure a webhook, the way to do that, when I say a webhook, basically you want your GitHub to interact with your Jenkins whenever there is a push to a particular repository. So in your repository, go to settings and then go to webhooks. So this is a webhook that I created for my Jenkins, right? So let me create it again for you. So all you have to do is click on add webhook, right? And enter the URL for your Jenkins over here. So in my case, it is this. I'll just enter it over here, followed by this keyword, which is GitHub hyphen webhook. And that is it. Once you specify that, just go down, click on add webhook. And this should basically send a request to Jenkins. And if everything goes well, it will say last delivery was successful. Okay. So any changes that I make to my GitHub now should trigger a change over here. Now let me delete this job, because I think even this job gets triggered when my GitHub, any changes made to my GitHub, right? So let me delete this project. Okay, great. So I just have this job now. Awesome. Now let us see how it actually works. So what I want to do is I'll come back to my terminal, do an ls, and let me go inside DevOps IQ, and let me do some changes in the code. So let's say I go into nanoindex.html. So the first thing that I do is I change the title of the website. So I call it as Jenkins test website. Okay. And I change the image from 2 to 1.jpg. And that is it. Let us see if I just push, or if I just push this website onto my server, what will happen. So I'll do a git push. Sorry, first I have to add these changed files into my repository. Git push origin master. Sorry, git commit, and let me label this commit as test push. Okay, done. Now let's push this to our remote repository. Git push origin master, and let's give the credentials. Awesome. Now if you wait here, it should basically start a job. So as you can see, there is a job queued, which is for demo job, and this got automatically triggered by my GitHub. Okay, so let me refresh this. Okay, so the moment it gives you a red, that basically means that your job has been failed. So let's see what had just happened, why our job got failed. So if you go here, you can see the console output with just like this. Okay, so basically we forgot to add a sudo here, and that is causing us a problem. Okay, so we can fix this by just going down and adding a sudo here. Save it. And again, we'll have to change the code. Let's call it as Jenkins test 2 website. We'll do a control X, Y. And now let's add our files to our local repository. Git add. Now let's commit it. Test push 2. And now let's push this to our master. I'll enter the credentials. And this should be it. Okay, so let's see. So our second job got triggered automatically and it gives us a blue. Now, blue means that your job was executed successfully. So let's check what happened. So we were deploying it on port 85. So let's check if it has been indeed deployed. So it was on port 85 and the folder was DevOps IQ. Okay, so let's check. I'm not sure if it was port 85. Let's check. Or the port that we have specified. So the port is 87. Okay, so let's go to port 87. Okay, so it's giving an error saying unsafe port. So for our troubleshooting, let's check if the container is running. So yes, the container is running on port 87, but it says an unsafe port. So what we can do is let us change it to say 82. And now let's just try to build the job from here. We just click on build now. Job has been completed and the port was 82. Yes, so Apache is working. Now let's try going inside DevOps IQ folder. And there you go. You have your website with this title which you pushed on GitHub. Now for one more time for testing purposes, let us push our code once more and see what happens. So I'll say that this website is test3 website and say I'll change the image as well to 2.jpeg. Okay, save it, do a git add, do a commit and say call it test push 3. And now let's git push origin master. Enter the credentials. Great. Now let's check what will happen. Okay, so our build has been started and it has been completed. Great. So if I refresh this now, it says Jenkins test 3 website and the background also has been changed. So congratulations guys, we have successfully completed the demo. So basically if you change anything in your GitHub, the website is automatically getting deployed on your build server, right? And on top of this, just for making it more interesting, what we can do is we can do a git log and we can revert on this commit that we saw earlier. Okay, so let's do a git revert and then paste it, agree to everything, and then push to master. Enter the credentials. Everything has been pushed. Job is getting triggered. Job is completed. And if I go here again, my website got reverted to a particular previous version. Awesome guys. So we have completed the demo, which basically asked us to create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So you've done it successfully. Awesome. Let's move on to our next domain, which talks about configuration management and continuous monitoring. Awesome. So what is configuration management and what is continuous monitoring? Let's understand it. So what is the difference between Ansible, Chef, and Puppet? Now, before understanding the difference between Ansible, Chef, and Puppet, these are basically configuration management tools. What is configuration management? If you have, say, around 200 servers and you want to install a particular software on each of these servers, what will you do? One way what you can do is you can basically go to each and every of these servers, run a script, and that basically will install software on that on these servers, right? The other way to do it is install a configuration management software using which you can deploy or you can install all these softwares, or you can control the configuration of all these servers from one central place. And that is exactly what configuration management means, right? Now, in configuration management, you have many tools like Ansible, Chef, Puppet, etc. But these are the three top tools which are used in the industry. Now, the question is, what is the difference between Ansible, Chef, and Puppet? All right, so let's go ahead and see the differences. All right, so let's first talk about Ansible. So Ansible is very easy to learn because it is based on Python. So you don't have to sweat a lot, or you don't have to sweat much on learning the commands for Ansible because it is based on Python. So if you know Python, Ansible is going to be a cakewalk for you. It is preferred for environments which are designed to scale rapidly. Basically, with Ansible, the thing is that you don't have to install the Ansible client software on the systems on which you want to basically deploy the configuration. Ansible just has to be installed on the master, and that is it. No other configuration required. You can directly control the configuration of the client server given you have the access to it. So it offers simplified orchestration, reason being, like I just told you, that you don't have to worry about installing softwares on the client machines. Ansible can standalone take care of all the complications that come forward when you are dealing with deploying configurations without installing a particular software on the client machines. But this is basically a disadvantage of Ansible, that it has a very underdeveloped GUI. That is, you only get the CLI to work with, right? And it has very limited features when we compare it with Puppet and Chef. Now let's talk about Chef. How is Chef different from Ansible? So it is Ruby based and hence it's difficult to learn. Now Ruby is a language that not many people are acquainted with, and hence people might find it difficult to get versed with the commands of Chef. The initial setup is complicated. When I compare it with Ansible, the setup was very easy because I just had to install Ansible on the host machine, and on the client machine I didn't have to install any software. So, but with Chef you have to do that, and hence it becomes a little complicated. But once all the setup and everything is done, Chef is very stable, right? It has been, since it's a community product and it has been well contributed to, it's a very stable product and it offers you resiliency. So of course, when you're working on production servers, probably working on Chef would be a better idea than Ansible, because Ansible does not have that great community when you compare it with Chef. And of course, Chef is the most flexible solutions for OS and middleware management. Now, middleware basically means the software management part. Chef offers to be a great choice for configuration management. Reason being, it is very reliable and is very mature, because it was probably among the first configuration management tools to come out. And because community has contributed a lot to this project, it is very mature in its development stages as well. Now let's talk about Puppet. So Puppet can be tough for people who are beginners in the DevOps world, right? Because it uses its own language called Puppet DSL, right? The setup part is smooth when you compare it with Chef, but it's a little harder than Ansible, because when you're using Puppet, we use a master and an agent as well. So you will have to install Puppet agent on the client machine, and only then Puppet will be able to interact with the client software, right? Now it has a strong support for automation. So if you're planning to do some configuration management that you want to automate, Puppet is very compliant in that part. You can easily do the automation part using Puppet, and it is not suitable for scaling any deployment. So if you have say around 50 or 60 servers and you plan to add more in the future, probably Puppet would not be the right choice for that kind of an architecture. It is good to have when you have a stable infrastructure where you're probably not adding servers now and then. But if you are working on cloud and you do not know the capacity that you would be running, probably Puppet would not be a good idea to manage your configuration on your clients. Okay. Our next question is, what is the difference between asset management and configuration management? So asset management basically deals with resources. It deals with hardware, which we'll have to plan so that our IT workforce can work with maximum efficiency, right? So we'll have to plan the planning of your hardware, of how many resources a particular team might need. Giving the right resources to the right people is what asset management counts in. When we talk about configuration management, it basically employs not the hardware but the software component of what all softwares are required by a particular employee of a team or a particular person in the team, what softwares are required by that person, and for other person what software is required. I mean, rather than taking the radical approach of installing every software in every machine, which should not be done because some softwares are licensed. So configuration management basically means installing the right software on the right system on which a particular person or on which a particular workload is going to run. So our next question is, what are NRPE plugins in Nagios? Okay, so NRPE plugins are basically extensions to Nagios which help you monitor the local resources of the client machines, right? So you don't have to SSH into the client machines to see how much of memory or how much of CPU is being used. Nagios being a monitoring tool, you just have to install and the NRPE extension on the client machine, and it will give you a real-time data of the resources that are being consumed on that particular client machine. And obviously, when you're working in production environment, you will be monitoring multiple machines, and with the NRPE plugins installed on each of those machines, you can easily monitor the resources of them at one central place. And that is exactly what NRPE plugin is. Our next question is, what is the difference between an active check and a passive check in Nagios? Okay, so in Nagios, if the data, the monitoring log that you're getting from your clients, if it's being delivered by a Nagios agent, in that case, it is called an active check. Reason being, Nagios is actively involved in taking all the data or in collecting all the data from your clients. But in case when you're dealing with systems wherein it does not allow you to install any other software, or probably the software itself can generate monitoring logs, in those cases, what happens is rather than Nagios, the software component pushes the logs to the Nagios master, where it can take the logs and probably create a graph or create the metric for you in the dashboard. So basically, using those logs which are being published by some other software, Nagios will create a report of the health monitoring part of your client systems, right? And that is why it is called a passive check. Reason being, Nagios is not involved on the client side at all. It is basically the software's own services which are basically pushing the log to Nagios master, and hence it's called a passive check. All right. But if you talk about the architecture or the working or the life cycle of how this actually works, on the master itself, the logs which are published are actually published to a queue, right? And whether it's an active check or a passive check, the logs have to be published to that queue so that the Nagios master can pick them up and create the monitoring metric which is required. All right. So in a passive check and in an active check, the queue is going to be there, but it's only difference between the agents. That is, in an active check, the Nagios agents are involved, but in a passive check, third-party software tools are involved, which publish the log to the Nagios master. All right. So our next question says create an Ansible playbook to deploy Apache on a client server. So basically, we have to do configuration management. So as to without, going inside the client system, we'll have to install a particular piece of software inside it. Okay. So let me quickly do an SSH into my AWS machine. And what I'm going to do is I have a slave machine which I've already configured, which can interact with my master. That is, if I do a Ansible ping all, you can see that there is a server 1 that I have configured, which has successfully responded to my master's request. Okay. Now let me show you the server, which is basically working. So this is the server which is configured with my master, right? This is my client machine, and on this machine I'll have to install Apache. So if I right now go to the IP address of this machine, it says connection refused. Reason being that there is nothing installed on this server, or there is no Apache software installed on this particular server right now. All right, so let's install Apache. Now to do that, you will have to write a playbook. Now, what is a playbook? A playbook looks something like this. So it's basically a YAML file that you'll have to create. So I have created one for me. So where do you want to install the Apache software is the part where you'll have to specify in hosts. So basically my client machine is a part of a group called servers that I've created, right? So the hosts are servers, and where can you actually specify what part is your machine, or which group is your machine a part of? So that you can specify over here. So it's in /etc/Ansible and /hosts. Okay. So as you can see over here, this is the group name, that is servers, and inside servers I've specified a server 1 client machine which has the IP address this. So this is the IP address of my slave. So if you can compare, it's 18.223.101.172, and if I compare it with my slave, this is the IP address of my slave, right? And this has been configured over here. So I can refer to my server 1 as servers, or I can refer it to as server 1, right? So if I do, let me do a clear over here. I can say Ansible -m ping, and I can say server 1 as well. It will reach out to my server 1, or I can say servers as well, because it's part of the group servers. Okay, so this is how it works. Now I want to install Apache. So for installing Apache, I'll have to write a playbook which looks like this. Basically, it's a YAML file. So you start with the 3 dashed lines, and then you specify hosts. So hosts, I've specified every server, every machine which is inside the servers group should install Apache on it, right? And what is the task? I want to install Apache 2. This is basically a name. You can specify anything over here. Then I've specified apt. Basically, I want to use the apt package to install Apache 2, the latest software. Okay. Now, what I will do, I will type in Ansible -playbook, and I'll type in apache.yaml. I'll hit enter, and now it has started to install everything. So it is installing on the servers group, It is gathering the facts, and it saw that it is able to communicate with server 1, and now it is accomplishing the task of installing Apache. All right, so it has been done successfully. So if I go to my Chrome browser now, and if I refresh the address, you can see that Apache is installed on this server automatically. So I didn't have to basically SSH into the server. It all happened automatically. And if I had like 5-6 computers which were running on AWS, and if I wanted to install the software on it using Apache, using Ansible, this would have been the same way. It's only that in the server group, I would have specified more IP addresses which my Ansible could talk to. Okay, so this was our task of basically deploying an Ansible playbook on a client server without SSH, doing an SSH into that client server and doing it from a central location. All right, so this is done. Now let's move on to our next domain, which is continuous testing. Now, what is continuous testing? So we talked about continuous development, which is done using GitHub. We talked about continuous integration, which is possible using Jenkins. We talked about continuous configuration management, which can be done using Ansible. And next online is we have continuous testing. So once the code has been deployed, it has been integrated with Jenkins, it has been deployed on a server. The next thing is automated testing that we discussed in the best practices before, right? And it can be done using a tool called Selenium, a software called Selenium WebDriver, right? So the first question is, list out the technical challenges with Selenium. So the Selenium tool is used widely for automatic testing or automated testing, but what are the problems that you get with Selenium? So if you're using Selenium, mobile testing cannot be done. So if you have developed an application for your mobile, you cannot test it using Selenium. The reporting capabilities of Selenium are very limited. If your application or your web application deals with pop-up windows or it gives pop-up windows, Selenium would not be able to recognize those pop-up windows and work on them. And again, Selenium is only limited to web applications. So if you have an application that probably runs on desktop, probably it's a software that you have designed, you cannot test that software using Selenium. Selenium is only for those applications which can run inside a browser. And if you want to check whether there is some image in your web page and that image should have some particular content, it is a little difficult to implement it in Selenium. Although it is not impossible, it is possible. You'll have to import some libraries and other things like that. But natively, Selenium does not support image testing. You'll have to work around. You'll have to work around with Selenium to import some libraries which could do it for you. But like I said, natively, Selenium does not support image testing. So our next question is, what is the difference between verify and assert commands? So let us see the differences. So if you're using assert in Selenium, if the command fails, the whole execution comes to a halt. Whereas in verify, it does not come to a halt. It keeps on continuing the rest of the lines which are written in the code. Now, how can it be helpful? How is it helpful to basically put execution at halt whenever there is an error which occurs for a particular line? It is helpful when you're dealing with critical cases. Like for example, if there are 5 cases and say if case 3 fails, case 4 and 5 cannot execute because they have a dependency on case 3. In those cases, I would say that you would have to use assert with the case 3. But in the same example, if you talk about case 1 and case 2, they do not have a dependency or they do not create a dependency for any other test cases that have to run, right? For example, case 3, case 4, case 5 are not dependent on case 1 and case 2. In those cases, we can run the verify command, which will not stop even if the test case fails, right? And this basically is done to basically see what all is working and what all is not in one shot in a testing program. And for those cases, you would use verify. But in the cases where you are testing critical cases and you do not want to waste your time testing other things, if one of your case fails, in those cases you will use the assert test. So like I said, it is used to validate critical functionality, assert command, and verify is used to validate functionality which is of the normal behavior kind of scenario, which comes into the normal behavior. That is, it does not create a dependency for other things to not work because it stopped working.
Okay.
All right. So our next question is, what is the difference between set speed and sleep methods? So set speed is basically used for executing tasks at a particular interval that we specify. For example, say I want to echo hello world at intervals of 5 seconds. In that case, I can specify it using set speed. But sleep method basically suspends the execution of the whole program for a particular interval. For example, if you're doing a Selenium web test and the web page takes around 3 seconds to load, and you don't want testing to happen just after each line, you can specify a sleep method of say around 3 seconds, where it waits for 3 seconds for the website to load, and only then it will start executing the tests which follow that particular line. All right. So this is the difference between set speed and sleep.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world, and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.